Dave Gray is one of the more popular instructors we've featured on our channel, and now he's back with a beginner's Python course. This course is perfect for everyone who wants to learn Python. This course has some things that make it stand out over other Python courses. For one, it has a bunch of small projects that you will build along the way that will help you really grasp the key features of Python. Also, it's organized like a video textbook with 23 clearly defined chapters. Finally, the course stands out with the clear and expert teaching of Dave Gray. So get ready to learn Python.
Hello and welcome to nearly 9 hours of Python tutorials and instruction for beginners. This video is made up of 23 tutorials that build upon each other much like the chapters of a book. Throughout the lessons in this video, I will mention links being available in the description below. I've compiled all of these links into one GitHub resource that you will find in the description. Hi, I'm Dave Gray, and I'm the creator of these Python tutorials for beginners. You can subscribe to my YouTube channel for more tutorials like this one. You can also follow me on Twitter, and if you're feeling generous, you can even buy me a cup of coffee. A quick thank you to Bo at freeCodeCamp for sharing this video, and to everyone at freeCodeCamp for providing such an outstanding resource that helps people learn how to code for free. It's truly my honor to contribute this video. Let's get started learning Python with Chapter 1. Python is a great first programming language to learn, but if you already know another programming language like JavaScript, Python is still a great addition to your resume. Congratulations on your decision to learn Python. It's a great first or additional programming language to learn, but don't take my word for it. I asked ChatGPT why anyone should learn Python, and here's what it had to say. Python is easy to learn and use. It has a simple and straightforward syntax, and it's an excellent language for beginners. Versatility. Python is a versatile language, and it's used in a wide range of applications, from web development to scientific computing and data analysis. A large and active community. Python has a large and active community of users and developers, and there's a lot of resources and support available for you. Good for rapid prototyping. Python's simplicity and ease of use make it an excellent choice for rapid prototyping and job opportunities. As one of the most popular programming languages, Python's in high demand in the job market. Top 5 reasons, essentially, that Python is a good programming language to learn and add to your resume. And we need to start with the right tools. So go to python.org, which you should see here in my URL bar, and from there we can download Python. So there is a Downloads tab, and when you mouse over, it should show you the current download for your operating system. As you see, I'm on Windows here, and it says we are currently at Python 3.11.2. Of course, if you're watching this in the future, there may be a newer version. Now, if you're not on Windows, you can also choose Mac OS or other platforms over here. And note here, it says Windows. Note that Python 3.9 Plus cannot be used on Windows 7 or earlier. So if you're using Windows 7 or earlier, maybe you need to go to this Windows link and find an older version of Python to run, which should still allow you to complete this Python tutorial. So for now, click on the download for your operating system, download and install Python, and then come back to the video. Now that you've got Python downloaded and installed, we're going to install a code editor. And there are many different ones to choose from. My choice is Visual Studio Code, and I'm going to use it throughout the following Python lessons as I build the course. So to follow along with me, I recommend that you download and install Visual Studio Code for your operating system. Again, the website should identify which platform you're on, Windows, Mac, Linux, etc. And I'm at code.visualstudio.com, and then download the version for your operating system and install that. After you install, go ahead and open Visual Studio Code and then come back to the video. And now with Visual Studio Code open on your machine, you should see some type of welcome screen like I have here. You can go ahead and click the X to close that. We won't need that. But afterwards, we need to install the Python extension for Visual Studio Code. Now, on the left hand, we see the activity bar, and we need to click the extensions icon right over here on the left. So I'm going to click that, and then I'm going to search for Python, and we should see Python from Microsoft. If you click on that, you can see Python, IntelliSense, linting, debugging, and other things that are available. Now, I've already installed this extension, so I have uninstall and disable. You will need to go ahead and click install. That should show up here where I have uninstall, and install this extension for Visual Studio Code. It should not take long at all. After you do that, you can go ahead and close out of this. You can click the File Explorer icon over here just to show the file tree again for whatever folder that you currently have Visual Studio Code open in. I should mention that I created a folder. You can see I have Lesson 1 as the name of my folder, and there are currently no files in it whatsoever. So my Visual Studio Code is empty. My folder is empty over here. Now in Visual Studio Code, we're going to open the command palette. And to do that, I'm going to press Control, Shift, and the letter P. If you're using a Mac, when I say Control, you probably need to press Command. So either Command Shift and the letter P or Control Shift and the letter P. And that will open a command palette. And you can see my top choice says Python Select Interpreter. That may not be your top choice, so you can just start by typing the word Python and seeing all of the different commands that come up. And you could type all of this out, or you could scroll through and find the Select Interpreter. And once you do that, it's going to show the version of Python that you currently have installed. You can see I have Python 3.11.2, 64-bit, and I'm just going to select that. Once I've made that selection, I can then open a terminal window, and there's a terminal menu here at the top. When I click that, you can go to New Terminal, or you can also just use the shortcut, which is what I usually do. A new terminal is Control Shift and the backtick, or just Control backtick to open a terminal that may not be new. Say if you already had it open, say I could type something here like my name, which won't really amount to anything. If I were to try to run my name, for example, that wouldn't work. But if I close it and then press Control and backtick, it opens up the same terminal, not a new terminal. So that is the difference. Control and backtick opens an existing terminal if one exists, and Control Shift backtick opens a new terminal. And you can have more than one terminal. If you click this plus button here, you can see now I've got two terminals open. Mine says Bash because that is my default terminal. However, you might have other choices. On Windows, there's PowerShell, there's a command prompt. I'm using Git Bash. If you don't have that installed, that's okay. You can use a command prompt, and now I have a command prompt terminal window open, and you can see the difference over here. One's named Command, and one's named Bash. So either would work, and on Mac or Linux, it could be different for you as well. But now we need to verify our Python installation. So on Windows, I'm going to type py, just py, -3, and then -- version. Now that's for Windows. If I'm on Mac or Linux, I need to type Python 3, then -- version. And that would work on Mac or Linux. And then you press enter. So I'm going to go back to what I need to type for Windows. Just keep that in mind. Anytime you see me type py on the command line like I am now, if you're on Mac or Linux, you need to type Python 3. So it could be just a little different. Now I'm going to type -- version and press enter. And it gives us the version of Python that we currently have installed. I have Python 3.11.2. Now we can drag this window for a little more room also, so I'll drag this up to make this command prompt or terminal, because I'm not really using a command prompt, I'm in Git Bash, but whichever terminal window you have open, you can make bigger by dragging it like I just did. Now I'm just going to type py. Once again, on Mac and Linux, type Python 3 instead. But now I'll just press enter with nothing after that. And now you can see we have something different here. We can actually run Python commands right here at this prompt. You see the 3 arrows. This is the Python REPL, and that stands for Read, Evaluate, Print, Loop. And we can just put in a command. Python, for example, can be a calculator. So I can press 2 + 2, press enter, and it outputs 4. I can also do something with a string, like my name, which I had typed earlier. But let's do this. I'll say name equals Dave. And now I'll press enter. Notice there's nothing output currently, but if I type name, it's going to output my name. We assigned the string Dave to a variable called name. And so then when we typed name, it output the string Dave. Now it's good to know that we can run commands at the prompt like this, But this is not how we're usually going to provide commands to the interpreter. We are going to do that with files. And essentially creating a file is a bunch of commands put into one file that we tell Python to execute. Now, Python is not a low-level language, and a low-level language is more machine-oriented. Instead, Python's a high-level language, and it uses an interpreter. And this allows us to write code which is easier for people to read. So in other words, Python is more user-friendly to read and to write. So for example, when I want to get out of this, I'm just going to type quit, and I need to put parentheses after and press enter. And now we have quit our REPL environment, and we're just back to our normal prompt here. Now there are several ways to close this terminal window. Previously you saw me click the X. That works. And then if I wanted to reopen it and still have this here, I could do that with control and backtick. However, I could click the trash can, and then that will get rid of this window, and if I were to open it, this stuff wouldn't be here any longer. So I'm just going to click X in case I want to bring that back up. So I mentioned creating a file, and we can do that a couple of ways in Visual Studio Code. One would be to go over here to this file tree that we see on the left and click the plus button by the file icon. That would create a new file, and then we could name it. I can also just press Control N for a shortcut, and that starts a new file, which is what I'm going to do now. And then I'm going to say something like greeting equals, and I'll put hello world, because that's something just traditional that you have to have anytime you're learning a new programming language. And after that, then I'm going to say print, and then I'm going to pass in that greeting variable that we created above on the previous line. Now notice this file is untitled, and it has a dot here, meaning we haven't saved this yet. So I'm going to press Control S. I could go to the File menu, and from there I could also choose Save or Save As. I'm just going to do Control S, and it's still going to ask me what to name the file, and I'm going to save it in my Lesson 1 folder. So I'm going to name this Hello, and then I want it to end with the .py extension. Right now it says save as type plain text. That is not what I want. I want to find the Python extensions here inside of the file types and make sure I'm saving as type Python, which you can see it can have different types. I'm using the .py. So I'll click save. Now I've saved my Python file type, hello.py. And you can see Visual Studio Code now acknowledges this is a Python file type, and it is color-coded part of the code. So the string has a different color, and the command here for print has a different color. The parentheses are also in a different color, so it makes it a little easier to read the code. And now that we've created this file, we can run this command or commands, whatever we would have in the file, we can tell Python to execute in 3 different ways. One is to go to this play button that we see over here in the top right of Visual Studio Code. Now there's a little caret here that I'm going to click, and it gives us a drop down. I'm going to choose Run Python File, and when I do that, it opens up this terminal window. Notice it's named Python over here now. It's not the one we had previously named Bash, so I just clicked the trash can to get rid of that. But here is what it ran when we told it to run the file. It put this command, and this said exactly where the Python executable is. And then after that, we have this other long string here that says exactly where the hello.py file is. And then we get the output from that file that says hello world. Now, if we were to run this file ourselves, we would not have to type all of this. Although we could copy and paste this in, we can use a shortcut or two for this. One, we already know that we can just call Python in Windows with py. Again, Mac and Linux, type Python 3. After that, a space, and since we're already in this Lesson 1 directory that I have, or folder, you could call it, I said directory, but it's the same thing. If you've created a folder with a different name, you would be in that folder. So if you're already in that folder and you see your file over here, I can just type in hello.py, and now we're telling Python to run that hello file that will accomplish the same thing that we saw executed above when we used the play button up above. So now I'm going to press enter, and we get the same output, hello world. Also, we could go to the file tree and right click. I believe in Mac that would be a command click, and then we scroll down here and we find run current or run Python file in terminal. So I'll select that, and it runs it again, just like when we did the play button. So you see these extra commands. So 3 different ways to run our Python file. So congratulations again on getting started with Python. You've created your first file. You've got it all set up on your computer, and we've got much more to learn ahead. In the previous tutorial, we set up our Python programming environment in Visual Studio Code, and today we're going to learn the basics of the Python programming language. Let's start by opening a terminal in Visual Studio Code. Now, you can do that in a couple of ways. You can go to the menus at the top, and if your terminal menu is not showing, click the 3 dots, and then choose Terminal, and then New Terminal. Otherwise, you can just use a shortcut, which is Control and backtick in Windows. In Mac, it's probably Command and backtick. But either way, we now have a terminal window open. And if you remember from the last lesson, we can start the Python REPL by typing py, just for pi, and this is in Windows. If you're in Mac and Linux, you need to type Python 3, and then that will start the Python REPL. So I'm just going to type pi and press enter, and now I am at the Python REPL. So let's start today by discussing variables. And you saw a variable in the previous lesson when I took name, and that is a variable, and then I assigned a value to name, and I just assigned my name. So when I press enter, nothing happens, but now the variable name holds the value Dave, which is a string. So if I type name and press enter, it returns the value, which is the string Dave. Now, variable names can be made up of letters, just like name is, or it could be made up of numbers or a mixture of the two, or even use the underscore character. So I could say name 0001 and set that equal to Dave and press enter, and we have no problem. I could also use underscore name and set that equal to Dave, and we still have no problem. However, there are some things we cannot use in variable names. Other characters, for example. So if I said name exclamation mark, set that equal to Dave, and press enter, Python tells us that's a syntax error. So we cannot use that, and it highlights the problem character as we see right here. Also, we could say name dash first. Maybe I wanted to use that for a variable name. But the hyphen is a problem, and we see that issue as well. And now, of course, it tells us the whole thing is a problem, really. So that won't work either. It says maybe we meant to use double equals, which is something we'll get to later when we cover operators. But we can't use the hyphen in a variable name either. So maybe we decide to put the numbers first and then name. And we really can't start a variable name with numbers either. So once again, we have a syntax error. This mentions leading zeros, but it doesn't just have to be leading zeros. I could just say one name and try to set that equal to Dave, and we still have a syntax error. So again, we can use letters and numbers and even underscores. Now we cannot start a variable name with numbers though, and we can't use any other characters either. So we do have some limitations. Now, one other thing to consider is there are some reserved keywords that Python uses for other things, and we cannot use those. But no worries, you don't have to memorize them. Python will let you know, just like it did here with the syntax error, if we're trying to use a reserved keyword. So if I took the word if and tried to assign that to Dave, we're going to have a problem as well, because here it doesn't point at if, it points at the assignment operator here, the equal sign. We cannot use the keyword if. And the same for some other keywords like for. That is also a reserved word, so I'll type for equals, let's set for equal to Dave. And once again, Python has an issue with that because for is a reserved keyword as well. Okay, let's look at expressions versus statements. Now, you've seen me type an expression before, like 2 plus 2. That's an expression. When I press enter, it returns the output of 4. Likewise, I could type in a string, and let me just use the word expression and surround that in quotes, press enter, and it returns the value of the string, which is also expression. These are expressions, in contrast to statements that perform operations on values. So now let's use a statement, and I'll just say my name equals Dave. Here we're assigning the value of Dave, and it's a string value. We're assigning that to the variable my name. So that's a statement. I'll press enter, and now I can just type my name, and it's going to return the value of Dave. So we want to create a Python file, and put statements inside of that file so it executes as a program. So let's close out of the terminal. Well, first we need to exit our REPL. So let's type quit and put the parentheses, press enter. Now we have quit the REPL, and we can just click X to close out of the terminal window. I have created a Python file called welcome.py. Now remember, you can do that by clicking the new file icon over here on the top left, or you could press Control-N to create a new file and then save that file as welcome.py, welcome.py. So now inside this file, we're going to use some statements. So my first statement is going to be assigning a value to a variable, and I'm going to call this variable line01. I'll set it equal to a line that has 20 asterisks. So 1, 2, 3, I believe that's 20. From there, we're going to take a shortcut in Visual Studio Code. So I'm going to press Shift, Alt, and the down arrow and copy this down. Now, we don't have a problem right now, however, we're reassigning this variable. What I want to do is change this to a 2, and I want to change this to a 3. And actually, I don't need these last two. I was thinking I'm going to use 5 lines, but I only need the first 3 lines. Now here in the middle, I am going to remove all of the middle asterisks and then space this back over so it matches up with the edges. Now in the middle of this one, I'm going to remove them, but then I'm going to space over 5 times, 1, 2, 3, 4, 5. Then I'm going to type welcome, if I get my fingers on the correct keys, and then 1, 2, 3, 4, 5, and there I'm finished with the 3 assignments. Now let's go ahead and create some more statements that print these values. But my first print is going to be an empty string. So I want a blank line first. So this is the print function here, and it's going to just print this empty string. But on the next line, I can say print line 01. You can see Visual Studio Code even wants to help me. It knows what values we have already. Once again, I'm going to press Control, Alt, and the down arrow, and this time I actually do want 5. And so now I'm going to have line 1, and then I'm going to switch this to line 2. Now I'm going to switch this to line 3. And here's something about programming. We want to be efficient. There's no reason to create the line 4 or 5 if they're going to be the same as line 2 and line 1. So now I just want line 2 printed again, and then line 1. So what I'm going to do is create a welcome message, but it's actually going to have this header and footer because it starts with this and it ends with this. So Control S to save our file with those changes, or you could go to the File menu and choose Save, but it's faster to learn the shortcuts like Control S. From there, we can run this file. Do you remember how to do that from the first lesson? There were 3 different ways. What I'm going to do is go up to the play button here, choose the little drop down, and choose Run Python File. And let's see what happens. And it outputs our print statements, and we get our welcome message here in the terminal. So that worked out nicely. Let me drag this down a little bit, because now we also want to discuss comments. And comments would be notes we would leave for ourselves or for other programmers inside of our file. So here I'm going to just put a comment afterwards, and it starts with the hash mark, or you might call it a hashtag, as made popular nowadays. So we've got our hashtag here, and then I'm going to just say header/footer, because that's what I'm using that line for. And here I'll put another comment, and I'll just say reuse. So anything that comes after this hashtag is grayed out, and the hashtag itself is too, and it doesn't impact the code at all. They're just notes for us. Now here I could put a note before everything starts. I could say starts with a blank line. So I'm just leaving some comments inside of our code file here, and these are reminders to me, so when I look at the code, maybe I know what it's going to do, or another programmer that might look at the code in the future, and this would help them understand what the code does. I'm going to close the terminal window again, just so we have a little more room as we look at our code, and we need to talk about indentations in Python. They have special meaning, and if you're used to another programming language like JavaScript and others, they ignore white space, but Python does not. So I'm going to indent here several spaces and then type line 04, set that equal to a line that has some more asterisks, for example. And this is just an example, not anything that I really need. But here we have a red squiggly in VS Code. It's already telling us that this is not going to work. And if we mouse over it, we'll probably get a message. Yes, it says unexpected indentation. You can also see our file name is red over here in the file tree. That means there's a problem. And even in the scroll bar to the right, we have some red marks telling us that there are some problems in the file. But no worries, when I press Control S to save, we get some auto formatting, and Visual Studio Code fixes that indentation for us. So that's very nice. So let's make sure that you have that set up. It might be set up automatically after you already installed the Python Visual Studio Code extension like we did in the previous lesson. You want to make sure you have that extension installed. Click Extensions over here. This is the icon, and then search for Python. And then you can check Python from Microsoft, click that, and if you have it installed, you should have the same messages I do that say uninstall and disable instead of being able to install the extension. So this means you already have it. It says this extension is enabled globally. So we've confirmed that I have that extension. So now let's go into the settings of Visual Studio Code and confirm that you have the auto format on save set as well. So I'm going to press Control and comma. And this will open up the settings. Again, Command, comma on Mac, I believe. So once you do that, we need to search for these settings. The first one is going to be Format on, there we go, Save. And when we bring that up, we have Editor, Format on Save. You want this checked. And besides that, the mode that I have here is when I save the file. So make sure this says File as well. Now, after that setting, once you confirm that, now we're going to search for Format on Type. And you can see this setting that came up here, and it says Modified Elsewhere. You may or may not have that, as I have separate settings for different languages. And I have Python, then the greater symbol, then user. So if you do have that, you could click that. If not, and you don't have the modified elsewhere here, you could probably just check this box. I'll show what happens when I click this Python greater than user here. When I do that, it brings up this setting, and it gives a user setting and then a workspace setting. We don't want to change the workspace setting. If you start changing those, you will see a .vs code folder over here that will have separate settings. And if you don't want it, you can just delete it if you ever see it over here. But under the user settings, this is where I have the checkbox for Format on Type, and it says controls whether the editor should automatically format the line after typing. So after I type a line and go to the next line, it should put me at the correct indentation level automatically. So that's a good setting to have as well. And then finally, let's go back to the welcome.py file. And I'm going to make sure my unnecessary line 4 is once again indented over here where we don't want it, and we get the red squiggly lines. Now we can right click, and I believe this would be a command click on a Mac, but I'm on Windows, so I have a right click. Now from this context menu, there is Format Document, which is Shift Alt and the letter F for the shortcut, or Format Document With. I'll choose that one for now. And now you can see it gives me my choice, which is my default Python. But if you have other format styles installed like AutoPep 8 or Black, which are two other ones that VS Code might offer to you, and feel free to change between them. But if you don't like the way one formats, you may want to switch back. I'm just going to use the default Python formatter right now. So we can click Configure Default Formatter, and then it has you choose which one, and you can see I only have the one choice, which is Python. But now that I've done that, I can right click and I can format the document, or choose Format Document With to choose any of the formatters that I have installed. So I'll just choose Format Document, and it gets rid of those spaces once again. So I'll Control S to save, which since we set that format on save, let me go ahead and add those spaces that we don't need again. And now I will Control S to save, and once again, it auto formats. That's the exact behavior we want. Now quickly, just to show another way to do these settings, or to confirm that you definitely have the settings that I do, I'll press Control comma once again to open up the settings. And if you see this icon here at the very top right in VS Code, it's the one with the arrow and the document. This is your settings JSON file that you will open. It could look complicated to you, especially if you're not familiar with JSON. It's got all of these different user settings in here, but specifically, here are my Python settings. So I specifically have Python here inside of brackets, and then there's curly braces, and then it says editor.defaultformatter, and I have ms-python.python, and then editor.formatOnType is set to true. Now remember, we also set format on save, and that wasn't specific to Python, that was just overall for VS Code, so it has that setting right here also set to true. And now your user settings for Python should be exactly like mine going forward. In the last lesson, we defined a statement as an operation on a value. Now we can define Python operators as symbols used to perform operations on values and the variables that hold those values. So let's look at some examples, and we'll do that by opening a terminal window first. So you can go to the terminal menu, and from terminal menu you can choose new terminal, or you can just press Control and the backtick, which will also open a terminal window. From there, we need to start our Python REPL, and I do that in Windows by typing py. And you might remember in Mac and Linux, I believe you type Python 3, just like that. I'm just going to type py and press enter, and now my Python REPL has started. So the first operator that we have used already, and that I'll introduce today, is the assignment operator. So you have seen me type this example before. I'll just type name equals, and I'll set the variable name equal to the string Dave. After I do that, it's now assigned. That's the assignment operator, and I can type name and I get the value back. Likewise, we can assign other values. So I'll take meaning as a variable name and assign the number 42. And if I type meaning, I get the value 42 back. So I think it's easy to see how assignment works and how the assignment operator, which is just the equal sign, works in Python. From there, we'll move on to arithmetic operators. Now you have your standard addition, say 2 and then plus 2. Press enter, we get 4. So we can use Python just like a calculator. We can have 4 minus 2, and we get 2 back. We can also do multiplication, so 2 times 2, we get 4. And we can do division. So let's do something here that's a little different. Let's say 24 divided by 5. Now, what would you expect to get back from this? Possibly 4 if it's rounded down, or 5 if it's rounded up, but maybe we'll get a decimal back. Let's see. And yes, we get 4.8. But there's also floor division, so we could say 24 and then use 2 slashes, and that's floor division, which means it's going to round the answer down. And now we get 4. Or we could also use the round function, and then we could say 24 divided by 5, and now it's 5 because it rounds up. But what if we just want the remainder? Well, then we use a different operator, and that's the percent sign. And then I have 24% 5, and let's see what we get back. We just get the remainder, which is 4. Also, there's exponents. So if we said 2 to the power of, which is 2 asterisks, 3, that would be 2 times 2 times 2. And yes, we get 8. So what if we said 2 to the power of 5? That's 32. And so you see how that works as well. And now when we're working with variables, we can combine the assignment operator and arithmetic operators. So let's take meaning and set it equal to 42. And now I can say meaning, and then I can say plus equals 1. And now what do you think the value of meaning is? If I type in meaning and we get the value, it's now 43. So it added 1 to that. So that was a lot like saying 42 plus 1, but the variable meaning holds the value of 42. Likewise, we could take meaning, I type meaning correctly, and say minus equals 1. And now meaning should be back to 42. We can do the same with the other operators also. So I can say meaning, and then times equals 10, and then if we check the value of meaning, we get 420. So now let's look at meaning, and let's say divides by and equals. Now, what do you think will happen if we go ahead and divide this by 10? What will be the result? Well, let's go ahead and look. After we do that, we need to check the value. and it's 42.0. So that might be unexpected. We have a decimal now when we divide, but we could have used the floor division and not received that response. Now this won't change meaning. Notice we're not using an assignment operator here. We're just rounding meaning, and we'll see what the response is. Well, it's 42, but now if we check meaning, it still has the decimal point. So we could say meaning equals round meaning, and now that would remove the decimal point. So if we check it here, it's now just 42. One other thing you can use the plus operator for, and that is to concatenate two different strings. So if I took my first name in a string, Dave, and I'll put a space after it and put another double quote, then I can use the plus symbol and I could put my last name. Oops, I accidentally hit return or enter too soon. So let me try that again. Dave space, double quotes, plus, now double quote, Gray, make sure I hit the double quote again and not the enter key. Now we get one string returned that is concatenated the two previous strings of my first name and my last name. And now I want to look at comparison operators. But before I do that, let's get rid of our previous history here. And we can do this in the terminal by going to the three dots and choosing Clear Terminal. And then it just clears out the full terminal for us as well. So now let's look at comparison operators. And so if we want to check to see if one number is equal to another, let's say the number 42, is it equal to 41? Let's find out when we press enter. And we get a false response. So let's see if 42 is equal to 42. Notice we're using the double equals, so it's not the assignment operator. Here we're checking to say, is this equal? And when I press enter, then we get true. Notice we're getting false and true on these responses. That is called Boolean data. And notice how the false and true are both capitalized at the very first letter of the word. So now if we check to say 42 is not equal to 42, well, that's false. So if we said something like 43 is not equal to 42, we would get true back. Likewise, we have greater than and less than operators. So 10 is greater than 5. That is true. 10 is less than 5. That is false. We also have greater than and equal to operators. So 10 is greater than or equal to 10. That is true. 10 is less than or equal to 10. Well, that's also true because it's still equal to 10. And so now working with these comparison operators, we've introduced Boolean data, the true and the false. So let me create some variables here. I'll just set a variable named x equal to true. Then I'll set a variable y equal to false, and I'll set a variable z equal to true. Now we can use some Boolean operators with these variables. So the first Boolean operator we'll look at is the word not. It is a keyword, and so x is true, but if we say not x and we press enter, we get the opposite, false. So if we said not y, we get true. Again, the opposite. Another Boolean operator is and this would look at two conditions. For example, x and y. Now, let's look at what happens. It's going to evaluate the first value, and it only looks at the second value if the first value is true. So what do you think we'll get as a response? We get false because the first one is true, so it looked at the second one. Likewise, if we said y and x, now the first value is false, and it stops evaluating right there. So and needs both values to essentially be true. That's what we're checking for. So if either one is false, that's where it stops. Now just the opposite is the Boolean operator or. So let's say x or y. And now it's only going to look at the second if the first is false, but x is true. So the response we get is true. But if we say y or x, y is false. So the response we get is true again because it looks at the second value because the first was false. So you can kind of remember it that way, and or are the opposites. They would kind of give opposite results. But or is just checking to see if one or the other is essentially true. And if we use that in a conditional statement, which you'll see an example of here in just a minute, and would actually be us looking for both values to be true is what we would be hoping for. If X is true and Y is true, then do something else. So for example, we could say X and Z, now they're both true, and we get true back because the first was true, so it returned the value of Z actually, because then the second was true. And then we could also have Z and Y, and what would happen here? It's going to be false again because Z was true, so it went ahead and looked at the second value. Now let's check again with the ors, Y or Z. What are we going to get here? We get true because Y was false. Now if we said Z or Y, we get true again, but it stopped when Z was true. It never evaluated Y. Now I understand that can be a little bit confusing, so it's good to play around with these and check those Boolean operator comparisons yourself until you get the hang of how they work. So for now, let's quit the REPL. We'll type quit with parentheses. And after that, let's close the terminal window. And we're going to create a new file here in Visual Studio Code. So I'm going to press Control and N, and that brings up a new file. Remember, you could also use the new file icon over here. And now I'm just going to start typing, and then we'll save the file afterwards. So I'm going to take the variable meaning and assign it the value of 42. Now I can do Control S to save the file, or I could go to the File menu and choose Save As, which would allow me to name the file as well. I'll just do Control S. Now I'm going to name this meaning.py for Pi, or for Python, and I want to make sure that I have the Python file type here as the Save As type as well. So when I choose Save, now it is a Python file. Now in our small meaning program here, I also want it to start with an empty line. So I'm going to print an empty string to start out with. Now we were using comparison operators, and you often see those in logical if statements. So let's create our first if statement. I'll say if meaning is greater than 10, now I have a colon. So now I indent, and notice when I pressed enter, Visual Studio Code already knew I needed to be indented, and the indentations do mean something in Python. And so now I'm going to print, I'll just say right on. So if meaning is greater than 10, this would be the output. After this line, now I do not want an indentation, and Visual Studio Code doesn't really know if I want to do something else here or not after meaning would be greater than 10. So here I need to backspace just to go back to where I do not want to be indented. Now I'll type the word else. So this is essentially if meaning is not greater than 10, we're going to do something else. And I'm going to print here, and I'll say not today. So we have our first if-else statement, and it's going to check the value of meaning. We're using a comparison operator here. So once we save that, now if you remember how to run the code, we can just click the play button here. In the past, I've used the drop down and chose Run Python File, which also works, but we can do it a little simpler than that just by clicking this button. So let's do that, and it runs the code. Oh, it did not find an alias. Maybe we need to choose Python, Run Python File first. And after we do that one time, I think this play button is going to work. Yes, it works the next time. So if you need to do that, if you get that error that you saw I had, go ahead and choose Run Python File the first time. After that, the play button works just fine. And we get right on every time. And that's because I don't need this bash window here either. We're just using the Python one. But this is because meaning is 42, which is greater than 10. So let's change the value of meaning to 8. And I'll save the file again. And now I'll click the play button, run, and it says not today. I'll drag this back up so we can see just a little bit more. Run it again. And you can see the command that is issued when I click the play button. Now, if you remember, this is a quick review, how we can run this ourselves from the terminal window. We can just type pi to run our Python code, and then type the name of the file .py. Because I'm in this lesson 03 directory, And that's the name of this up here. Whatever folder you have would be the name there. And then we can see the file. So just py and then meaning.py, and we'll get the same result. But you see the long version here when you click the play button here. And so we get not today because meaning is only equal to the number 8. I'm going to close the terminal window for just a little bit more room, and we need to look at one more operator today, and that's the ternary operator. If-else statements are nice, but look, this took 4 lines. We could do all of this on one line if we wanted to. So let's talk about something else we can do. We learned about comments in the last lesson. I'm going to highlight all of this code in Visual Studio Code. I do that by clicking and dragging. Once I do that, I'm going to press Control and slash, and it just commented out all those lines of code that I have highlighted. So they're still there, and I want to leave these in here to give you the example of the if-else statement. But now let's use the ternary operator to accomplish the same thing in one line of code. And so I'll put another comment here and I'll spell this out. This is a ternary operator. In Python, we accomplish this a little bit different than if you're used to JavaScript or some other language. So the first thing I'm going to type is what I want to be the output if the statement is true. So I'm going to type print right on. And then after that, I'm going to actually put the conditional statement, what we're checking for. So I'll say if meaning is greater than 10. And then after that, I need the word else still. And then I can put what the output will be if it is false. And I'll print not today. That is our ternary statement, and it uses the ternary operator. It looks a little different, especially than I often work in JavaScript, for example. It looks a little different than the way I would do this in JavaScript. But let's go ahead and run the code again just by clicking the play button, and we get not today. It works just fine. Let's put the number back to 42, and let's run it again. And now we get right on. Our ternary statement is working as expected. So we've covered the most common Python operators today, but some other Python operators will also be introduced in the future, and those include the identity operator, the membership operator, and even bitwise operators. We are ready for Lesson 4, and I have Visual Studio Code open. You can see I have a folder to the left that is named Lesson 4, and that's what you'll find in the course resources. Now let's create a new file in this folder. I'll click the little plus icon up here for a new file. And this is a good time to talk about naming conventions for files with Python. We use all lowercase, so I'm going to type data. And then if we need a space, we do not use dashes or hyphens, if you will. We use underscores. And then we continue to type in lowercase. So I'm naming the file data_types.py. And then press enter, and there is the file that we'll work with. Now that we have the file, you'll see the play button up here that we'll use to run our code and the associated menu that can show with that. So let's begin by typing inside the file, and I'm going to just put a comment here that says string data type. It's the first data type that we're going to cover, and I'm going to talk about the literal assignment of values. So I'll type literal assignment here in another comment. And I'm going to type a variable named first. I'm going to assign the string Dave. This is literal assignment. So I literally assigned this value, Dave, that is a string value, to the variable first. Now I'm also going to create a variable named last, and I'll put my last name in there. These are both string values. Now we can check this in Python if we use the print statement, and then we use the type function, and I'll pass in first. So that is the variable first that holds the string value Dave, and we'll see that when we check it. So I'm going to press Control S to save the file. You could also do that from the file menu and then find save here. You can see it's Control S. After that, I'll come up here to the little menu by our play button and choose Run Python File. Now it went ahead and opened the terminal window for me when I did that, and you can see the output says class string. This str stands for string. Okay, after that I can close the terminal and it will reopen it when we run the file again. There's another way that we can check for this value, so I'll once again type print, then I'm going to say type, pass in first. Let's see if it is equal to, and that is to equal, and then str for string. And besides that, let's do one other one that we can also check. Now I'm going to do Shift Alt and the down arrow that will just copy this down, and then I'm going to change what's inside of the print. There is an isInstance function that we can use, and with this I'll pass in the variable first, and then we're going to say it is an instance of what, and in this case we're checking for string. So now we'll see the output of all three of these print statements. Once again, Control S to save, and then I'll just click the play button to run the code, and I'll need to pull this up maybe to see all of the output, and I'll scroll just a little bit. There we go. So we see string that we previously had here, and then true, true. So the output of the following two statements is type first equal to string, and the output is true. And then is the first variable an instance of string with this isInstance function, and that is also true. Okay, now that we have looked at literal assignment, let's look at another way we can assign a value, and that's with a constructor function. So I'll make a comment for that. Now I'm going to define pizza, and this variable is going to hold a string that says pepperoni, but I'm going to use the string constructor function. So it's str and then parentheses, and inside of this I'm going to pass in the string pepperoni. Now after this I'll copy all three of these and I will paste below. So I copied with Control C after I highlighted this, and I paste with Control V, the letter V as in Victoria. Okay, then I need to change this word first to pizza. So I highlight the first one and then Control D to select the second and the third instance of first. Now I can just start typing pizza and it will change all three. So now we're going to check the output for pizza as well. And I can highlight these also and press Control and the slash, and it will comment these out. So we only see the output for our pizza now after I save once again with Control S. Now clicking the play button, and we should get some output that we once again see in the terminal, and I'm going to just leave that terminal as a little bit larger so we can always see that. There we go. So it is class string and true once again. So now we checked pizza here, and it said class string, and then this said true, where we checked the type if it was equal to string, and then this said true where we checked if pizza was an instance of string. So now we know two different ways to assign string data to variables, and we can do this with other data as well. So we have literal assignment and constructor functions that can assign data. Now I'm going to comment this out as well. Again, highlighting this and pressing Control and the slash will comment these out. Now when you find these in the course resources, you can do the same thing to uncomment. So you could highlight the lines you want to uncomment and press Control and the slash, and they'll once again be uncommented. So you can toggle between the two by doing that. Now let's discuss concatenation, and that means adding two strings together to form a larger string, and that's what we will do. So we will type concatenation here, and after this, let me define full name as a variable, and I'll use my values from above. So I'm going to set full name equal to first, and then I can use the plus operator, and then I'm going to put an empty string here with one empty space, and then plus again, and type last. And this concatenated my first name with a space in between to my last name. So now we could print full name, there we go, and save. Once again, press the play button, and you can see my full name here inside of the terminal. Now we can also add something to the end of full name if we want to. So I will say full name, and now I can use plus equals, and this is going to take the value of full name and add to it. And I'll just put an exclamation mark here at the end. Then once again, print full name. And if I run the code with the play button, we should see my name now with an exclamation mark here in the terminal. You can also take a number and change it to a string, and this is called casting. So here I'll say casting a number to a string. And let me assign a variable named decade with the value, and I'll use the string constructor here, and I'm going to pass in 1980. So I had a number, 1980, the value, and I am now casting it to a string with the string constructor. After this, we'll go ahead and check this value. So I'll say print and type and decade. And then after that, let's go ahead and just print this out to see what it looks like after it has been casted as well. And now let's check those values. And you can see that yes, that type is a string, and there's the value, but it's a string here. It is not a number, and that is 1980. And now this is important. If I wanted to concatenate that value inside of a sentence, I would need to cast that number to a string as we previously have here. So now let me create a statement. So this is a variable name statement, and I'll just say, I like rock music from the, now I'm going to concatenate that value. So the plus operator, and then I'll just pass in that variable decade, another plus operator, and then the letter S and a period at the end. So now let's print our statement and save with Control S and run our code. And we can see we have the statement, I like rock music from the 1980s. But what if we wanted a statement with multiple lines? We can do that as well. So I'll scroll up for some more room. And underneath this, I will just leave another comment that says multiple lines. And now we'll take a multi-line. I'll just call this multi-line for the variable. And we want to start with 3 quotation marks. Either double or single will work. So I'll put 3 quotation marks. And notice VS Code wants to help me, so it already automatically added the closing 3. After this, I'm going to press return and leave a few lines between the opening and closing quotation marks. Again, 3 at the beginning and 3 at the end. Here I'll say, hey, how are you? With a question mark. And now let's add some spaces with the space bar. Press return again, and then another statement. I was just checking in, and then another space or 2 or 3, and then return once again. And now I'll tab over 5 or 6 times and say, all good, question mark, and then notice we have a blank line after as well. Let's save that with Control S. And now after we do that, let's look at our statement in the output when we print multi-line. Save once again and run. Now we have this big statement that is on multiple lines, and of course it has white space before and after some of the things as well. We'll come back to that white space in just a little bit. Now let's talk about escaping special characters also, because sometimes we have special characters inside of our code. We just started this multi-line statement with single quotes, and what if we were to use single quotes around a sentence we created? So here I'll leave a comment, escaping special characters. And now I'm going to create a sentence variable, and I'm going to set this equal to a value that is inside of single quotes. There we go, single quotation marks, and the word I'm. So this would have a single quote in the word. And notice VS Code doesn't like this. We need to escape this single quote if we want it to be in our statement, because right now VS Code just thinks the value ends right here with the letter I. It would not include the letter M. So let's put a slash here, and it's a backward slash, and that escapes that single quote. So now it knows that it should be part of this phrase. So now we can use I'm in our sentence. And I'll say back at work, exclamation mark, and then I want a tab after back at work instead of a space. We can indicate that with another backward slash and a lowercase t. Notice how VS Code leaves this as red, so that's a special character. So now we have a tab in our sentence. And I'll just put the word hey with an exclamation mark again. And now another backward slash and a lowercase n. That indicates a new line. That is the new line character. So that will make everything else that follows it be on another line. Let's put 2 of those just so we can see what really happens there. Then I'm going to use the word where's. So it once again has a single quote that I need to escape. And then the letter S, then this. Then I want at slash located. And I want to put a slash between at and located. But as we know already, we're using slashes here for special characters. So we also need to be able to escape that slash. And so we do that by adding a second slash, but only one will appear in our sentence. And then I'll put a question mark at the end. And let's go ahead and print this sentence out and see what we get. Control S to save, and we run our code. And here we have our full sentence. I'm back at work. Hey, where's this at located? Once again, it put in the tab, it put in the line breaks, and we were able to use the single quotes even though we had wrapped our full sentence inside of single quotes. I'm going to scroll up for some more room, and then I'm going to leave another comment because we're going to begin working with string methods. Now, methods are functions that are called on the string class, and that's not too important right now. But we do want to see what these methods will do for us. So let's start out just by looking at the value that we once again have in the variable first. But after that, I'm going to put another print line and say first.lower, and we'll see what it does to the value that is in the first variable. And we'll also note that it won't actually change the value in the first variable. It will just return another value. And then instead of typing that all again, I'm going to use Shift-Alt and the down arrow and do that twice. And I'm going to change lower in this second one to upper, see what happens there. And then I'm just going to remove lower from this last one so we can once again see the value of first and note that it did not change. Control S to save and click the play button. And now here's our value of first, which is my first name, Dave. And then after we called the lower method that we see here on line 49, we then had the lowercase value of my name, and then first.upper, and we had the all uppercase value of my name. And then we once again just checked the value that was in the first variable, and it is still left untouched as it was. Let's look at some more string methods, and instead of using my first name here in the first variable, let's use that multi-line variable that we created. So we'll now say print, and then inside of this print, I'm going to use multi-line, and I'm going to use the title method at the end of this. Now, this method will turn everything to proper case, and capitalizing the first letter of every word in that multi-line phrase. But I'm also going to print another version of multi-line, so we should see it twice. And in this version, I'm going to use the replace method. I'm going to replace the word good with the word okay. And we should see the difference there. And then finally, I'm just going to print multi-line so we can see that the original value did not change. So I will save that, click play, and of course we can't see all of that at once. I'm going to make this terminal window take up the full screen for a moment. We'll see 3 versions of this. So here was the version that has the proper case where we called the title method. So it says, hey, how are you? I was just checking in, all good. The second version used the replace method and we changed good to okay. And then finally, we printed the original version that you can see did not use proper case with the title method and still contains the word good. Now I'll go ahead and close out this terminal window for a moment, and we talked about all of that white space that is in our multi-line variable. So let's work with that now. I'm going to call print once again, and I'm going to call the length function, which is just len, and I'm going to pass multi-line into this so we can see what the original length of our multi-line string is. So it will count every character. After that, we're going to change the multi-line variable, and I'm going to use the plus equals to add to the end of it. And let's just add a lot of extra white space. After that, let's go ahead and once again change the multi-line variable, and I'm going to add some space to the beginning of it. And we'll do that in a different way. Instead of the plus equals, I'll use the equal symbol. I'll add some space, and then at the end, I'll concatenate the value that we have in multi-line currently. And then after that, let's once again check the length. So we'll check the length function with len, and then we'll pass in multi-line. So we're checking the original length, we're adding to the end and the beginning, and then we're checking that length again. And if you want to, you could even check in between where you'd get a value that only has it added to the end and not at the beginning. So now let's run this and see the values that we get. So we start out with 126, and after we add all of that extra white space at the beginning and at the end of the variable, it's 184 characters. Now, of course, this white space is undesirable, but I'm adding it as an example. So now let's look at some string methods that will remove that white space if you had some values that you needed to remove white space from. So I'll say print once again, and now we'll say multi-line dot strip, and that should remove the white space if we wanted to remove it. But this will of course print out the output. It's not checking the length if we don't add length, and we won't really be able to see that because you can't see white space. So let's go ahead and just check the length here, len, and we need to wrap that in parentheses. And now I'm going to do something else. I'll do Shift Alt and the down arrow twice. There are two other methods we can check. So let's check if we only remove the white space from the left side, and that is with lstrip. Let's also check if we only remove the white space from the right side, and that is rstrip. So if we check all three of those, then we'll see different values. So let's run this code with the play button, and we can see the last three here. If we removed, well, all of the white space, it took it down to 123. And remember our original, it had 126 up here before we added the white space. So this actually removed some extra unneeded characters as well. And then when we only removed the white space from the left side, we still had 165 characters. When we only removed it from the right side, then we had 142, and I think I'm saying that in the correct order. Yes, we removed the right side last. And there are many more string methods, and I'm going to leave a link in the course resources where you could go to the documentation and find all of the available string methods that you can experiment with. Right now, let's just use a few more string methods to build something, just so we can apply this in a small way for now. Let's build a menu. I'm going to set a title variable equal to menu. Notice it's all lowercase value, and we can call string methods directly on the value itself. It doesn't have to be called on a variable name as I have been showing you. So here I'm going to say menu.upper and call a string method directly there, and that will be stored in the title variable. After that, I'm going to print the title, and I'm going to call the center method. I'll pass in 20 characters, and I'm going to pass in a value that is an equal sign. Let's see what this does if we just return this much. And I'm also going to leave an empty line here so we do not actually see everything that we've had above pressed right up against our menu. So Control S to save. And now I'll run the code with the play button, and you can see what we've got. So we called a center method, and it centered our word menu that was set to all uppercase, and it used that character I passed into the center method to fill out the rest of the space. So that's a very interesting method to call. Now let's call another one that is equally interesting. So after this, I'll say print, and I'm going to use the string coffee. And after this, I'm going to use ljust, which means left justify. And I'm going to give this 16 characters. I'm going to have it fill out the remaining space after coffee with periods. And then I'm going to concatenate inside of our print statement. And I'm going to say $1, but I want it to be a string. So the $ and the number 1. And I'm going to call the right justify method on it. And I'm going to say 4 characters. There is nothing that I want to fill out the rest of the space with, so I'm just going to pass in one argument here, or one value, I should say, to this right justify method. So after I do that and save, let's see what we get in our terminal once again when we click run. And now our menu has coffee, and you can see it filled out the space that we gave it for 16 characters. And then we have our $ that is right justified over here. Let's go ahead and complete our menu. I'm going to scroll up, and once again, as I've explained, I'm going to use Shift Alt and the down arrow to copy this down twice. And now let's just change our values. So I'll double click coffee and change it to muffin. And in the last line, I'll change it to cheesecake. And then here, let's just change our values to $2 and let's go with $4. Control S to save, and we run our code, and we have a nice little coffeehouse menu. Let's close the terminal, and let's look at just a few more things with strings. And one thing to discuss is string index values. So I'm going to say string index values here in a comment, and just to keep our menu separate, I'll once again print an empty string here. Okay, after the string index values comment, let's look at string index values. I'll come back to that first variable that we have. And if we just want the value that is at index 1, do you think that will be the D in my name? It would seem to be if we say we want the number 1 value, right? The very first value. Well, that might not be what that indicates. Let's go ahead and press play. And you can see it actually returns the second letter. And that's because indexes start at 0. So if we wanted the first letter, we would pass in a 0 right here. Let's copy this down with Shift-Alt and the down arrow. And let's see what -1 gives us. So if we save now and run our code, we have the E, which is the last letter in my first name. So anytime we want the last value in the string, we can reference the -1 index. And that could be very useful if you didn't know how many letters were in the string you were working with, but you needed to get that last value. You can also use a range of values. So here, instead of just 1 or -1, you can start with the index, say at the first position. Well, it's actually the second position, but at the 1 position. And then we could say we want to end at the last position. But this might not deliver what you think either. When you provide a range, let's go ahead and run this, you see we just get the AV. So the value you give at the end of the range will not be part of the output. So you need to consider that when you create the range. And if you want to go all the way to the end, you just provide a range without providing the last value at all, like this. And now we should get the A through the end of my first name. Run this, yes, we get AVE when we don't provide that final value. And now when we've previously checked what data type we had, some of those checks were returning true, and that is Boolean data. Let's look at a couple of methods that also return Boolean data. And I'll just say some methods return Boolean data. And if you're wondering what Boolean means, it just means we're working with true or false data. So if we print here and say first starts with, now I could say does the value in the first variable, does it start with the string D? Well, that should be true because my name starts with a capital D. Let's copy this down so we can check two things at once. Now we can say does first ends with, and now we'll check the letter Z. So let's see what result we get. Oh, it does not have two S's. And notice Visual Studio Code will help you with that. This, in my theme at least, it turned purple here. And if you're not using the same theme, it may turn a different color. But overall, if I mistype something, then it doesn't look right. It doesn't have that color that starts with does. But if I remove the S, there you can see it identifies the method. Likewise, and I'll just remove this for a second, when we're working here in Visual Studio Code, you can just type the period and suddenly a list of all of these different methods can show up, including the one I want, which is ends with, and you can search for them that way as well. So now I'll just put in the letter Z again, save, and we'll run the code. And of course, we get true that yes, first starts with the letter D, a capital D, but false, it does not end with the letter Z. So now since we've brought up Boolean data, let's quickly discuss that. And I'll just leave another comment here that says Boolean data type. And now after this, I'm going to set my value equal to true. Now notice the true has a capital T. If I remove that and just put true, Visual Studio Code tells us something is wrong here. It needs to be proper case with a capital T, or false will not work either. It needs to be capital F for false. So either way you do it, just needs to be proper case, whether you choose true or false. Now after this, I'll set another variable, just the letter X. I'll set it equal to bool, and I'll pass in false. Now this is the constructor function once again. So you can set this data type in either way. And once again, we can print, say type and check the type of X. And we could also say print and say is instance that we see right there. And then we could pass in my value and say, is it a bool value? We should get true for both of those. Let's go ahead and run the code. And well, we didn't get true. It just said what type it was. Actually, we didn't check that against a value like bool. So yes, we get the output here, what it is. Then yes, true for the second one. But just important to remember that Boolean means you are working with true or false data. Let's move on to the numeric data types, and there is definitely more than one. So we'll start here, and I'll just say numeric data types. And the first type we'll work with is integer, and we have seen this in previous lessons. I'm going to set price equal to 100. Then I'll set best price, and I'm going to set this equal to the constructor function and pass in 80. So you can set an integer in either way. And just like we did in the past, as a matter of fact, I could just copy these lines, Control C, and then down here, Control V to paste. I could change X to price, and we should see that it returns the type integer. And then here, I could change this to best price, and we'll compare it not to bool, but to an integer type. And we'll see what we get for the output. And yes, it is a type integer, and yes, it's true that it is an instance of integer. After that, let's do some more with numbers, and we'll look at the float type. Float types have decimals, so a grade point average, GPA, set that equal to 3.28. That would be a float type, and that is a literal assignment, just like we did with price up here. But we could also use a constructor, but it almost seems pointless because you still type the float. So I'll just say y equals float 1.14, and of course this is a float data as well. We just had to type a little bit more. So here we could say print. We'll check the type GPA, and it should return float. And of course, we could do is instance as well if we wanted to. But let's see what we get. Yes, it is the type float. Now, there is one more numeric type to quickly mention. It is not a type we will use in these basic lessons, but I should bring it up. It's the complex type, and it's often used in electrical engineering. It uses J notation. So here we'd say comp value equals 5 plus 3J. I know that looks a little strange, especially if you're not into engineering. But we can print type, and we'll check the type for our comp value. But now a complex value has a couple of property values we can check. So let's go ahead and do that just so you see how. We can say comp value dot real. We can also say comp underscore value dot imag, which stands for imaginary. This is based on a real number system, and it has a real number value and an imaginary number value. Once again, if you're not into engineering, it may not make a whole lot of sense, but Python has so many applications, it's pretty awesome that this is built in. So let's go ahead and run this, see what we get back. Yes, it's a complex type, and you can see when we return those individual property values, they are float values, but they are part of the complex data type. Okay, I'm not going to go over all the different mathematical operations that you can do. We have previously covered several of those in the past lessons, so no need to rehash that. We went over those especially with operators in the last lesson. But there are some built-in functions for numbers. So let me just highlight those with a comment this way, built-in functions for numbers. And let's print one of those out. Let's print the absolute value of the GPA that we previously created. And remember, that was a float type. I think we said 3.28. So let's see what the absolute value of that GPA value would be. It is 3.28. So no change there. But once again, this is checking the absolute value. Now let's see if we did something else with that we could check. We could say print, and we could say round, pass in the GPA there. And then let's go ahead and do one other. Let's print round and say GPA, and we can specify the decimal. So the difference here would be this would round to the nearest integer. This would round to the nearest decimal place that we specify. So we have 2 decimal points here with our absolute value. And you know what? I should check this as well by saying print. And since that didn't change before, we could say GPA multiplied by -1. So you would expect to have a negative 3.28, but the absolute value will probably not be negative. So now we can check all of this. Let's run. And yes, we got 3.28 twice without the negative, although that would have been expected. Now the rounded down to the nearest integer, which was 3. But then when we specified the decimal point, it rounded up from 3.28 to 3.3. So those are just a couple of built-in functions that you can use with numbers without importing a module. But there are some modules that provide many good mathematic helpers. And one of those is simply the math module. Now, if I type import math right here, and when I save the file, it's going to move this to the top of the file, which is nice. And that's because I have that Python extension installed that we'd previously talked about. Visual Studio Code just wants to help us format this. What you should typically do is type your imports if you're bringing in a module, which we'll get into more further in this series. But you would type your imports at the top of the file. I'm going to type it here to just give the example of how it will be moved to the top. Now, after that, I want to use this math module just to get the value of pi. So I'm going to say math.pi. And once again, we can use dot notation to check all of the different things available in this module for us. I just want pi right there. Okay, when I Control S to save, notice that import statement was moved. It should be at the top, and it is. So VS Code moved it right up here to the top above our first actual code. If I was typing this at the top, where I would normally put it is at the absolute top of the file. Okay, after that, let's scroll back down to where we were, and we should just run our code once we're back here to check the value of pi. So we'll do that, and there is pi from the math module. Let's do a few more things with the math module because we've imported it, so let's use it. I'll Shift Alt and the down arrow 3 more times, and let's go ahead and use the square root function that we can use. Let's pass in like 64 and see what the square root of that is. Let's also use the ceil function, and here let's pass in our GPA and see what ceil does. And then let's use, I want to go ahead and highlight that, let's use floor and pass in GPA as well. So we're going to see pi once again, then we'll see the square root of 64, then the ceiling of our GPA value, and the floor of our GPA value. So Control S to save, run the code. So after pi, then we went ahead and found out the square root of 64 is 8, and that is a float value that was returned. But then when we checked the ceiling value of our GPA, which was 3.28, it's now 4, so that rounded up to the nearest integer. Likewise, math floor rounded down to the nearest integer. And one more note, earlier we cast a number to a string, but we could also, let's say here, casting a string to a number. We could also cast a string to a number. So for example, if I had zip code, which is my variable, and inside of it I had this zip code, which is a string, I could check that value or turn that string into a numeric value using the integer constructor function, pass in zip code, then I'll check the type of the zip value. So now that I have that, Control S and run the code, and yes, it is an integer after we have cast that string to an integer with the constructor. Now, a quick note, you can, and I'll scroll just for some more room again, you can have an error if you attempt to cast incorrect data. So for example, if I said zip underscore value equals, and I said integer, and then I passed in New York, which I believe this is a zip code for New York, but we pass in the actual words New York to our integer constructor. Python isn't going to like this, so let's take a quick look at the error. You can see it says invalid literal, and it doesn't like what we did. It really highlights it there. So let's close out of that. I'll comment this out, but I'm going to leave it in the code for you in the course resources, just so you can see this reference that this will be an error. I've got VS Code open to a new folder. Let's create a new file in this folder, and let's name this file rps.py. Stands for Rock, Paper, Scissors, which is the game we will build today as we learn about user input and control flow. So to accept user input from the command line, we first need to assign that input to a variable that we're going to use. So we'll just call this value, and I'll set this equal to input, and then we can put a message to the user, and that's exactly what the user will see. So instead of typing message to the user, let's say something like, please enter a value. And then the user, it will wait for the user, I should say, to enter a value. And then after they do, the code will proceed to run. So after we do this, let's go ahead and just do something simple like print value. So it will print back to the console, of course, what the user has entered. So let's save this much. And now with that saved, I also want to change something from the previous tutorial. When I open the terminal with Control and backtick, we can see it down here at the bottom. Let's move it over to the right. And we can do that by going to the View menu, then going to Appearance, and then we can go to Panel Position, and then choose Right. And now it has moved the terminal here to the right. I'm also going to hide the file tree as we don't really need to see it with just one file. And I can do that by pressing the Control button and the letter B as in boy. And now we've hidden that, so we have some room to code here, and we'll still be able to work with the input over here. So we've saved our file, rps.py. We're going to go ahead and run that by choosing Run Python File. And then it says, please enter a value. So I'll just enter my name, Dave. And then it printed to the console, Dave. So very simple, but that's what we get. Now, of course, we could also put a colon here to make it look a little bit better. And how about a new line character, as we learned how to escape those characters that are special, and the /n is a new line character. So if we save, now let's just run that again. Now we have please enter a value with a colon, and we're ready to enter that on the next line instead of immediately after it as we did up here. So now I could just say something like, hey, and then of course it printed that same value right after I entered it on the line above. So now let's start making our game, and to do that we'll just start over. I'll delete what we have there, and I'm going to start with an empty line, which will just help separate a new game from an old one at the command line. So we've printed an empty string essentially there for a blank line. After that, let's call this player choice, because the player gets to choose rock, paper, or scissors. We'll set this to an input, and then inside of the input I could say enter, let's give 3 dots, and then let's give the new line character. And after we start a new line, we could say 1 for rock, and then we could have a comma. Then let's put another new line. Let's say 2 for paper, comma, and then another, well, let's say or first, and then a little space. We'll say then another new line, and then 3 for scissors. And then we'll put a colon, and let's put 2 new lines. Now notice how this just extended and kept on the same line here, so we have to scroll. Let's go ahead and press Alt-Z to wrap this down to lines. It doesn't mean that I pressed return, it just puts it on a second line. As you can see, line 2 now takes up 2 lines in the editor when I pressed Alt-Z. So that's what we're going to display to the user when we ask them to enter their choice, and we want them to enter 1, 2, or 3. So now we can start applying control flow to our program, and control flow is how the code flows. It's how the user kind of goes through our code in a way. So it's kind of like a waterfall if you picture it like that, and it's performed step by step in a serial direction, just top down for now. And you could also call that procedural. So we're doing one procedure at a time. Now you have already been introduced to some if statements, some logical operators, and we can apply those. So we can say if the user enters this, then do this, and then else if the user enters something else, do something else. So if we look at a simple example of that, we can say if 1 is greater than 2, which doesn't even apply to what the user is entering. This is just a very simple example. Remember, in Python, the indents mean something. So when I press return, VS Code already knows to apply that indent here. And if it's not doing that for you, that means it doesn't recognize that you have a Python file, and you need to install the Python extension that I explained way back in lesson 1 in this series. But here this just says if 1 is greater than 2, and of course it's not, then we would say print do something. So this is just an example of an if statement. This doesn't apply to our game, but this is a code block. So it executes this code block if 1 is greater than 2, and of course that would never be true. So let's apply something that makes a little bit more sense to our game here. And so we have our player choice, so we could say if player choice is less than 1, and then we can put in the pipe symbol, which means or, then we'll say player choice is greater than 3. That means they have given a number, but it's not the number that we want, not in the range we want, at least 1 through 3. So now we have something we could act upon, and we want to tell the user they need to enter 1, 2, or 3. So we could print this statement, like print, and say you must enter 1, 2, or 3. But the problem we have with the print statement is the program is still going to execute and continue after this. So really we need to learn how to exit the program here. If you remember from the previous tutorial, we imported the math module, and there are things we can import in Python that will help us. We need to do that at this time because we need to use the system exit. So I'm going to import at the top of the file, and I'll just type import sys, and then I'm going to give an extra blank line there just for some separation. And now, so instead of this print, we can exit and still provide a message to the user, but I need to use sys.exit. And that will exit the program, but will also output this message to the user. Okay, we have another problem we haven't addressed here yet, and this is that all user input is a string. So when the user inputs that, it will be a string. We really can't use a string here, and that would cause an error. So let's go ahead and cast this to an integer so we can use our logical operators to check if it's less than 1 or greater than 3. So we'll call this player instead of player choice, and we'll cast player choice to an integer as we previously learned about data types. So now we just need to replace player choice below. I'll highlight 1, player choice, press Control-D to highlight the second one, and then just Control-V to go ahead and pass that in. And now we can check player to see if it's less than 1 or greater than 3, because player is an integer and not a string. Now, as we also learned in the last lesson, a user could enter something unexpected, like a word, like New York or whatever like that, and then we could have an error here too, but we'll learn how to handle those in the future. For now, let's assume the user has good intentions, can read the instructions to say enter 1, 2, or 3, and will at least enter a number, if not one of the correct numbers. Now, after that selection, we're going to have another control flow statement that is larger to choose who wins the game. But before we can choose, we need something to compare to. So the computer, we'll call the computer Python, needs to go ahead and make its own choice too. And we want that choice to be random, fairly unpredictable. And we can do that by importing a random module. So let's do that. We'll say import random at the top. And after that, we will come down below and we will go ahead and assign the computer choice. So let's call this computer choice. We'll set this equal to random.choice. I'm going to pass in a string that has all 3 selections, 1, 2, 3. So computer choice will also be a string, but it's going to randomly choose one of the characters from this string using random.choice. So after that, we'll cast that to an integer as well and say computer equals int, and we'll pass in our computer choice variable. Now let's just enter a few print statements to at least get what we have so far before we go any further with the game. So let's print another blank line, and we can do that with an empty string. And I'm going to scroll just so we don't go off the screen there and say print the next line, and I'll say you chose. And then let's put in our plus symbol to concatenate the player choice. Remember, that is the string above, so we can just use player choice there. We don't need this to be an integer. We actually need it to be a string when we use it in string output. After that, I'm going to use Shift-Alt and the down arrow in VS Code to copy that line down, but now I'm going to change you to Python, and then we'll say Python chose, and here we'll put the computer choice. And now we've stated what the computer chose as well as what we chose, or the user. And then we'll just once again print another blank line just so we get a little room. So let's save all of that. And now over here in the terminal, let's type clear. I'm using the Python terminal here, we see. So I'll type clear, and that should clear that out. So now we have some room again. I'll go ahead and click the play button. And it says enter 1 for rock, 2 for paper, or 3 for scissors. Let's enter 2. Press enter. And it says you chose 2 and Python chose 3. So it's working as expected right now, but it's not telling us who won. So now we need a larger control flow statement to determine who wins. So let's just start by building a simple one, and we can change the logic as we go to make it make more sense and apply to the game. But just to look at how a larger if statement could work, we could say if the player, and then we'll say double equal sign here, equals 1. So if the player choice is 1, then we could print you win for the user. Now, of course, that doesn't apply to the logic of the game. This is just an example. But what if it's not 1 at this time? So then we could say else, and here we could just say print, and then we would say Python wins. But of course, this won't work for our entire game, but at least it shows how an if-else works. We can also add more to this statement. So let's go ahead and do that now and apply the full game logic. And so if player chooses 1, that would be rock. And then we would say also, and the computer choice equals 3. So we chose rock as a player and the computer chose scissors. So rock beats scissors, and then actually the user would win. So let's go ahead and copy this down. I'll highlight both lines. I'm going to press Shift Alt and the down arrow. Now it gives us another line, but we can't have 2 if statements back to back. We need to say else if here. And in Python, we do that with elif, so ELIF. So now we can say if player chooses 2 and then the computer chooses 1, that means the player chooses paper and the computer chooses rock. Once again, the player would win. So you win is the appropriate output. Finally, let's highlight this one more time and do Shift Alt and the down arrow so we can have multiple else ifs, this elif statement. We can only have one else, we can only have one if. In between, we can put as many elifs as we need. And here I'm going to say if the player chooses 3 and the computer chooses 2. So now the player would choose scissors and the computer would choose paper. Once again, the player would win. But there's other cases, of course. There is the choice that any other choice there would be where Python wins. But what if they both choose the same thing? So we have one more elif to put. And let's go ahead and instead of copying that down, I'll just type it here. elif, and now this would be if the player value is equal to the computer value, then we're going to have print tie game. Now we've covered each option. So we've covered the 3 options that would let the player win, and we've covered the tie, and anything remaining, anything else, allows Python to win. Let's go ahead and save our Python file one more time, and we'll press play to run our code. So it says enter 1 for rock, 2 for paper, 3 for scissors. I'm going to enter 2 once again. And it says you chose 2, Python chose 3, Python wins. So Python chose scissors and I chose paper. Let's run it again and see if we can win this time. I'll choose 1 for rock. And it says Python also chose 1. We have a tie game. You could continue to test this to ensure your code is working as expected. Let's do a couple of more things that could make our game just a little more appealing, even though it's a simple game at the command line. One is to use some emojis in here in our print statements. Now I'm on Windows, and I can press the Windows key and the period here in VS Code, and I get an emoji menu. And I want to use celebrate, I believe is the name of it. So I'm just going to type the word celebrate. And as I see, it starts to narrow down here to the emojis, and I just want the little celebration emoji. So that is the you win, and I'm going to copy that in the space and paste it into each of the you win statements. Now for a tie game, we would want something different. So let's go ahead again. I'm going to press Windows key plus the period. And here I want like a wow face. Yes, wow, tie game. So we have a space there. And now Python wins. We need to give Python a snake, of course. So once again, Windows key period. I'm going to type snake and narrow it down to Python. Give a space. We save the file. Let's run it one more time and see what we get. Now I'll choose 1 again for rock. And we tied, and we have the wow emoji. Let's do it again and try to see if somebody can win one here. 3 for scissors. Oh, Python chose 1, rock, and rock beats scissors, so Python wins. So do you notice what I'm doing at the end of the game? I'm translating here. I said you chose 3, Python chose 1, so I had to translate scissors and rock for the numbers. What if we could get it to say you chose scissors and Python chose rock? So we could improve our game just a little more. To improve this, I'm going to introduce you to Python enums. So I'm scrolling back to the top and we need to import enums, but it looks just a little different because we don't want the entire module. We just want enum. So we're going to say from enum, which is all lowercase, import enum, starting with a capital there. So notice the difference. And now I'm going to use the class syntax because that's what we would use with enums, but they're different than other Python classes, and we will cover classes in the future. But I'm going to type class, and I'm going to name this RPS for rock, paper, scissors, and pass in an enum here and put the colon after it. So that may look a little strange, but just know it for now, and then in the future we'll learn more about classes. After that, I'm going to use all caps here, which is the tradition as we name constant variables, constant data that does not change. So I'm going to set rock equal to 1. On the next line, I'm going to set paper equal to 2. And on the last line, I'm going to set scissors equal to 3. So the syntax for constant data is all caps as the tradition. And this data is not going to change. So we have no plans of reassigning the rock variable a different value. And so now when we use our enum, we can pass in these numeric values. And I'll show you what I mean just by putting it here at the top of the program for now. So let's say print, I need lowercase now, print, and then I would want to use my enum. So I would say RPS, and then I could pass in the value that we have. And notice our value down here was player. So if I had a value in player, I would pass in player. But here, let me just pass in the number 2, save our code for now, and I'll go ahead and press play, and we'll see what gets output at the top. It says RPS paper. So by inputting the number 2, we got RPS dot paper return, but it did return the paper value. Of course, it still wants to play the game. We did not exit the game after that. So let's go ahead and choose the number 2, press enter, hey, and we won. That's great. But let's look at some more ways we can get data from our RPS enum here. So I'm going to go ahead and press Shift Alt and the down arrow 3 times, and we can look at this in different ways. So we could also be printing RPS.rock. And after that, we could also say RPS and use bracket notation and then pass in rock as a string. And finally, we could say RPS.rock and then .value in lowercase. Now, after this, just so the game does not play once again, I'm going to use our sys exit just to exit for now. And notice how VS Code then made all of this a lighter color because it knows the rest of this code will not execute after I put the exit statement here. This is just temporary, so we can check the different ways that we can get values out of our enum. So if I save this, let's run our Python code again, and you can see the first time we had RPS paper, and that's what we had before when we passed in the 2. The second time, we got RPS rock when we said print RPS rock. The third time, we got RPS rock again when we used bracket notation. And the fourth time, when we checked the actual value of rock, that's when we got the number back. So if we want to get the number or whatever value is over here, it should be from typing RPS dot whatever the enum name is, and then we should get the number that is associated with it here by typing .value. So the different ways you can get that. What we're going to do, as I mentioned before, is pass in the player value right there, and of course the computer value as well. So let's go ahead and delete these and finish completing the game. So we want to use these in our string outputs for the game. So let's go ahead and look at the you chose and player choice. Now here we needed to pass in a string before, and that's what player choice and computer choice both are before we casted those into integers. But now we're actually going to use our enum and the integer. So let's do that. Instead of player choice here, I'm going to cast to a string, and I'm going to pass in RPS, and I'm going to pass in the player value. And then we could do the same here with the computer choice, remove it and say string, and then we could say computer, and then we could, oh, I left off the RPS. Let's go ahead and say RPS, and then of course we need computer. And now we should get our RPS rock, RPS paper, RPS scissors. Let's go ahead and play the game once and see what we get. We're running the game, it says enter 1, 2, or 3. Let's enter 2. And it says you chose RPS.paper, Python chose RPS.paper, tie game. So that looks good, except that RPS dot is kind of strange for a user. That's not a great user experience. I'm going to go ahead and type clear here once again. Let's go ahead and remove that RPS. And we can do that with one of the methods that we learned about in our last lesson. So here I'm going to use dot replace, and this is a string method, and we're going to replace the RPS dot, and then we'll put a comma, and the replacement is just an empty string. Now let's do the same here. So I'm just going to copy this, Control C, add it to the end of our string there, and Control S to save. Now let's run our code one more time and see what we get. And we've got 1, 2, or 3. I'm going to choose 3. We enter. You chose scissors. Python chose scissors. Tie game. We can't end on a tie game. Let's run this code one more time. I'm going to enter 1. Another tie game. Let's run one more time. 3. Python wins. Well, I didn't win, but I didn't want to end on a tie. So now you've built your first game. You've learned about user input and control flow with if, else if, and else statements. And we also added in one more data type that you learned about, and those were enums. Hey, before we get started on today's lesson about lists and tuples, I want to go back and make one correction in the previous lesson. I did make an annotation there. I've already changed the GitHub source code, but if you missed that annotation or haven't looked at the source code, I just want to change this for you. On line 18, where we check the player with an if statement, I wasn't thinking and I used the bitwise or. We should have just used the actual word or right here. This will make all the difference as far as how this if statement works for you. We're learning about lists and tuples today, and you can see I have an empty folder named Lesson 6 over here in the top left. We're going to create a new file, and let's name this file lists.py. And then before we type any code inside of our Python file, let's go ahead and move the terminal, which I can open with Control and the backtick. Let's move it to the right if you don't have it over on the right side. So I'm going to choose View and then Appearance, scroll down to Panel Position and choose Right. And now our terminal is over here, our Python file's here, and then I'm going to press Control B to go ahead and hide the file tree that was over here. Now, lists are one of 4 collection data types in Python, and what they do is hold multiple values, and then we can reference those values with a common name. So for example, I could say users, then I could set this equal to a list, and inside the list I could put Dave and maybe John, and how about Sarah? So now we have a list of users, so 3 values in one list, and we just refer to it as the name users. But of course, it's not limited to just string data type or any one data type. So I could just call a list here data, set this equal to a list that has, say, my name, number 42, and Boolean data like true, and that's also a valid list. Or it can even be empty, so I'll just call this empty list, and I'll set it equal to an empty list, and that is also a valid list. So now let's say you're working with one of these lists, but you don't know what's inside it, and you want to check to see if a value is inside of it. So let's do that. I'm going to use a print statement here so we can see the output, and I'll just say Dave, which is a value that's in 2 of our lists, and I can say in users, and let's see what we get in the console. After we Control S to save our file, Then we can go up here by our play button and choose Run Python File, and let's see what we get. It says true over here. So yes, Dave is in users. So let's switch this to data, Control S to save again, and I'll click the play button, and we've got true again. So now let's see if Dave is in the empty list. Control S to save, click play, and that output is false. So now let's say we want to get a specific item from a list and we know what position it is in. And we have to remember that lists start with a 0 index. So Dave would be at the 0 position. So here I could say users, and then I can use a bracket and put 0. Now this should print Dave to our output terminal over here. So once again, click play. And we've got false because we had that above, and now we have Dave as well. And now I'm going to copy this down by clicking on line 9 where you see my print statement, and use Shift Alt and the down arrow to just copy that line of code. And now instead of using the position of the value we want, if we want to know the last value in our list, we could also use a -1. So I will save that and run, and let's see what we get. Yep, we've got Sarah, which is the last value in our list. So likewise, we could use a -2, and now let's run this code again, and we've got John. So it does accept negative numbers also. Now, if we want to know the position of a specific value, we can use a method. So I'm going to say print, and I'll say users once again, and then dot index, and let's find out the index of Sarah inside of the users list. So now that I have passed the string Sarah to index, we get position 2 returned here in our output. And now what if we want a range of values? Maybe we want the first and second value. We can also do that. So I'll start with print once again so we can see the output, and I'll say users. And now with bracket notation, let's start at 0. And let's go to the second position. But note, this will not include the value at the second position. So save and run the code, and we get a list returned that has only Dave and John from the 0 and the first position in our list. And now I'm going to copy this code down again with Shift Alt and the down arrow. And let's say we wanted everything from the first position to the end of the list, no matter how many entries were inside of our list. Well, then we just wouldn't provide an ending value, but we would start at the first position. So now I'll say Control S to save the file again and run this, and notice we get John and Sarah. So by providing the first position here in the first slot of the range, it does include John. However, when we provided the second position as the last slot in the range, it did not include Sarah. And now, as you might guess, this could also accept negative numbers. So let me provide a full range here, like -3 to -1, and let's see what we get. So I'll save this, run the code, and we got Dave and John again. So that is the same as saying 0 to 2, because it did not include Sarah because she's at the -1 position, but it did start at the -3 position, which is the equivalent in our list to 0. I'm going to scroll up for a little more room, and we should note we can use the length function, which is len, and then use parentheses, and pass in a list like users, or we could pass in data that we created above, and this will return the length of our list. So I'll Control S to save, run our code again, and you can see we've got 3 here because we have 3 items in the list. So note that doesn't start counting at 0 like the index of our list that has 0, 1, and 2 when we have 3 items. It actually returns the length, which is 3 because we have 3 items in the list. And now let's say we have an existing list like users, and we want to add more items to our list. And we can do that with the append method. So I'm going to say users.append, and I'm going to add Elsa to our users list. And then I just need to print users so we can see the end result. Control S to save, run the code, and now our list of users has Dave, John, Sarah, and Elsa in the list. And what if we have another list that has users and we want to add those to our previously existing users list? I will show you a couple of ways to do that. One is to take our list, users, and say plus equals, and then add the other list. So I'll create another list here, and I'll put in Jason inside of this list. So a list with just one item. And then we'll once again need to print users to see the output. And then we'll run the file. And now our users list has Dave, John, Sarah, Elsa, and Jason. So we added those two lists together, if you will, because this is a list, although it only has one item, and we had a previous list named users. Now the other way to do this is with the extend method. So we could say users.extend, and I could pass in another list. So I could say I've got a list with Robert, and let's put somebody else in here. So after Robert, let's just pick another name, say Jimmy. And now we're adding this list to our users list. So once again, I'll need to print users to see the end result. We'll run the code. And now we've got a lot of people in our list because we've got Dave, John, Sarah, Elsa, Jason, Robert, and Jimmy all in our users list. And now something to note about this first method here. Make sure if you use this that it is indeed a list, because if you were to do this without the brackets, let me go ahead and delete these, and then we'll run our code. Let's see what happens in the output. Notice it entered every individual letter as a list item from Jason's name. So that's not what you want. You want to make sure you have brackets here if you're using the plus equals, because if not, it considers every letter and item to be added to that list. Now here I created new lists to add to our users list when I used extend or when I used the plus equals above. But we could also just pass in a pre-existing list. So let me do that now with users.extend, and I'm just going to pass in our data list. Now we'll print users once again, and I'll run the code, and let's see what we get. Now our previous list had Dave, 42, and true, and that's all been added to our users list. That may not be what we want, but of course it does work that way. So you can just pass in a list name because we're referring to that full list up here as data, and that also works. We really don't want this mixed data in here though with 42 and true. It's a valid list, there's no problem with it, but it doesn't make sense as users. So I'm just going to highlight both of these, press Control and the slash to comment out both lines at once. Now, something to note about all of the ways we added to our list, it added the items at the end of the list. And so we see all the new items here at the very end of each list, but we can pick our spot. I'm going to scroll up for a little more room so we can add to our file, and I will type something like users.insert because we're going to insert into our list, and this is the insert method. I want to insert at the very first position, so I'll say 0, that's the index position, and I'm going to put Bob's name in our users list. So I will print users once again, and we'll see if Bob is added to the beginning of our list when we run the code. And yes, we see Bob now at the beginning of the list. We can also use bracket notation, so I'll say users, and after that bracket notation, and I want to insert maybe more than one value at the second position slot. I don't want to replace any of the values that are in our list. I just want to insert 2 extra values. So I've picked the second position, and notice how I say it's not only going to begin, but it's going to end right there. So I'm not replacing any of the other values. And now let's have a new list, and I'll put in Eddie and Alex, and we'll print users again so we can see that output. Save the file, run the code, and we should see Eddie now in the second position, Alex in the third position, but we didn't lose our previous values here where we had Dave, John, and Sarah inside of, here's the first position, second position, Sarah in the third. Now Dave is still in the first position, but now John has been moved from the second position to the fourth position, and Sarah is still there as well. So this insert just made room for Eddie and Alex, and we once again picked our spot. But now let's look at how we can replace values. So here I'll say users, and we'll use bracket notation again, and we'll start at the first position and we'll end at the third position. Now let's set this equal to another list, and here we'll put in Robert, and let's put it, well, we have a Jimmy already, let's put in JPJ. That should work, and we'll print users again. And let's see what happens to the last version of our list compared to the one before it. So now Robert is in the first position and JPJ is in the second position. So we replaced Dave and Eddie, what was in the first and second positions. It stopped at the third position, but notice it did not replace what was in the third position or who was in the third position, and that was Alex. So it works much the same way as we return values, how we specified this range in here, and this is also referred to as a slice. So we're referring to a slice, but here we were very specific, saying start and end at that same position. So it did not replace any of the other values, but this actually did replace two values in our previous list. Now, if we can add data to a list, we should be able to remove it as well. So let's go over how we do that. I'll scroll for some more room. And the first thing we'll do is look at the remove method. So I could say users.remove, and I could specify the user that I want to remove from my list. I want to remove Bob. So let's check the list afterwards, again with a print statement. Run, and we'll check our list. And now Robert is the first position here in the index position of 0. Previously, it was Bob. So Bob is no longer in our list. Now we can also pop off the last user from the list or the last item from any list, and we do that with the pop method. But I also want to point out that the pop method will return that value even though it removes it from the list. So here I'm just going to say print users.pop, and we'll call that pop method. And then let's run the code, and we'll see that it actually returns Jimmy. Jimmy was the last value in our list. But now if we look at our list again, and I'm just going to Control-C to copy and Control-V to paste this down here. We'll look at the list value afterwards. So we have Jimmy here, but Jimmy is no longer in our users list. Now we can also delete a specific user or a specific item from a list with the keyword del, which stands for delete. So I'll say users, and now I can specify the user that I want to remove from the list. Let's once again just go to that first position in the list, the 0 index. And so now this should delete Robert from the first position in our list. And of course we won't know until we once again print the users list afterwards. So I'll paste that down there. Let's run our code and let's check the list. And yes, JPJ is now first in our list. Robert is no longer first. You can also use this delete keyword to delete a list completely. So let's go back to that data list, and I'll say del for delete and then data. And now let's check this by trying to print the data list, and I'm expecting to get an error. Let's see what happens. We run our code, and yes, Python doesn't like that. It says data is not defined. So we deleted it entirely. Even though it's defined up higher in our file, by the time we get to this print statement, it is not defined. So I'm going to comment this out, and instead of deleting it and causing an error like that, I'm going to use the clear method. So I could say data.clear. Once we call that clear method, it will empty our list, but the list will still exist. So now when we run this, it returns an empty list here on line 52. Now that we've added, removed, inserted, and modified lists, maybe we want to go ahead and sort those lists as well. So let's scroll for a little more room. And underneath our last clear statement and print statement, let's add users.sort. And after that, we'll once again print users. And let's look at what happens to our list of users. So now it is alphabetical. We've got Alex, Elsa, JPJ, Jason, John, Robert, and Sarah. But notice something else. They all start with capitals. So what if we put something in here as lowercase? So let's do that. I'm going to do it before we sort. So I'll just put it right above here, and I'll say at users, and let's put it in the, whoops, not the curly brace, we need the bracket. Let's start at the first position and end at the second. So we're replacing Elsa with whatever we insert here. And I'm going to insert Dave once again, but make Dave all lowercase. And so now let's check out our code. And oh, I forgot to put it in brackets. This is what I warned you about. Notice it inserted the letters individually and it organized them, but they're all at the end. And that's the point that I want to get to about this, because when it's lowercase, it comes after the uppercase. So I'll save this and run it again. And now we can see Dave is at the very end of the list. So what we want is Dave inserted alphabetically here as well. And we can do that. We just need to change what we're doing. And by the way, we replaced Alex with the insert because Alex was in the first position. John is still in here, so Alex was replaced by the lowercase Dave. Okay, so since we have determined that lowercase comes after all of the uppercase, we need to pass something to the sort that will help Dave get inserted in the correct order. Actually, Dave is inserted at that first position, and then it is sorted. So we're just going to do another sort after the first one here. So I'll copy both of those, put it underneath, but we need to pass in an option here to the sort. So we're going to say key equals str, which stands for string, dot lower. So once we do that, and we go ahead and run our code again, we can see that it is now in an alphabetical order, and Dave comes first just because it is a D. The letter D comes in the alphabet before E. So really what we needed to do was pass in this key equals string dot lower to include the lowercase in the correct alphabetical order. Note these are all strings also, so if we were sorting two different data types, it really wouldn't work as expected. It should be all the same data type. You couldn't call this on a data type that wasn't string even. So you need to make sure you have the same type of data when you're sorting it. So now, speaking of that, let's look at some numbers. I'm going to create another list called nums, and inside of it I'll put 4, 42, 78, 1, and 5. Just some random numbers, really. And after that, we'll say nums.reverse. Now, this is different than sorting. It actually flips the array, and I want to look at this because I don't want you to confuse the reverse method with reverse when we pass it into our sort function. So nums.reverse, and we will print nums, and you'll see that the array, or not the array, the list, this looks just like what I call an array in JavaScript, but it's a list in Python. So our list is now in the reverse order of what it was over here in our code, beginning with 4 and ending with 5. It now begins with 5 and ends with 4. So we already know how to sort something in the ascending order with numbers, which would be just to use the sort method like we did on users. So it would start with 1 and work its way up to 78. But now let's sort in reverse with our nums array. And to do that, I need to say nums.sort, and I'm going to pass in reverse equals true. And after that, let's print nums once again. And we'll see that it's different than it was with our reverse method that just flipped the list around. So now when we run the code, we actually get it descending instead of ascending. So it's 78, 42, 5, 4, and finally the number 1. Something we need to note about all the different sort approaches we have used here is that they modify the existing list. So notice when I print users after I have sorted, I'm just printing the list. So it has definitely changed. It doesn't keep the same order that it previously had. And the same with any of these others. I'm just printing nums after as well. So what if we want to keep the original list the way it was, but yet sort the list just for an individual purpose? Well, we can do that. There's a couple of ways. One is to use the global approach here, the global sorted function. So I'm needing to print now because it's not going to give me a second line that I could just print nums, for example, with, because it's not going to change if I print nums after. So I'll do that as well, but I'm going to call the sorted function, and I'm going to call it on the nums list, and then I can just pass in my option right here. So reverse equals true as well. I'm going to comment this out so we didn't modify it before. So when we did use nums, we modified it here, and we'll see that print. I'm going to actually print the result of the global sorted function here, and we pass in nums and then pass in our reverse option right there. So now let's run our code. We should see really the same thing we returned from this, except our original array is not modified. So if I were to print nums once again after this statement, it should still look like it starts with 5 and ends with 4. So let's try that. Print nums here and run the code again. And yes, so here is our sorted array, but here is the, I said array again. I'm going to occasionally mess that up because I'm talking about lists, but it looks just like an array in JavaScript. Here is our list, and this is the same order we had before we sorted it. So this does not modify the original, it just returns that sorted list for that one time, and that's using the global sorted function. Now, another approach we could take is to make a copy of the original list and then sort that copy, so we would still have our original list. I'm going to scroll just a little, and I'll show you 3 different ways to make a copy. One, I'll call this nums copy, and we'll set this equal to our list nums dot copy, and that will create a copy. We could also say my nums, and we'll set this equal to the constructor here for a list, and now we'll just pass in nums, and this creates a copy of our original list nums. And the third way we could do this, and I'm just randomly naming these things here, so I have my copy now. We'll set this equal to nums, and we'll specify an index range here, but really we're not going to specify the beginning or the end. So it's just going to slice the full list and store it in my copy. So it's once again a copy. All 3 of these are actual copies of the original. So now let me go ahead and copy our print nums here, and then I'll paste it here, and then I'm going to use Shift Alt and the down arrow 3 times. So I have 4 print statements. The first one's going to be the nums copy, and the second one is going to be my nums, and the third one should be my copy. And after I pay, ooh, that's not right. Let's paste that in. And now let's go ahead and print all of these lists, and let's see what we get. So they all kind of look the same here after we printed those, and it should be the last 4 actually, but they're not all the same. And that's because these 3 are copies. So let's go ahead and sort any one of these here. So let's just call sort on the third one, and we'll see that our original nums still does not change. Oh, and I tried to print the sort statement. What I should do is sort right before, and then I should just try to print my copy. So there we go. Let's remove this. So my copy.sort, and then print my copy. And that's why we had none there instead. So let's do this now. There we go. So here is the sorted my copy list, but here is the original nums list. Just a couple more things before we're finished with lists. One is to go ahead and say that we can check the type of lists, just like we did any other data type. And that is, say, with type, and then we just pass in our list. So I'll pass in nums. And now when we run this, we will see that it is a class list type here. So this is our data type that we received from the type function. After that, we can also, or we should also note that we can create a list, much like we did up here, by passing in a list or a list structure to the list constructor. And that's how we created the copy of my nums. But if I wanted to create a new list, and let's just call this my list, I could use that list constructor, and then inside I would just create this list. And so I'll say something like 1, and we'll put in Neil, and then let's put in a true. And after that, we should be able to print my list as well. Now notice earlier we didn't really use that constructor, and we were still able to keep the list or create the list, but it should be noted that you can create a list this way as well. So let's save that, run the code one more time, and here is the list we created with the constructor. And that covers lists for today, but the next data collection type we'll look at is tuples. So let's start learning about those. Tuples are very much like lists, except the data inside the tuples will not change, and the order the data is in will not change. So let's create a tuple, and we can do that with the constructor. So we'll type tuple in parentheses, and then we need parentheses again inside of this, and I'll just put in some random values as well, much like I had for the data list above, I guess. And now we have created a tuple with the constructor. We could also create it without the constructor. So here I could say another tuple and just set this equal to one set of parentheses, and I'll put in some random numbers. This is also a tuple, and we can verify that. So let's go ahead and print one of these. I'll say my tuple, so we just see what it looks like when it prints out. Then let's print the type function again, or the result of the type function when we pass in my tuple. Then I'm going to press Shift Alt and the down arrow, and then I'll put another tuple in here as well, just so we can verify both of these are tuples. And here we'll run the code. So we see here is the output of the tuple. It has parentheses instead of brackets. And then you can see both of the tuples we created when we check the type do indeed say tuple. Now, most of what we've already learned about lists also applies to tuples, but we have to keep in mind that tuples cannot be changed. However, if we need to do something with a tuple, we can get creative and copy it. So let's look at how we do that. First of all, I'll create a variable here called new list. I'm going to set it equal to the list constructor, and then I'm going to pass in my tuple. So this will create a new list out of my tuple. And then I'm going to say new list, and I'll append a new value, and I'll just add the value Neil. After that, now let's go ahead and create a new tuple, and we'll set this equal to the tuple constructor, and we'll pass in the new list. So now when I print new tuple, we'll have a new tuple with the value Neil added. The original tuple, my tuple, will not have changed, but we'll have a new tuple that did add the value that we needed to add to that. So now let's go ahead and run the code, and we see our new tuple here that has Neil added to it. When we assign values to a tuple, as we do with another tuple up here, that is called packing the tuple. So likewise, we can unpack a tuple, and we can unpack it into new variable names. So I don't have any specific name picked out here. I'll just call the first one 1, the next one 2, and let's call the last one here hey, but I'm going to start it with an asterisk, and you'll see why. So I'll set this equal to another tuple, but we are unpacking. You can see we're putting values into these variable names. So now I'm going to print each variable name. So I'll print 1, print 2, and I'll also print hey, and let's see what each one of these holds. So when we run our code, variable 1 holds the number 1, variable 2 holds the number 4, and hey holds the remaining values. And notice they're unpacked into a list. But it doesn't have to be the last one either. So we could remove the asterisk from hey and instead put it in front of our variable 2. And now let's go ahead and save and run this code again. And you'll notice now we get the value 1 inside of the first variable, and the value 8 is inside of hey, but everything in between goes to the variable 2, and it's a list, so it has the values inside of a list. A final note about lists and tuples in VS Code, and that is we can check what methods are available on a list or a tuple just using dot notation. So I'll say print, and I'll pull in the data list that I had earlier, and type a dot, a period, and then we see a list of all the different methods that we can call on our list that is called data. So that is one way to check what methods are available. So let's put in the name of our tuple. So we had another tuple, and I'll once again have to delete the period, type it again. You can see that a tuple only has two methods, count or index. So let's call count, and we need to put the parentheses after it to call it into action, and it needs something passed to it, one parameter, and one argument, if you will. And what I'm going to pass is another tuple holds numbers. If we look up here, we put in the number 1, 4, 2, and 8. I'm going to put in the number 2 more times. And now let's go ahead and pass in 2 to count and see what we get back. So when I run the code, we get 3. So it's actually counting how many occurrences of the number 2 are inside our another tuple. I've got Visual Studio Code open, and I've got a new folder over here in the file tree for Lesson 7. Let's create a new file. Let's call this Dictionaries. Then after that, we'll end it with a .py, .py. And then let's open a terminal window with Control and the backtick. And you can see mine opens here at the bottom, but I'm going to choose View and then go to Appearance, go to Panel Position, and choose Right. So it's over here on the right. Finally, I'm going to press Control B to hide the file tree. So we have our code here on the left taking up all of that part of the screen. And on the right is where we have our terminal window. Today we're talking about Python dictionaries. So I'll just put dictionaries here at the top. And really, dictionaries are used to store data values that are in key value pairs, and you'll see what I mean. And just like when I accidentally called Python lists arrays a few times, Python dictionaries look a lot like JavaScript objects. And so I may accidentally refer to them as objects when I'm talking, but if I do, it's unintentional because we're talking about Python dictionaries. So let's look at an example. I'll set band equal to a dictionary. Now they have curly braces, and here's the key. I'll say vocals, and then I put a colon, and after that I put the value. So I'll say plant. Now I'll put another key, and here I'll say guitar, and then I'll put the value, and I'll say page. So that is a Python dictionary. And of course, you could have more key value pairs. It's not limited to 2. You could make a large one if you want to as well. And it can be different data types. It doesn't just have to be a string as the value. Now here I typed out this dictionary. Let me create a second dictionary that has the same values, but I'm going to use the constructor function for a dictionary. So I'll call this band2, and I'll set this equal to the constructor function, which is dict, then use parentheses, and then I'll say vocals equals. Then I'll put in plant. After that, a comma, and I can say guitar equals, and I'll put in page. Now we'll be able to see that both of these create essentially the same structure for a dictionary here. So I'll print band, and then I'm going to use Shift Alt and the down arrow to copy that line down, and then just print band2. Well, I've typed in 3 a couple of times. Band2 is what I want. There we go. Control S to save. We'll run our code here. And, oh, I got an error. Python was not found. Let's first run it using run Python file the first time. There we go. After that, we should be able to click play. So we've got the same structure here. Here is our first dictionary, band, and just below it is band2. They look the same. You can create dictionaries in either way. We can also check the type. So I'll say print, use type, I'll pass in band. Now I'm going to use Shift Alt and the down arrow one more time. And here, instead of type, I'm going to use the length function once again, because we can also check the length of a dictionary. So now when I run this, we see the type as well, and we see the length. So it's saying it has 2 key value pairs inside of the dictionary. I'm going to scroll for just a little room, and now I'll put another comment because I want to talk about how we access items in a dictionary. There's a couple of ways to do it, and I'm going to use a print statement so we can see the output. But we refer to the dictionary, such as band, and then we can use brackets, and then we can name the key, and the output will be the value. The other way we can do this, and I'm going to copy this down again with Shift Alt and the down arrow, but is to use band.get. And that is a method that we can call on dictionaries, and then we pass in the key once again. So I'll pass in the key guitar here. That's going to return the value that is paired with guitar. So Control S to save, run our code, and you can see we get plant from our first print line, and we get page from our second. And those are the values that are aligned with those keys in our band dictionary. Now, what if we want to list all the keys? So let me put in another comment, and I'll just say list all keys. Here, I would say print, and then band, and then dot keys. And then I'll save, and we'll run the code, and let's see what we get. So here, we get a list of dictionary keys. So we get vocals and guitar. Likewise, we might want to list all values. So I'll say list all values here in the comment, then print, and as you might guess, it's band.values, and we can run that code, and now you can see we get a list of the dictionary values, plant and page. We can also return the key value pairs as tuples, and so here I'll say list of key value pairs as tuples. And now I'm going to say print, and then I'll just say band.items. And let's run this code again, and you'll see what I mean when we get the output over here. It's the dictionary items. Now, inside of this list, each item is a tuple. So you see vocals, plant, and then you see another tuple that says guitar, page. Now, just because these are wrapping down and it looks a little strange, I'm going to see if I can drag this window over a little, and it might make our console a little easier to read because I'm not going to usually need to type past about this width. Okay, so our dictionary items wrapped down, but The keys and values, for example, did not. So this is just a little easier to read here. Now, one more thing we might need to do is verify if a key exists in a dictionary. So that's what I'll put here. Verify a key exists. And now we'll say print, and we can just see if guitar is in band. Now let me do another one. So I'll shift alt and the down arrow again. And instead of guitar, I'll look for triangle. Maybe I should have looked for cowbell. Let's run this. See what we get. So first, guitar in band is true, but triangle in band is false. Let's scroll for some more room again, and we'll look at how we can change values in a dictionary. So I'll put change values here in my comment, and after this, I'm going to say band, and then I'm going to specify the vocals key. So I'm using brackets and then the key once again, and I'll set this equal to Coverdale. Now that would set the key value pair to vocals Coverdale instead of vocals plant. So the value for the key vocals has changed once I do that. Now, something else you can do is use band and call the update method. But now we need to pass in curly braces, and we need to give the key as well. Now, we could update vocals or guitar here, but we can also create a new key value pair. So that's what I'm going to do. And I'll make this bass, and then I'll pass in the value JPJ. And then if we check our band afterwards, we should see we have changed vocals to Coverdale, and we should have added a new key value pair as well that says bass and JPJ. So let's run this code and see what we get. Here is our dictionary. Now it has vocals Coverdale, guitar page, bass, JPJ. Now what about removing items? So I'll comment that as well. Remove items. So we'll print, and then I'm going to look at band.pop. Now the reason I'm printing is because pop will return a value. It will return what we remove from the dictionary. So here I'm going to say bass. And so we'll see what gets returned or what gets output here from the print by doing band.pop bass. And so after that, I need to go ahead and print band one more time, and let's run this. And you can see we don't get a tuple or the full key value pair. Pop does return the value, though, of what was removed, because then we print band afterwards and we see it no longer has bass JPJ in the dictionary. That key value pair has been removed, but pop only returns the value. Now I'm going to add a new value like we learned before. So I'll say band, use bracket pairs here, and add drums. I'm going to set this equal to Bonham, and after I do that, I'll go ahead and print the band again just so we can see that the new value has been added. But now we'll also print, and then we'll say band.pop item. If I spell item correctly, what pop item does is it removes the last thing that was added, the last key value pair that was added to the dictionary. But what we will see is this is going to return a tuple. So I'll print band here as well. So what we last had was the removal here from bass, did JPJ, and then it once again had our dictionary down to two key value pairs. So we'll see this twice afterwards as well. Save and run the code. Now let's look at what we get here. So we added Bonham, and then we print band, and that's what we should see here is a dictionary that has vocals, guitar, and drums, and the value for drums is Bonham. Then we used the pop item method, and so it removed what was last added, the full key value pair, and it returns it as a tuple. And that's what we see here. So then when we finally printed band here the last time, our dictionary is once again back to just vocals and guitar. Now this deals with removing items from a dictionary. What if we want to delete or clear items? So once again, a comment here, and I'll put delete and clear. And then if we want to delete an item, first I need to add that item again. Let me just copy this from above here on line 41. We're going to add key value pair of drums and Bonham back to our band. And then after that, let's go ahead and delete with the keyword del, and I'll say band and say drums. And you can see Visual Studio Code wants to help me. It knows what's in the dictionary, so that's very useful. Don't always have to type that out. So now we're deleting that from the dictionary, and I can print band once again, so we will once again see that it has been removed. What we could do though, and remember we created another band up here at the top. We've also got band 2. So what we could do is empty out a dictionary completely by using band2 as our dictionary and then saying clear, the clear method. And then I'll print band2, which should be an empty dictionary. So we should just see the curly braces. And after that, I'm going to delete band2, delete the entire dictionary. And we do that with the delete keyword also, but we don't specify any specific key. We just name the dictionary and it completely deletes it. So I can save and run this, and we won't see everything that we just had there. We'll see the print once again of the band dictionary after it just has vocals and guitar. We'll also, I guess it's this line right here. We'll also see the empty band2 dictionary, and that's why we just see the curly braces. There is no output after we delete the band2 dictionary. It has just been deleted from our application. Now let's scroll up and talk about copying dictionaries. So here I'm going to leave a comment and say copy dictionaries. After this, I need to talk about the way not to copy dictionaries first. So let's say band2, I'm going to create a new band2 because I just deleted it above. If I set this equal to band, that doesn't really create a copy. It creates a reference. And so I want to put this here, creates a reference. And what that means is they're both referring to the same place in memory for the same dictionary. So after you create band2 and you add or remove something to it, it's going to also add or remove the same thing to band. So this is why we don't want to do this, because they actually refer to the same thing. View it as a place, a storage place, and both of these variable names are referring to the same thing. So what I'm going to do here is say print, and I'm going to say bad copy, because you really don't want to do this. And I'll give the example of what it actually does. So here I'm going to say print band2, and then I'm going to use Shift Alt and the down arrow, and we'll also print band. But after we do that, let's go ahead, come down an extra line and say band2, and then we'll put in drums. So we'll add drums to band2, and I'll set drums equal to Dave this time. After we do that, let's just print band once again, because we didn't do anything to band, right? So you wouldn't expect it to change. Let's go ahead and run the code and see what we get. So we can see band2 is the first one we print right after it says bad copy, and then band1, and they look the same. But then we add drums to band2 with the value of Dave, but we just print band. Well, that last print of band already has drums and Dave in it. So this is what you do not want to do. So I'm going to comment these things out. I'll just highlight all of those and press Control and the slash, and it will add comments to all of those lines. But I did want to show you that because that's not the way you want to create a copy. So how do you want to create a copy? Well, let's go ahead and say band2 equals band.copy, and we can call that copy method. And now they will not have the same reference. So I can say band2. As a matter of fact, I can just copy these lines, Control C, speaking of copy, and then we'll go ahead and paste them in with Control V, and then I'll print band here. And after that, I might as well print band2 as well, so you can see that they're different. So we're just adding drums to band2 again after we use the copy method. Now let's run this code. And what happens is we have band here, the first one, and then we have band2 on the next line, and only band2 has drums with the value of Dave. But both were printed after we added drums to band2. So to be consistent, I guess I should add the line here, good copy. And I'll leave the commented lines inside of the course code as well. So if you're getting this course from GitHub at the course resources link, you'll be able to see this. This is what you do not want to do. And that's why I said bad copy. This is what we want here with good copy. Now there is another way to make a copy, and that is using the constructor function. So let me comment that as well. I'll put or use the dictionary constructor function. So we can make a copy this way also. So I'll say band3 equals, then I'll use the constructor function and I'll pass in band. So this makes a copy that is not a reference as well. So I'm going to print good copy here as well. And after that, I'll print band3. and we'll go ahead and run the code again. And you can see we didn't add anything to band 3, but you can see it made a copy, and this is a good copy. So that's another way to do it. Okay, one more thing to discuss about dictionaries, and it can seem a little complicated when you first learn about it, but I think you'll get the hang of it after you experiment with it a little bit, and that is nested dictionaries. This means that the value for a key value pair can be another dictionary. So let's look at this, and I'll create a dictionary called member1, and I'll set this equal to, of course, curly braces, then I'll have name, and let's say plant here, and then I'll have instrument, and here I'll put vocals. Now I'm going to just highlight all of this and do Shift Alt and the down arrow. I'll turn this into member2, so a second dictionary. Here I'll make this name page, and I'll make this instrument guitar. Okay, now let's create a third dictionary, and let's call this band. And in this dictionary, we'll have a key called member1, and we'll put member1, the dictionary we created above, as the value. And let's do the same here, member2, and let's put member2, the dictionary we created above, as the value. So you can see band is going to have nested dictionaries here. So member1 is the key, but the value will be a dictionary. So let's go ahead and print this. See what it looks like inside of our terminal when we run the code. So here's our dictionary band, and well, I started one line ahead. There we go. Here is our dictionary band. It's got member1 for a key, but the value is another dictionary. Member2 for a key, but the value is another dictionary. Now, if we want to get a specific value here, we have to go one level deeper. So we'll print, and then we would say band, and let's go ahead and use our brackets, and you can see VS Code wants to help us once again, so I'm going to say member1, and then from that, I'm going to use brackets again, and now it's not helping us so much. Notice we had name or instrument, and I don't see those readily available here, so I'm just going to type name, because we want to get member1, so there we're going one level deep, and then we want to get name, so that's the second level deep. We'll save this and run the code, and you can see the output here is plant. That's because we were able to drill down into our nested dictionary to get that value by adding another bracket. And you need to do that every time you'd have a level. Could you have another level deeper and so on? Yes, you could. Okay, a final note on dictionaries before we move on to working with sets, and I'll scroll once again. I'll just type in band as our typical dictionary here. Remember, in VS Code, you can use dot notation. So type a dot after your dictionary, and all of the different methods will pop up. So you can experiment with these. We covered quite a few of these today, but not necessarily all of them. But VS Code will help you see what methods exist or a dictionary or a list or whatever data collection type you are using. Okay, now let's move on to sets. I'll just type sets here. Now, sets are the fourth and final data collection type that we are going to cover. So now let's look at creating a set, and I'll say nums equals, I'm using curly braces again, but it's not a key value pair. I'm just going to say 1, 2, 3, 4, and that is creating a set. We can also create a set with the constructor function. So I'll say nums2, I'll set this equal to set. Now we have parentheses, but now we need double parentheses. And I'll say 1, 2, 3, 4. So we've created two different sets that way. I'll print nums, and then I'll go ahead and do Shift Alt and the down arrow, and I'll print nums2. I'll do this one more time. And inside of here, I'm going to say type nums. And finally, one more copy down with Shift Alt and the down arrow, and instead of type, I'm going to check the length, because we can do all of those things again with a set. So now when I run the code, we have got our first set we created. We've got our second set we created with the constructor function. We can see what data type we have, and we see the length. There are 4 elements in our set. Now, scrolling up, we'll look at one of the top advantages of a set of data, and that is no duplicates are allowed. So I'll just type this here, no duplicates allowed. And then I'm going to say nums, once again, equals, and I'll create a set here, but it'll be a little different data than above. Notice I put in 2 number 2s. Okay, after this, I'll go ahead and print nums. What do you think we'll get for output once I put both of these in, but we know a set doesn't allow any duplicate? Let's take a look. I'll run the code, and the output is a set that does not have a duplicate at all. It didn't create an error because I put one in, it just ignored the duplicate. And that's what happens when you try to put something else in a set. So we should also note that a true value, true, is a dupe, I'll say, of 1. And false is a dupe of 0. Now I'm scrolling over, so I'm going to press Alt-Z so the code or the comment line wraps down to the next line. See how 111 is a little bit deeper here compared to the other lines, so it's all still one line, it's just wrapping down. Now I'm going to create a nums set once again, and inside of this set I'm going to say 1, true, 2, false, 3, 4, 0. So now let's think about what we might get returned, and we'll analyze this after we actually check our output here. So I'm going to print nums once again, and now nums has some duplicate data. Remember, 1 and true are considered to be duplicates, false and 0 are considered to be duplicates. Any guesses as to what will the output be? Let's take a look. And we get false 1, 2, 3, 4. So number 1 was in here first, and so it ignored the duplicate true. False was in here first, so it ignored the duplicate 0. Then notice it's in order also. So false comes before the numbers, which is also 0. So if we had 0, it would essentially be in order as well. Worth noting. But notice it did remove the duplicates when we were working with Boolean data, that true and false, because 1 is considered true usually in programming, and 0 is usually considered false as well. So those are considered duplicates in a set. You can also check if a value is in a set. And we can do that with the in keyword once again. So I'll say print 2 in nums. And if we run this code, we get back true. Yes, because 2 is in our nums set. We see it right here as well. So that is true. So you can check to see if any value is inside the set. But I'll put an extra note here. But you cannot refer to an element in the set within index position, as we had with lists, or a key, as we did with dictionaries. So you can't refer to any specific value based on a position like that, and there's also no key to refer to, but you can check to see if the value is in the set. Scrolling up again for room, let's talk about adding a new value to a set. So here we'll say add a new element to a set. And we can do that with nums.add, and then I'll just pass the number 8, and we'll print nums once again, and we'll check our set. So let's run the code, and now here's our set once again, but it also has the number 8 in there. After that, you can add, I guess I need a space between these. Let me put a little extra line there. You can add elements from one set to another. And to do that, let me create another set just called more nums. Set this equal to a set that has 5, 6, and 7 in there. Then after we do that, say nums, our original set, dot update, and then we'll pass in more nums. And I'm not sure why I put a space there. We don't need that space. And remember, see that error there? Spaces and tabs or indents are important in Python, so an extra space like that could cause problems. But here we are using the update method for nums, and we're passing in the more nums set as well. So we're adding elements from more nums to the nums set. So we'll print out nums, run our code, and you can see now our nums set also has 5, 6, and 7 added to it. I'll add an extra comment here as well underneath, and this comment is you can use update with lists, tuples, and dictionaries too. And what I mean by that is you don't have to pass in another set here. You could pass in a list to update, or a tuple, or a dictionary as well. Update will still work. Now with update, we took all the values inside of the more nums set and we added them to the nums set. But what if we want to merge two different sets and then create a new set from those two? So let me comment that here. Merge two sets to create a new set. And now I'll have to create the sets first. I'll say 1, and let me put this equal to a set that has 1, 2, 3. And then let me create another one, and I'll just copy down here. I'll rename this 2, but I want to change the values also. I don't want duplicates right now. So it's 5, 6, and 7. And after we've created both of those, let's say my new set is going to equal 1, and then I'm going to use the union method, and I'm going to pass in 2. So here we're merging these 1 and 2 to create a new set. So I want to print my new set, and we should see the merger of those two, but that didn't change the original set 1 or the original set 2. Let's look at a couple of more useful methods when we're working with two sets. So I'm going to copy lines 131 through 133 with Control-C, and I'll just paste here below again. But instead of merging two sets to create a new set, here we're going to keep only the duplicates from the two different sets. Now, right now I don't have any duplicates, so let me change the values here in 2. So we have some overlap. So 2 and 3 would be duplicates in both of these sets now. And now that I've done that, we'll say 1.intersection update, and here we'll pass in 2. Now let's print 1. This didn't create a new set, so what happens is it actually changes the first set here that we call intersection update on, 1, to only include duplicates. So we should expect to get a set that only has 2 and 3 back. So when we run our code, that's what we've got here is 2 and 3. Now kind of the opposite of that, so I'm going to go ahead and copy this down again, 3 lines that start everything. And instead of keeping only the duplicates, we're going to keep everything except the duplicates. So here's 1 and 2 as well. So 2 and 3, the numbers 2 and 3 are the duplicates, so we're not going to keep those. So now we're going to expect to return a set that has 1 and 4 only. We're going to do that with a different method. Here's 1, and then it's called symmetric difference update. Here we'll pass in the second set. Notice it's still happening or being applied to the first set that we call the method on as well. So we're going to print 1. I'll save that, and we run our code, and you can see the set that we get here is the output just contains 1 and 4. So it was the opposite of the intersection update. So that just about covers it for sets. Once again, a reminder that you can use your set and then use dot notation to pull up all the different available methods. And there's some here that we didn't cover today, so you could experiment with these as well and look those up in the documentation. Of course, is linked in the course resources. I've got Visual Studio Code open. You can see I have a new folder for Lesson 8 over here in the file tree. Let's create a new file, and let's call this loops.py. From there, let's go ahead and press Control and the back tick to open a terminal window, and then let's go to View, and from there we'll go to Appearance, come down to panel position and choose right. So our terminal window is here at the right. And then I'm going to press Control B to hide the file tree. So we can see our code here on the left in Visual Studio Code. And we can see the output and everything we run at the terminal here in the right. So when we talk about loops in Python, we can talk about two different types of loops. There's a while loop and a for loop. Let's look at while loops first. And a while loop will execute a block of code while a condition is true. So let's create a basic while loop. Let me first set a value equal to 1. And from here, I can say while value is less than 10, and then we put a colon, and now we have a block of code inside of our while loop. Notice we're indented. So I'm going to print the value, and now we must increment the value to go ahead and make it greater than 10 at some point, or if not, or at least equal to 10, the way we have this current loop set, because if not, we will have an endless loop or an infinite loop. That could crash our computer, it would use up all the memory, and it would just go on forever, and we don't want that to happen. So let's go ahead and say value plus equal 1. So now this is going to increment every time it goes through the loop, and it will eventually be equal to 10 or greater, and the loop will stop. So let's save our code. And from here, we'll use the drop and we'll choose run Python file. And you can see over here, now we get 1, 2, 3, 4, 5, 6, 7, 8, 9. It doesn't get to 10 because this says while less than 10. So if we wanted to print the number 10, we would say while value less than or equal to 10. Now we can run this code again by clicking the play button, and we get 1 through 10. So we have iterated through this loop 10 times. So it goes through the loop 10 times, printing each number. Now we can stop a loop in another way besides making this condition true, and that is using a break statement. So after this print value, let me go ahead and say if value equals 5, so I'm putting an if statement in our loop, then I'm just typing the word break. And that break statement there will stop the loop when value is equal to 5. So let's run the code again. And you can see we go 1, 2, 3, 4, 5 because we print first. So we print the value of 5 before we get to the if statement, and then the loop stops. Now I want to keep this example in here for you. So I'm just going to highlight all of this, Control C to copy, and then Control and the slash to comment that loop out. And below it, I'm going to paste with Control V. And now I'm going to show an example of the continue keyword. So instead of break, I'm going to say continue. This will stop this current loop where it's at and go to the next loop. But we have to be careful here once again. We have to think about where we're incrementing the value. If we continue here and skip to the next, then we're not incrementing that loop again. And that's important that we continue to increment that loop. At this point, it would be equal to 5, and it would just continue to be equal to 5. So that's not what we want. We better increment our value before this if statement. And let's go ahead and print the value after the if statement. And so I'm just using Control X to cut those, and then Control V to paste those. So cut instead of copy, with Control X and then Control V to paste those values. But you can see I've rearranged what happens in the loop, but now this will skip to the next iteration when it equals 5. So let's see what happens when we run our code. And you can see it starts at 2 because we don't print until we're down here. So we've got 2 through 11, and that's because we're adding 1 immediately once we get inside of the loop. But notice we didn't print the number 5, and that's because we used continue here, so it never gets to the print statement. It just goes to the next iteration of the loop. Now we can also add an else to our while loop, so I'm going to come down a line, bring the else over to the left where it's not indented, and then have a print here as well. So when do you think this else will occur? It should occur when the loop has completed, but not, note this, not if we use the break keyword. If we break the loop, the else will not execute. So only if the loop actually completes as it should, and this condition is no longer true, then the else will occur. So here I'm going to say value, I need quotes, value is now equal to, now let's concat here with the plus symbol, and then just put in our value. So I'll save this code and run it, and let's see what we get. Oh, I tried to print an integer. I should have known better. We need to use the string constructor here and make this value a string because it's currently an integer. And now we can run the code again and it will work. So we have value is now equal to 11. Okay, I'm going to highlight and press Control/ to comment out that loop as well. And let's move on to for loops. So let's make a basic for loop. A for loop iterates over a sequence, and the sequence can be contents of a collection data type that we've gone over, like lists, tuples, dictionaries, or sets, or it can even be the individual characters of a string. So I'm going to make a list first called names, and inside this list I'll have Dave and Sarah, and let's put in John as well. So we've got 3 names in our list, and now we can use a for loop to iterate over this list. So I'm going to say for x in names, And then inside the loop, we'll just print X. Now note, I'm using X here, but I could say for name in names. I could use any word or letter, just some type of character is essentially what I'm doing to represent each value in the list as it iterates through the for loop. So we'll save and run our code. You can see we get Dave, Sarah, and John all printed here in our output in the terminal. So now I'm going to scroll up just a little bit and let's create another for loop. As I said, you can go through each character in a string. So what if I said for X in Mississippi? That is a long word that most of us here, at least in the United States, learn how to spell in school, and we memorize MISSISSIPPI because it's a long one. And after this, we'll run the code and we should see each individual letter on its own line because we printed one letter of the word Mississippi each time the loop iterated. Okay, I'm going to comment these two out, but I'm going to leave our names list above. And then let's go back to this names list and let's iterate through once again. So I'll say for X in names. And then inside the loop, I'm going to say if X equals Sarah, then, oh yeah, I need my colon there. Then I'm going to use the keyword break once again, but I'm going to print X. So what do you think the output of this loop will be? Let's find out. I'll run the code and it's just Dave. So when X equals Sarah, the loop stops with the break keyword. And notice the print statement was after the break. So it only printed Dave before it actually stopped the loop and stopped printing. So now I'm going to copy this once again, highlight, Control-C to copy, and come down, Control-V to paste, and I will highlight this and Control/ to comment it all out. But I'm going to switch the break keyword to continue here. Now let's think about what the output will be. What do you think will happen at this point? Remember, continue stops the current iteration and just goes to the next one in the loop. So let's run our code. And you can see we get Dave and John, and that's because when X equals Sarah, it continues and it skips this print statement and it just goes to the next iteration of the loop, which prints John. Okay, scrolling for some more room again, I will comment this loop out. And from here, we're going to look at ranges because we can have a for loop that iterates through a range. So I'm going to say for X in range. And then I need to provide a number. I almost forgot to do that. Let's just put the number 4 here. And after that, we'll say print X. So now we're going to go through a range of numbers, but notice what the starting number is when I run our code. It's 0, just like the index in a list. So 0, 1, 2, 3. Even though we said we want a range of 4 numbers, it starts at 0. However, I'm going to copy this down by highlighting both, and then Shift-Alt and the down arrow would also work to copy down. And from there, I'm going to say start at 2, and then have a range of 4, or stop at 4, essentially. So it won't necessarily be 4 numbers. We're still saying when to stop. Now we're also saying when to start. And just to avoid any confusion, I will comment this out. Let's save and run the code and see what we get. We get the numbers 2 and 3 because we started at 2 and we said stop at 4. And just like above, when we said 4, it didn't use the number 4. It actually stopped there. So we started at 0 and we got 4 numbers. But what if we had put in, say, 5, for example? Let me change this. And now we say a range of 5 numbers. We run, it should be 0 to 4. So you see how that works. Let me switch this back to 2 and 4. So it's going to include the number that you start on, but it's not going to include the number that you stop on. Now there's one more thing we can do with ranges. So I'll once again Shift-Alt and the down arrow to copy this down, and I'll comment out the loop above it. But the thing we can do with a range that we haven't accomplished yet is actually telling it how to increment. Instead of 1s, which is the default here, you saw that it went through by 0, 1, 2, 3, 4, and etc. We can actually tell it to say, okay, start at 0, go through the number 100 or up to the number 100, but increment by 5s instead of by 1s. So now when we run our loop, we count from 0 all the way up to 95. Remember, it will not include the number we stop at. So if we actually wanted the number 5 to be the beginning number, we could start at the number 5 And we would want to make sure our number was higher than 100 if we wanted to include the number 100. So now when we run our code, it starts at 5 and it ends at the number 100 because it increments by 5s. Now, just like we discovered with a while loop, we can also have an else statement with a for loop. So I'm going to add an else here at the end, and at the very end, I'll just print and I'll say, glad that's over. Now I need an apostrophe S, so I need to escape the apostrophe, and that's with that slash, and then I'll say that's over. Save, and so now our loop should run, and at the very end we get glad that's over. Okay, just to visualize our names list, once again, I'm going to copy it and just bring it back down here to where we can see it. And after that, I'm going to create another list, and I'm going to call this list actions. And inside the list, I'm going to have codes, and I'm going to have eats, and I'm going to have sleeps. And the reason I want two lists here is because we're going to look at using a nested loop. So we're going to loop through two different lists, and I'll just bring those to the top. Now, let's look at how we could do this. So the first thing we want to have is for, and I'll use name in names. So for each name, we're going to do something. Now, the next loop is going to be inside this first for loop. So for Dave, then we're going to loop through all of the actions. So I'll say for action in actions. And now I want to print, and I'll say name plus, and then I'll give a space here, another plus, and then action, and then one more plus to concat a period at the very end of the statement. So what do you think the output of this nested loop situation will be? What I should get is Dave codes, Dave eats, Dave sleeps, and then we'll get the same for Sarah and the same for John. Let's see if we get what we expect. That is what we get. So we get 3 statements about Dave, then 3 statements about Sarah, and then 3 statements about John. And that's because name is in the outer loop. So it goes through the name, and then it loops for every action for that specific name before it moves on to the next name. So let's go ahead and copy this down. I'll highlight it all, Shift Alt and the down arrow, and then I'll put a space between, and let me comment out this loop, and let's go ahead and switch this around. So here I want for, I press Control D to highlight both names, and I can type action. Then here I'm going to highlight action and press Control D, and I'll put in name. So now I've got the action on the outside and the name on the inside. So let's think about what we expect to get now. We should get Dave codes, then Sarah codes, then John codes, because the actions are on the outside. So it's going to apply code to each of the names before it moves on to the next action. So let's go ahead and run this and confirm our expectations. And that is what we get. Dave codes, Sarah codes, John codes. Then we get Dave eats, Sarah eats, John eats. So whatever is on the outside is what happens, and it loops through for whatever is on the inside. So play around with this if it's hard to understand, because nested loops can be a little hard to wrap your head around at first. But after you get the hang of it, I think they will make sense. And of course, a natural question would be, can you even have more nested loops inside? Yes, you could. And of course, you need to understand how 2 loops work together before you start adding more loops in there. But go ahead and experiment, and it will help you understand how nested loops work. Okay, now I'd like to take a little time today to apply just a little bit of what we've learned about loops to improve our rock, paper, scissors game from lesson 5. So let's go ahead and open the file tree again. Now in your file tree, press Control B to do that. In your file tree, maybe you've got all of your different lessons in one folder where you've still got the rps.py file. If you have that, great. If not, you might want to open it up and use it for the rest of this lesson. I'm going to create a new file over here, once again named RPS, but I'll put the number 2 after it. So this is the second version of our rock, paper, scissors game. Also over here in the terminal, I'm going to type clear just to clear all of that out for now. Now I'll hide the file tree again because we want all of this room, and I'm pasting in our original code from lesson 5, and this is our rock, paper, scissors game. But we want to add a loop to our game so we can play again and again without having to restart the code. So to do this, underneath our enum here, I'm going to add an extra line or two, and then I'm going to define a variable saying play again, and I'm going to set this just equal to true. So a while loop doesn't have to have an equal sign. We can just say while play again, and this means while play again is true. If play again is ever false, then the while loop will stop. But note, indentation is important in Python. So after I start a while loop here, I need to select everything else, and I mean everything. So I'm starting to highlight here, and then I scroll down, hold down the Shift key and click so it highlights everything, and press the Tab key. So we need that indentation to say, yes, all of this code is inside the loop. And I can see I still have a typo here. I have play gain instead of play again, and I want play again for my variable. So let's go ahead and make sure that the type is the same here. So play again is the variable, and while it is true, we're going to loop through our code. Now, I don't need those extra spaces here, but we do have to consider how to stop our loop, because right now, play again will always be true, so we would have an endless loop. Let's scroll down to the bottom of our code, where after we have determined who the winner is, and we can add just a little more. And remember to indent so it's part of the loop. Here I'm going to say play again is going to equal input. So we're going to get some more input from the user. And here I'm going to say /n because I want a new line instead of printing a blank line. Oh, I need quotes first, and then /n. And then I'm going to say play again with a question mark. Go ahead and put a space and another /n so the next part appears on another line, and I'll say Y or yes, or then another /n for a new line. Then I'll say Q to quit. Not quite, but quit. And then 2 lines, so /n/n. I'm also going to press Alt-Z so this wraps down and we can see all of the code at once. And now we just need a logical if statement to handle this. So after we get our play again input, we'll say if play again dot lower, which will take the Y. If the user does not enter a capital Y, it would make it lowercase. Or if they do enter a capital Y, I should say it'll make it lowercase. So either way, we only need to check a lowercase after we use our lower method here. So if play again dot lower equals Y, then we know we want to play again. So we can just continue our loop and go to the next iteration. But else, let's go ahead and print a kind of thank you message for playing. So let's print, and inside of this, I'm going to press my Windows key and a period. You may be on a Mac or Linux that has a different way of getting emojis, but that's how I do it here. Then I'm going to start to type celebrate so I can bring up a little celebration emoji, and I'm going to put it in here several times. There we go. I can remove the hands. That was a mistake. Or if you want the hands, that's fine too. I also want to put another /n in front of this so I have another line break before it starts. After that, I'm going to print one more line. And in this line, I'll say thank you for playing, an exclamation mark, and then another new line character. And after that, we could end our loop in a couple of different ways. One, we could say play again equals false. That should end the loop. But also, we could use a break. Either one would work. So just so you know, if you were thinking break, nothing wrong with that. I can leave break here commented, but I don't think I will because play again equals false would work. So let's just do that. And mental note, break would work if that's how you wanted to end the loop as well. After that, let's go ahead and put a message at the very end of the program. So we'll use that sysexit again as we did above in the program. And I'll just say bye. I'm going to use one more emoji here, and I want my wave emoji, little hand. So a goodbye message there. So now we've pretty much put our whole game in a loop, and we can continue playing it over and over again. One thing you might notice, I used these /n's instead of some of these empty lines here. So we could consider refactoring our code to remove any of these. Let's see how many we have. We can highlight what we have here, and then I can Control F. And it looks like we have 3 of them in our code. So let's remove this first one. And when we remove that, then we want to make sure to put in a /n when our string begins. Okay, let's go to the next one. It's right here before the player choice statement, so we'll put a /n there, and then we can remove that one. And then we have one after as well. So if it's always after this, the place to put it would be at the end of the statement above. And then we can remove it as well. And now we've also refactored our code to be just a little bit more efficient. And we'll close that out, Control S to save, and let's play our game and see if it all works as expected. So now we can choose, I'll say 1 for rock, and we won. And it asks us, play again, Y for yes, or Q for quit. Well, we really know they don't have to put Q for quit. Anything that's not a Y will actually quit the game. So for example, I could put in an A and check, yes, thank you for playing, bye. So let's run the code again. This time, I'll choose rock once again, and we had a tie game. I'm going to choose Y so I can continue playing, and I'll just put in a lowercase y, and we continue playing. Rock and Python 1. Now I'll put in an uppercase Y, and enter. Yes, we're still playing. So now I'm going to say 2 for paper, tie game. So lowercase y, and let's choose 1 for rock, Python 1 again. So now I'm ready to quit. So let's just press Q. And yep, that works too. Thank you for playing. Goodbye. Once again, our game's not perfect yet, but we have improved it. So this shows you how to apply some of the things we've learned as we continue, and we'll apply much more with some small projects and keep improving this game too as we go. I've got Visual Studio Code open and a new Lesson 9 folder open over here in the file tree. Let's create a new file, and let's call this file functions.py. Functions are reusable blocks of code, and when we call a function, it runs the block of code inside the function. So let's create a simple function. I'll start with the def keyword, which means we're defining the function. Then we'll use hello to name our function, and we'll use parentheses. So our function is named hello, and after the colon, we'll press enter, and notice VS Code brings us down to the next line and already indents. So this is where our block of code inside the function starts. So now we can print, and we'll say hello world with an exclamation mark. Now that is our function, but it is defined here. It is not being called yet. So if we're to run our code right now, we won't see any output. We won't see this print statement happen. So I can run it, and we don't get any output over here. So what we need to do is call the function. So we do that then in our code, wherever we need to use the function, by just calling the name of the function with the parentheses after it. So now when I save this, and it's scrolled back up, but there we go. There's our definition of the function, and here is the call to the function. Now we'll just run the code, and we get hello world here as output in our terminal. I'm going to go ahead and leave this open, but I'll press Control B to hide the file tree, as we don't really need to see the file tree right now. Now let's talk about naming functions. They need to be all lowercase, and if they have more than one word, we can separate the words with an underscore. So let's do that and rename this function hello world. And now you can see Visual Studio Code is telling us that there is not a hello function. So we need to go ahead and add the underscore world here, and now we'll call the function by name once again using hello world. So we get the same output. But that's how we want to name these. No capital letters, no hyphens or dashes. We need to use underscores if we want to separate a word, and we need to use all lowercase. Now, sometimes functions need to receive data, and we can use placeholders for that data, and those placeholders are called parameters. So let's go ahead and create a simple function that receives a couple of parameters. So I'll say def, once again, the keyword def, and then I'll call this sum. It's going to receive num1 and num2. We'll put the colon here, and now we start the block of code inside the function, and we're going to print num1 plus num2. So once again, a very simple function. Now remember that this function is not being called yet. So if we were to run our code right now, we would not see the output of this. We need to call the function. Now these placeholders are parameters. When we call the function and we pass in the actual data, we're passing in arguments. So if I say sum and I pass in 2 and then 3, now we're going to pass in the arguments 2 and 3, and they will use the definition of this function. So they're represented here by num1 and num2. A distinction between parameters in the definition and arguments that you would pass in is the parameters never change. However, arguments can change with every function call. So let's switch this to 1 and let's say 7, or this could even be 100, and then we could leave that as 3. So all of these function calls are reusing this code that we defined for our function sum. Notice the parameters never change. They're just placeholders. So that is the difference between a parameter and an argument. The argument is the actual data when the function is called. So now let's go ahead and save this code, and we'll run our code, and we'll get the output here. So we have the sum of all of those numbers underneath of our hello world. And note, this was also a good demonstration of how our function is reusable. So we have a reusable function that we can use anywhere we need it now, and we used it 3 times here with different arguments. Now, our function isn't really too useful if it just prints this value to the console. We might want to return that value and use it in our program. So let's look at how we can do that. And I'm just going to change this function. So we'll remove these, but of course you know how to call the function now. And instead of a print here, we'll remove the print and the parentheses. I'm going to use the keyword return. So our function actually returns the value, the total of the 2 parameters that are here. So whichever arguments we pass in, if we pass in 2 and 3, it should return 5. So let's do that now by saying a new variable, total, equals the sum of 2 and 3. And then we can print the total just to verify that, yes, total now holds that value. So now let's run our code again. And that's what we get, is 5 right here. Now, right now, our sum function is a very basic function, and we are just assuming that 2 numbers will be passed in. But we can't always make those assumptions when we are writing programs. So let's verify that we're actually receiving numbers, because if we passed in strings right now, they could be concatenated together, because it would just push the 2 strings together, and that would also work. And that's not what we want our sum function to do, for example. So let's go ahead and check some of our input here, our parameters that are being passed in. Well, the arguments are the values, but the parameters is what we'll check in the definition. So here we'll say if, and then let's check the type of num1, and we'll say is not int. And then we could also say or type of num2 is not int. So here's our if statement. We put a colon at the end, and now we want to have a return keyword here. But notice we're not returning anything. This is just called an early return. So we're exiting the function. It will never execute line 11 here in our code. We'll never return the sum of num1 and num2 because they are not integers. Now I can press Alt-Z to wrap this code down, or I could close this so we can see the full line here. So now let's see what happens if I change one of our arguments to something that is not an integer. I'll just pass in a string with the letter A. So I'll save the code and once again run the Python file. And now our function returned none. That is a special value in Python. It's not true or false. It's just none. So that's also something to be aware of if you ever see that. However, that's what is returned from the function. So currently our total value is none. So now we're ensuring to get a result from our sum function that 2 integers do need to be passed in. But what happens if nothing is passed in? We'll probably get an error. So let's confirm this when I remove the arguments from the function call and once again run the function. And yes, we received an error. It says sum is missing 2 required positional arguments, num1 and num2. So our check here, our if statement, doesn't really help if somebody forgets to pass in those arguments. But there's something else we can do. We can give default values for these parameters in case they are not passed in. So now let's just provide one default parameter value, and I'll just make num2 equal to 3. So now I can just pass in one number, say the number 1, and I can call the function, and num2 will automatically have the value of 3. So if I do this and run the Python code, we get 4 for the output. Of course, this doesn't help if somebody forgets to pass in the first value. So one thing we could do is say num1 has a default value of 0 and num2 has a default value of 0. So now, if no numbers are passed in, we should receive a total of 0, and we do. And if we pass in just one value, say the number 1, we should get 1 in return. However, our function does accept 2 values, so we can pass in a second argument, and now it should add those 2 numbers together, and we get 3. So I'll once again press Alt-Z to just wrap this code down to the next line so it doesn't extend off the screen here. But what we have accomplished now with our function is we have default parameter values of 0 for num1 and num2, and we're also checking to make sure that the values passed into the function are integers, and if they're not, we just have an early return. But possibly instead of that none value, if we always want to have a number returned, we could just return 0 as well. So now if we save our function and once again call it without any of the arguments being passed in, and we run the function, instead of none, we get 0. That might be more useful if we're just using this in mathematical equations, because 0 is something we could continue to use in the program, and it wouldn't be some unexpected output like the word none. Now, just as a reminder of how to call this function, I'm going to put a couple of numbers in here, like 7 and 2. So this will be in the course resources, and you'll see, once again, how to call the function with 2 arguments, and we get the output of 9. Okay, now some functions may receive multiple arguments, but when you're defining the function, you won't know how many arguments are going to be passed into it. So let's go ahead and look at a function that would be handling that type of parameter input. So I'll use the def keyword once again, and then we'll say multiple, if I could spell multiple, and underscore items. That's what I'm calling this function. And now it's going to receive an amount of parameters, essentially arguments, that we don't know. These are often abbreviated as args, even though in the definition they should be referred to as parameters. What we want to do when we don't know how many we're going to receive is start with an asterisk, and then I'll use the word args here to represent the arguments that will be passed in. Now, inside of the function, I'm going to print args so we can see what we get. I'm also going to print the type of the args so we can also see what type those args are and how they're represented in the code block of the function, because that would be important to know for you. So now when I call the function, I will say multiple items, and I'll pass in Dave and John, and let's pass in Sarah. Okay, so now let's go ahead and run the code. We're calling the function here on line 23, and we should get 2 lines of output. We're printing the args and then what type they are here. So let's run the code. Notice we get the args right here, and it looks like a tuple, and sure enough, that's what type it is. So if we have an unknown amount of arguments that will be passed into our function, we can define the parameters. Here, we could use any word we want. I'm just representing them as args, which is fairly common. But we want to start with 1 asterisk here, and that will make the data inside the function a tuple. And then, of course, we can work with it as we learned about tuples. But notice these arguments that are passed in here, we just have values, and represented in the parameter area here inside the definition, they don't have names. Like before, we had num1 and num2, and we could refer to them by name inside of the function's code block. So what if we have a function that has, again, multiple unknown items that will be passed in when we're defining it, but we want to use actually keyword arguments? So I'll define another function here, and I'll just abbreviate this as mult, and then I'll say named items. And here we'll start with 2 asterisks. And now you'll often see this word. It's a weird word. It's kwargs, which stands for keyword arguments. Once again, you could use any word here, but this is what you would typically see. So that's why I'm using this, and it stands for keyword arguments. Once again, in the function definition, it's representing the arguments, and we actually refer to that in the definition as parameters. So now inside this definition, I'm going to print the kwargs, and then I'm also going to print the type of the kwargs. So now let's go ahead and call this, and I'm going to use this same line of code here. I'll just switch the function name so we have a different function call. So instead of multiple items, this will be our mult named items. So underscore named underscore items. There we go. So now we're calling this function, and we'll run the code, and I got an error, and that's because I forgot to actually name the items here. So let's do this differently. Instead of Dave, John, and Sarah, which won't make as much sense, let's go first equals Dave, and then last equals Gray. So now we have actually 2 named arguments, and that's what I forgot to do when I called this. I was in too much of a hurry. So these will be represented in the function as first and last. So let's go ahead and run our Python code. And so now, of course, here we have our tuple output above that I left in, but now we have a dictionary, and that's what we got when we printed the kwargs here. So we have a dictionary with first and last, and you can see it is type dictionary. And then we could work with this data as a dictionary, and we learned about dictionaries in a previous lesson as well. I've got Visual Studio Code open and a folder over here in the file tree for lesson 10. We're going to not only learn about recursion today, but also review a few concepts we've covered in previous lessons and once again refactor our rock, paper, scissors game. So recursion happens in Python when a function calls itself. So that would be a recursive function. So let's get started today by creating a file in the file tree, and we'll name this file recursion.py. Okay, now I'm going to add a function here that will be a recursive function. So I'll start with the def keyword. I'm going to call this function add_1. It's going to have 1 parameter, and that will be a number. So I'll just represent that with num. So when we call it with the argument we pass in, it will be a number. And then inside the function, I'm going to say if num is greater than or equal to the number 9, then we're going to return. So this will end the function when the return keyword starts here. So it will not go any further in the function. Then we'll say num plus 1. But after that, I want to create a new variable called total and have it be equal to num plus 1. So this will only be created if the number is less than 9. And now I'm going to print the total. And then after all of this, again, this only happens if the number is less than 9. I'm going to once again return, and I'm going to call the add1 function and pass in the total value. So this is the recursive call to the function. It calls itself here on line 9. Now notice we're returning that, and we're passing in the new total. So it will continue to call itself until it is greater than or equal to 9, essentially, and that's when it will just return the number plus 1 here. So now, of course, this is just the definition. The file is not calling the function yet, so we need to call the function to see how it works. So let's do that with add_1, and let's pass in the number 0. So I'll save the file with Control S, and I noticed it scrolled up on me, so I'm going to add a couple of lines, so now when I save, it will not scroll up. There we go. And now drop here and choose Run Python File. And notice we get the numbers 1 through 9. And you may be thinking, why didn't we get the number 10? Because we passed in 9 to the function, and that is when it went here. But notice there is no print statement here inside the if, so we're not printing the number 10. The only way we might be able to do that would be to return a value from our function here. So we could say my new total is equal to add1 and pass in 0. And then when the complete recursive calls are all finished, then we will print my new total. And now, here on line 15 is where the number 10 would be printed. So let's run our code again. We can see we now get the number 10, but just 1 through 9 are printed here with line 9, and the number 10 is printed here at line 15. And this makes it important to note this return keyword, because if we forget and leave that out with our recursive call, everything will go ahead and continue, but we will not get a value returned to my new total. So let's go ahead and save this, and I'll show what happens. We run the code again, and now instead of the number 10, we get none because we were not returning this recursive call. So we want to make sure we do that. And by the way, none is a special value in Python. It's not true or false, it's just none. But let's go ahead and put the return keyword back in here so we can get a value out of our recursive function. So now when I save and run the code, we once again have the number 10. Now, it's worth noting that you could use a loop to achieve this same result, and that would be a good practice exercise for you. Go ahead and try to create a loop instead of a recursive call, and you could do that inside of a function that would have the same output that we have here. However, recursion is a mathematical concept, and sometimes it's just necessary. And overall, I think it's important that you can recognize recursion as a beginner. So if you are reading someone else's code and you see that the function calls itself, you'll know that that is recursion. Now, before we move on to refactor our rock, paper, scissors game one more time, I want to create another file in the file tree, and let's just call this file example.py, because I want to review a couple of things we have covered in the past to add a little more clarity here. So we're going to talk about while loops and how they evaluate the true or false condition just a little. So I'm going to set value here equal to true, and then after that I'm going to say while value. And we can use double equal signs to say true, but most of the time you will just see while value, and it implies that while value is true or while value exists, which is something we're going to talk about. So now I'm going to print the value, and then after this, I'm going to set the value equal to false. So this is what we would expect from this loop. It would print true one time, and then the value is changed to false. And then when it comes up here for the second iteration, when it wants to go back through the loop, it will see that value is now false, and the loop will exit. So let's save this and see if that's what we get for our output. Yes, we get true one time here in the output. Now, it's also worth noting that we could set value equal to 0, and it would evaluate as false. 0 is considered false. So we run the code again, and we get true one time, and it also exits. But note what I said before about value. So I said it doesn't really just have to evaluate to true. It can be saying while value exists. And that is because we could set value equal to a string like y. Say our user says they want to play rock, paper, scissors again, and so that input is y for yes, and then it still exists. So this will evaluate the same as true. So now if I run the code, we're going to get y one time instead of true, because this evaluated as true. If we set this to 0 or false here, we wouldn't even get the one print line that we are right now. Now I'm going to make this into a slightly larger example now, so I'll say count equals 0, and we'll still have our while value here. And then let me start out with count plus equals 1. So instantly we'll increment the count variable by 1, so now it is equal to 1 the first time through the loop. After that, instead of print value, let's print the count, and then after that, let's have an if statement. I'll say if the count is equal to 5, then we're going to break out of the loop. But then we can also have an else, and inside the else, I'm going to set the value equal to 0, and then I'm going to use continue. And I want to highlight this because I had a question about this, and the question was, when using the keyword continue, is the loop still evaluated here at the top? Does it check the while value part? And that answer is yes. It's going to check the value every time to evaluate whether the loop should execute again or not. So let's think about what this loop does before we run the code. And we're going to increment count by 1 and print the count. So we'll have 1 as our output so far. It says if count equals 5. Well, it doesn't. It equals 1. So we'll go down to the else. And then here we're setting a value equal to 0. Now that's what we're evaluating here on line 4. Does value exist or is it true? And when it has 0, it does exist, but it's not true. 0 is equal to false. So that should end the loop. So the continue will just bring it back up here for the evaluation. It will be evaluated and it will say, no, we're not going through the loop again. So all we should get is a print count of 1. Let's go ahead and run our code and see if that's what we get. That is what we get, just the 1. So what we're learning here is that yes, using the continue keyword does cause an evaluation before the loop executes again. Now I've got the rock, paper, scissors code pulled up from our previous lessons, and we've refactored it a couple of times. I've created a new file named rps3.py, as this would be the third time. So if you've got that from a previous lesson, bring it up. If not, you can get this code from the course resources, so I'll leave that in there. However, I'm going to refactor it now. So the starter code for this, the last time we refactored, I believe, was lesson 8, which is also in the course resources. The code in this lesson, lesson 10, will be the refactored code, so you'll find the finish code in lesson 10. Okay, now moving on, we have learned several things that it could improve our game at this point. So one of those things is functions. So let's make our game a function, and we're going to include everything after the imports here at the top. So we'll use the def keyword, and let's call this play_RPS. And then we have a colon. So everything else needs to be indented to be part of the function. So I'm going to start selecting here on line 7 now, scroll all the way down to the bottom, except for this system exit here. So I'll press the shift key and click, and it highlights everything. And then I'm going to tab in. So now it should make all of that code part of the function. So now everything is in the function except that system exit that we have right here, and we'll probably end up moving it in the function too, but we don't have to for now. Now, let's go ahead and add the function call here at the bottom that we're going to need. So it was play_RPS, and we would need to call that, of course, to execute the function to see our gameplay at all. So we'll save that much, and we now have a function for our rock, paper, scissors game. Now the next thing we can do is actually remove the while loop, and we can use recursion in our function instead. So let's do that by deleting the play again equals true and the while play again that starts the while loop. But after we delete these, now everything is indented too far underneath here. It thinks it's part of the class RPS that we created up here. So we need to select everything on line 14. Once again, scroll down to the bottom here, and I'll click shift or press shift and click, and then we're going to press shift and the tab key to tab reverse and go back out just a little bit. So now everything is once again part of the function, and it doesn't consider it part of our RPS class here that we start the function with either. So just verify that your indentation is correct, and Python will read that correctly. Now we need to make some changes. As you might have noticed, I have a red squiggly line here where the continue keyword is that was applying to a loop, but let's start at the top and work our way down. One thing we still haven't fixed in our game is the player choice value. If the input from a user was something that would cause an error as we cast to an integer here on line 16, we're not handling that at this point. But we can do that. So let's put an if statement underneath the input here where we get our player choice value. And let's say if player choice, and then we'll say not in, and let's create a simple list because we know we're only expecting a 1, 2, or 3, and all user input is string. So here we have not in 1, 2, or 3 in our list. So we're making sure the player choice is one of those. But if it's not, let's execute some code in the if block here. So we'll say print, and now we're just going to take this message that we have in the system exit below because we will be removing this. Let's put this in, you must enter a 1, 2, or 3. And after that, this is a good time to use a recursive function call. So we will return and we'll say play underscore RPS. And that's all we need. So we're calling the function here again, and it will go back to the top, and it will once again ask for the input of a 1, 2, or 3. And with that completed, we can delete the other if statement we had here previously. Now note, I've already pressed Alt-Z so Visual Studio Code will wrap my code down. I expected both of these lines to look like this first one. However, it's doing something a little weird here. I've noticed when I delete this spacing and bring it back to look like the other one, and then I save, it auto formats it back this way. So just note that if you see this in your code, it is just happening automatically by Visual Studio Code, and I'm not entirely sure why, but it's essentially all one line, just like this line above is. Now let's scroll down and fix the area where we have the continue problem here, but we're going to start here on line 41 where we have play again, because remember, we're no longer evaluating play again for the loop at the top. I'm going to start though with a print statement, and I'm going to print, and here is where I'm going to ask the play again statement. So I'll just copy that, paste it in there, and finish that print statement. And then of course we can remove that same phrase from the print statement here. But I want to have this input in a while loop. And again, this is correcting the input. Right now, if we get a Y for yes, then it will play again, and any other input, not just a Q, but any other input will quit the game. But we want to limit the accurate choices to just Y and Q. So here I'm just going to say while true. So we're just looking for a true value to begin the loop once again. And then we'll have our play again. I guess I don't need that extra line. I could just tab this in. So then we'll have play again, ask for the input. I'll get rid of one of these extra new line characters at the end though. And now let's evaluate play again. So we'll say if play again dot lower, then not in, and let's create another list. And we'll just have Y and Q as the two items in our list. And then inside the block for the if statement, I'll just use the continue keyword. So if it's not Y or Q, it's just going to start the loop again and ask for Y or Q. So we're just asking our users to please specifically enter Y or Q. And then our else will just issue the break statement. So if they do enter a Y or Q, the loop stops. Now here the if statement below was checking for a Y, and we still want that. So the loop is stopped, they've entered a Y, and now this is a good place to put our recursive call to the function once again. So play RPS, because they want to play again. If not, we're going to still print the thank you for playing, but we no longer have to evaluate play again for a loop. So let's just take our system exit line right here, Control X to cut it, and Control V to paste it over that line on 55 that was setting the play again value. And now rock, paper, scissors should be ready to play, and it is a recursive function. So let's give it a shot and see if everything works as we expect it to. So I'll enter 1 for rock, and hey, we won. That's great. Do I want to play again? Yes, let's play again. Let me enter something else like an A now that would have caused possibly an error before. But now it just goes back and says we need to enter a 1, 2, or 3. How about a 5? Nope, 1, 2, or 3. So I'll enter 2, and now Python wins. So Y for yes to quit, or I mean to continue playing, or Q to quit, and let's enter a 4 instead. No, it just asks us the same question again. So we're in that loop until we get a Y or a Q. We did Y once already. Let's enter a Q. And we quit. So our game is working as expected. You've now applied a recursive function to the rock, paper, scissors game. I've got VS Code open. You can see I have a lesson 11 folder open over here. Currently no files. Let's go ahead and create a new Python file, and we'll call this scope.py. There are different types of scope, and the first one we want to learn about is the global scope. So when I define a variable like name and set it equal to Dave, This is in the global scope because this will be available to everything in this file. So if I save this and then I go ahead and print name, of course it's available. So let's add something else here to compare to the global scope. So now I'll define a function and I'll call this greeting, and then greeting will accept a name parameter as well. And now inside of this function, I will print name. Now, of course, this parameter has the same name, but it's not referring to the same thing. This is a parameter for the function, so it's going to print whatever I pass in. But let's go ahead and define something else, like, well, instead of name, actually, let me think about this differently. Let's first prove that we can print this name value, because this is in the global scope, but being in the global scope, it's also available inside of this function, but this function has a local scope. So let's go ahead and do this first. I'll save this, and then of course we need to call our greeting function for it to run, and let's put an extra space because it likes to scroll up when I save. So we'll go ahead and save that, and now I'm going to come over here to the drop-down menu and choose Run Python File. And we've got this here at the bottom, and it prints Dave, so it printed the value of name. Now, we defined name in the global scope. But like I said, the function has a local scope as well. So we'll look at that, but right now I want to move this over to the right. So I'm going to go to View, and from View, I'm going to go to Appearance, and then from Appearance, I'm going to go to Panel Position and choose Right instead of Bottom. So now we can see our output here on the right, and I've got Dave as the output there when we first ran our code. So now let me define another variable, but I'll define it inside of the function. So I'm going to say color equals blue. But now if I try to print that outside of the function, I'm going to try to print color. Look, VS Code gives it a squiggly mark, and if I mouse over color, it says color is not defined. That's because color is in the local scope of the function, and it's only available here. If I want to print color inside of the function, VS Code's going to have no problem with that because it knows what color is inside of this local scope. But out here, outside of the function in the global scope, it does not know what color is. So let's go ahead and remove this print color in the global scope because that would cause an error. But if we run the function now, we should see the value of color and the value of name. So I'll run the code again and we get Blue and Dave. And that's because this function inside of its local scope can access the global scope and get the value of name. And it also has access to its own local scope and it gets the value of color. Now let me go back to what I was going to do, and I'll pass in a parameter here for the function, and I could name it the same thing as name, or I could name it something else like first name, and it would be the parameter. And so I'll do that just to eliminate some confusion. So we'll print first name now. So when we call this, we would be calling it with a name like John. And then of course, we could still print name inside of here, and the local scope of the function should still be able to access the value of name, but it can also get a value from the parameter name. So let's go ahead and do this first. We'll run the code, and now we get Blue, Dave, John. But what if this had the same name? So now I'm getting back to where I first started, and now name is a parameter, so I can remove one of these prints because we're just doubling that up. And so this does not represent the value that's in the global scope. Name now represents the parameter that the function is receiving. So now if we run the code, we get Blue and John because we passed in John. So when dealing with variables, I hope this eliminates any confusion where we can see there is a local scope inside of functions, and yet there is a global scope that's available outside of functions and outside of anything else that the value may be in. So if it's defined outside of anything else, it's in the global scope, which can be accessed inside of functions. But if we define it inside of a function where the local scope is, it cannot be accessed outside of the functions. Now, this not only applies to variable names, but it also applies to functions. So let me create another function, and I will call this another, and that's just because I couldn't think of anything else. And inside of another, we're going to go ahead and call our greeting function, and here I'll pass in Dave. So now we'll need to call another down here at the bottom. So we'll put the another call at the very bottom of the file. And now let's run this code again. Remember, we're already running it here with John, and then we're going to run it here, and it doesn't need to receive a parameter. It's just going to run greeting with Dave. So now let's run the code. And you can see we get blue John, blue Dave. So we can call one function inside of the local scope of another function. And that's because this function, greeting, was defined in the global scope. So it's available to be called inside of the local scope of another function. So as you might guess, we can also define functions inside of other functions. So let's go ahead and do that. I will Control X to remove greeting here and put it inside of another before we call it. And now it doesn't like the definition of color being blue right here, and it doesn't like the call to greeting because this is in the global scope, and now the function is being defined inside of the local scope of another. So we could only call this function inside of this another function. But the reason it doesn't like the definition of blue is because these are not indented properly for the definition of greeting. So let's just tab that over, because remember, the spaces in Python do matter. So as we tab this over, this indicates the local scope of greeting. So what if we put color inside of the another scope? And now it should still be accessible inside of greeting because this is the parent scope. So what we have here is a nested function, and the parent function is another. It's defined in the global scope, and then we're defining the color blue inside of the local scope of another. And then we're defining the function greeting, which makes the function greeting only available inside of the local scope of another. So it's not available out here. And even if we put it after our function definition here, it's still going to have a problem because it's not defined in the global scope. So let's remove that. However, I'll get rid of some of these spaces here too. However, inside of another, we can call greeting, so there is no problem here. So let's go ahead and save this code, and we'll run this code and see what we get. And we get blue and Dave, and that's because we defined the color here inside of the another local scope. Then we defined the function greeting inside of the another local scope. And then we called greeting, and greeting prints the color and prints the name. So understanding scope applies both to variables and to functions, and you can have nested function definitions. If you're wondering why you would actually have a nested function, well, that could be because you're only going to use the function inside of the other function. And therefore, it doesn't need to be defined outside of the function. Now, if we did define greeting outside of the function, as we did earlier, you saw that I could call greeting inside of another function still because it was in the global scope, and then the other function, another, still has access to that greeting function. So it's a decision at design time, really, where you define your function. But if it's only going to be useful inside of this function, you can just define it inside of here because there's something called polluting the global scope. And you really don't want to put anything in the global scope that you really don't have to, because that can make things more confusing later on, especially if you're working on a team with other developers. So we try to keep the global scope as unpolluted or with as few things as possible, and we try to put everything else inside of functions, or later we'll learn about classes and objects and so on. But that is important to understand about scope. So we have the global scope and the local scope, and it applies both to variables and to functions. Now, one more thing we haven't looked at is what if we want to modify the assignment of a variable inside of a function, but the variable was initially defined in the global scope. So let's put another variable out here, and I'll just call this count and set it equal to 1. So this is a global variable. And now if I try to define count inside the function, so I'll say count equal to 2, and then let's go ahead and print count right here inside of the parent function. So we'll print count. Let's see what we get as far as the output goes. So I'm going to go ahead and run the code, and we get 2. That's because we really created another variable here. We didn't reassign count. That's because we can't reassign that easily. So we need to use the global keyword. But notice if we do, what happens is we have an error here. We can't just do this all in one line. So global count. So another way I could, of course, demonstrate this instead of saying count equals 2 is we're trying to take the previous value. So let's say count plus equals 1. And now let's see what value we get. And this should show that I'm not using the value from count, because if I use this global value, then it would be equal to 2, correct? Let's see what we get. And we do get an error. It says unbound local error cannot access local variable count where it's not associated with a value. That's because it doesn't currently have a value there. So we can't really do that. Now, of course, we said we can go ahead and access the value of count. If we're not trying to modify it, there is no problem. So if I run the code now, we get 1. That's because it gets the value from the global variable. But trying to modify this inside of the function when it's already defined here, but we didn't give it a definition, because this would be a new variable essentially if we were just trying to assign another number to it, like 1, or previously I had 2. This is just creating another variable named count in the local scope. And I know that can sound confusing, but that's what it is doing. So really what we need to do is use the global keyword, and now we'll say global count equals plus equals 1. So we're adding 1 to that, but we can't do that all on the same line. So then we need to go ahead and just say global count on one line and then say count plus equals 1. Now it's going to go ahead and be happy about that. So now we'll run the code again, and you can see we get 2 because it added 1 to the value of the global count. But we had to use that keyword before we could modify the global value. So I know that may be a little difficult to wrap your head around at first, but what you need to understand is that if you just assign count inside of this another function's local scope, you're essentially creating a new variable named count, and you're assigning a value to it. Now, if you try to modify count, because it already exists, so if we didn't have this global here and we were just trying to modify, that is when we got the error, because yes, it knows count exists and you're trying to modify it before you've used the global keyword. So now by using global count and then modifying it, everything was okay. Now in nested functions, this same concept exists, and especially if we're trying to modify a value that was defined in a parent function inside of a nested function, like color equals blue, well then there's another keyword we need to use, and that is non-local. So we'll say non-local color, and that tells our greeting function that it's going to be using the color from the parent function. And from there, we can assign color equal to red, and it should be okay. But of course, this looks just like reassignment. So if we didn't have this, we would essentially once again be creating a new color variable. VS Code helps us see this because we're not printing color like we are here inside of another. So look at how this is now grayed out, because it knows we're not using the value of this variable. And this is a different variable at this point than color is inside of the greeting. But once we uncomment our non-local color, then VS Code knows we're using this color variable, and then we're just reassigning it here. So I'll once again save and run the code just so we can see everything, and we have 2, Red, and Dave. Okay, let's close our output window for now. And in the file tree, let's go ahead and create a new file. I'm going to call this rps4.py. Now I'm just going to pull in the rock, paper, scissors code from the previous lesson where we had a file named rps3. So if you have that, you may want to open that up. I'm just going to paste this in so we have that same code to work with. So now at the very top of the file, let's go ahead and create one global variable, and I'll call this game_count and set it equal to 0. Now in a future modification, we will remove the global variable once again, because I said it's important to not use global variables where they're not needed, and we will be able to remove this in a future iteration of this game. But for now, we're going to put a global variable here called game_count and set it equal to 0. Now let's scroll down to once we get past the decision tree here, but before the play again in our code, get a little bit of space, and then we'll tab in to line it up. And let's go ahead and say global game_count. So now we're telling the function we're going to work with and modify that game count variable that's in the global scope inside of the local scope of the function. And we'll set game count, and then we'll say plus equals 1. So we're counting how many games we've played. And then before we ask play again, we can print, and we'll start with a /n for a new line. And then we'll say game count, give a colon, and then of course we have our quote here, and then we'll just say plus, and we'll make sure this is a string now as we print this out, or we would get an error. So we will use our string here to convert this to a string, str, and then we'll put the game count. So this should output how many times we've played the game. And even though we run the function again and again, it won't lose the count because that count's not stored in the function. It's stored in the global scope outside of the function. Now, one other thing we could apply that we have learned today is a nested function. So let's do that with this game winner decision here. So I'm going to tab in and then say def, and I'll call this decide_winner as a function. It's going to receive the player as a param and the computer as a param. Now inside of the function, I'll need to tab all of this over. So I'll highlight all of this and press tab. Then we're going to change this a little bit, because instead of the print here, I'm going to select print the first parentheses, and then I'm going to go ahead and press Control D to select the next, the next, the next, and the next. And I'm going to change this to the keyword return because it's a function. So then likewise, I'm going to select the last quotation and the closing parentheses, Control D again as I select all of those, then just a right arrow to make sure I'm at the end, and then backspace once, and we've changed all of those at once. And now we have a decide winner function that is going to return the appropriate response based on the decision. But now we need to add a couple of more lines because we haven't called this function. Now, decide winner is our nested function that's inside of our function up here called play RPS. So underneath decide winner now, we're going to go ahead and say game result, which is a new function, is going to equal decide winner, and we're going to pass in the values we have for player and computer. So it's important to know with the parameters, even though I named those parameters the same, so I wouldn't have to rename all of these, they could be named differently because here, these hold values, player and computer, from above. However, here, player and computer are params inside of the function. They represent whatever value we pass into that function. So we're calling decide winner, and we're storing whatever is returned inside of game result. So then we need to go ahead and print game_result to see that output. Okay, with these changes in place, let's go ahead and run our code by choosing Run Python File. And now it's asking us to play the game. I'm going to choose Rock. And it says Python wins. Our game count is 1. Do we want to play again? Sure. So Y. Let's go ahead and choose paper, and I won. So game count is 2. Play again, and you can see how the game count is working. We'll choose 3. And hey, we won again. So game count is 3. So that's working as expected. Everything else is working just like it was before, but we created a nested function inside of our game as well. So I hope today's lesson has helped you understand a bit more about global scope and then local scope as we see inside a function. I've got VS Code open, and you can see I have a new empty folder named Lesson 12, and that's where you will find this lesson in the course resources. Let's create a new file named closure.py, closure.py. So now we've got our new file, and let's talk about closures for just a moment, because closures are often a difficult concept for beginners to understand. But I think I can provide a simple example in this lesson that will help you always remember what a closure is. And it's important to understand scope first, and that was covered in the previous lesson in this series. So if you've found this video, but you haven't learned about scope yet, I suggest going to the previous video in this playlist and learning about scope first. let's define what closure is. I'll just paste this definition in, and it looks like I need to put another comment before the second line. And I'll even press Alt-Z to wrap this down, and it looks like I should just fit this on the second line as well. So Control-X to cut, Control-V to paste, and there we go. So let me scroll this back up. There we go. Closure is a function of having access to the scope of its parent's function after the parent function has returned. That sounds complicated at first, but if we break this down, we're talking about a parent function, so that means you should know we're going to have a nested function defined. And we learned about those in the previous lesson with scope. And then the nested function is going to have access to the scope of its parent function. And of course, let's go ahead and create an example. So I'm going to come down one line and use the def keyword, and then let's just call this parent underscore function, and this will be our function. It's going to receive one param to start out with, and that will be a person, and now we can define the body of the function. So let's say we have coins, and this coins is equal to 3, then just the number 3. Now let's define a nested function, and here I'm going to use the def keyword again and call this play underscore game. And now inside of our nested function, we're going to use that coins variable from the parent function. So we'll use non-local, as we learned about in the scope lesson, and say coins. So we're going to use that, and we'll set the coins equal to -1. It's essentially equal to itself -1. And we learned about how to do that, so we don't have to say coins equals coins -1. We can just put a negative and then the equal sign, and it will accomplish the same thing. So we're subtracting 1 from coins at this point. Essentially, we had to put a coin in the game to play the game. And now let's put some logic here with an if statement. So I'll say if coins is greater than 1, now we can go ahead and print something for our output. So let's print, and we'll start with a new line. So that's a /n. Let's give it a, well, we don't need a space yet, but we will. So let's give it a plus here, put the person's name. So we're just starting out on a new line with the person's name that's passed in. And now we'll have a space, the word has, and then another space. And after that, we'll put another plus. And now remember to use coins. It's not a string, so we need to wrap it here in our constructor for string, and then we'll just pass in coins, whatever that value is, and it should be greater than 1 at this point. And then we'll put plus, and now another space, and we'll say coins space left. So we're just making a statement here. If we passed in my name, and then it would call play game, which it's not calling yet. We're just defining play game at this point. But if we got to this point here in our if statement, it would say Dave has 2 coins left because I started with 3. So now let's put an else if here. And our elif is essentially what an else if is in Python. We'll say coins equals 1. And the reason we're doing this for 1 is because then we don't want to say coins left, we just want to say coin left. So let's copy this with Control-C, paste it here as well, and now let's just change this to coin left. So now this would be Dave has 1 coin left, because this will only happen if coins is equal to 1. And finally, let's put an else here. So this would be anything else. And essentially, if it was greater than 1, the first happened. If it's equal to 1, the second happened. So here our else would be 0 or anything less than 1, essentially. And now I'll just paste this again, but I'm going to change the message. So instead of has whatever coins left, now I'm going to say is out of coins, because at that point, we shouldn't really be able to play the game anymore. We would be out of coins. Now, as just an example function, we're not really tying a game to this. We're just going to get this output printed to the console. But after we're finished here defining our play game function, then we need to come back to the parent function, essentially. And instead of returning any value, we're going to return the play underscore game function. Notice we're not calling it into action by putting the parentheses after it. We're just returning this nested function play game when we call the parent function. So now that we've completed our parent function, let's go ahead and use it. And I'm going to say Tommy here for our first variable. And as a parent function, let's say his father gives him 3 coins to go to the arcade. So here we'll just pass in Tommy's name because that's what the function needs to receive. We're already defining the coins value inside the function here. And then we're going to be able to call Tommy because Tommy is a function because we're returning the play game function here when we call the parent function, and it has the value of Tommy for the person's name. Now notice we're not changing the value of person, and that's why we don't have to use the non-local coins here like we did with coins, essentially the non-local keyword with coins, but we are changing the value of coins, and that's why we must use the non-local keyword with coins, but we don't have to use it with person because Tommy's value stays the same or whoever's name we pass in. As a matter of fact, let's say Tommy has a sister, so we'll just copy this down. I'm going to highlight Tommy, change this to Jenny, which would be his sister's name, and let's say their dad gives both of them 3 tokens to go to the arcade and play games with. So every time we call one of them into action is when they're going to play a game. So let's copy Tommy down. He's going to play the game a couple of times, and then we'll have Jenny play the game. So let's save all of this now, and notice we're calling our function Tommy twice and Jenny once. Let's check the output. I'm also going to press Control B to hide the file tree for now, just so we can have some extra room here when we see the output. We'll go to our drop menu, run the Python file, and it says Tommy has 2 coins left, then Tommy has 1 coin left because he played twice, then Jenny still has 2 coins left. So I'm going to move this over to the right also. We'll go to View, Appearance, and now we should be able to go to panel position, and then I'll choose right, so it's not at the bottom, so we can see our code just a little better. But when we did this, we called Tommy twice, and he used 1 coin, so he had 2 left. Then he used another coin, he had 1 left. But Jenny was able to go ahead and play once, and she still has 2 coins left. So you can see how we're keeping different values in coins inside of the scope of the parent function that our play game function can go ahead and access the value of even when we change that value. That's what a closure is. And the closure is created when the parent function returns. So when we return this, then the closure is created, and play game, the nested function, will always have access to the variable value that is in the parent function. And it's not always 3. It can change that value as we're accessing it and changing it right here. So let's go back to our definition and see if it makes a little more sense. So a closure is a function having access to the scope of its parent. So play game has access to the scope of the parent function even after that parent function has returned. And that's what's necessary here. So the parent function returns the play game function, and then the play game function has access to the scope of that parent function every time we call play game. And it's not always the same. As we noted here, Tommy and his sister have different values for how many coins they have left. And if we called Tommy again, he's going to run out of coins. So let's save and run this code once again. And now Tommy's out of coins. Jenny still has 2 coins left. So now, just to change our example a little bit, let's go ahead and comment out coins here, and let's have our parent function receive a specific number of coins as well. So as a second param, we're going to pass in the coins, so that way the parent can award the children different amounts of coins. So now that we have changed that, the coins is still inside of the scope of the parent function. It's a param of the parent function at this point. So I just wanted to show essentially how we could move coins up here as a param, and the same concept still applies. So now when we call these functions, Tommy, well, he did okay, but he didn't do all of his chores, so he just gets 3 coins. But let's say Jenny did all of her chores, and she gets 5 coins for the arcade. So let's save this, and let's go ahead and rerun our code. And now Tommy has 2 coins, 1 coin. Jenny has 4 coins left after she uses 1, and Tommy is out of coins. So the same applies to a param as if we had defined the variable inside of the parent function here. So if you remember in our scope lesson, I had said that it's really a good idea to avoid global variables when possible. And notice we didn't have to create a global variable here. So really creating a nested function and using closure, accessing a value from the parent function, is one good way to avoid creating global variables, but when you need to access a variable from a parent still. So this just creates another level. So now let's look at an example with our rock, paper, scissors game that we have been adding to throughout these lessons. So it was changed in the last lesson, so I'm going to start with the code from the previous lesson of where we left off our rock, paper, scissors game. So I'll open up the file tree, and this will be the 5th version, so I'm going to call this rps5.py, and I'm going to paste in the code from the last lesson where we had modified this. But if you remember, we created a global variable here called game count, and we were counting the number of games we played. But now we should be able to change this to where we're not going to use a global variable. And the first step is going to be to wrap our play RPS function inside of a parent function. And we'll do that with the game count here too. So above this, I'll just call this RPS instead of play RPS. And now we have essentially wrapped this, but we need to change our indentation because that's important in Python. So I'm going to indent the game count here, and this will be inside of the scope of the RPS function. And then let's select everything else. So on my line 9 all the way down to the bottom here, I'm going to press shift and click, and then I'm just going to tab over. But really, I didn't need to tab this play RPS. We can go ahead and change that because it's not going to be play RPS anymore. Notice when I backspaced, it got this squiggly line from VS Code because now play RPS is not in the global scope where we can call it. It's a nested function. So we're going to be calling a function called RPS when we actually do call everything into action. Let's scroll back to the top because we need to make a few more changes. Besides the game count, now let's count how many games the player wins and how many games Python wins. So I'll also create a variable here called player wins, set that equal to 0, and one called Python_wins and set that equal to 0. Now let's remove this extra line, but what we're going to need to do is pull these variable values into the play RPS function because we will be modifying these by adding to this number we have, of course, starting with 0. So we will increment as Python wins or as the player wins, and of course for each game with game count. So what we need to do here is go ahead and use our non-local and then say player_wins, and we could say non-local and say Python_wins. Now we could do this with game count here as well, but if you remember, we had this lower in our code. So let's find that. I'm going to use Control F and then just type game_count to see where else it shows up in the code. And we can see it's on line 52. So now that I'm here, I can't use this global keyword anymore because game count is not a global variable. It's inside the scope of the parent function RPS. So we're also going to use the non-local keyword here for game count as well. Now let's scroll back up, and remember we already had a nested function, and that's okay. So now we have a nested function inside of a nested function. It just creates another layer. But when we do that and we need to access our player wins or our Python wins variable inside of our decide winner function that is nested inside of our play RPS function, you might guess that we're also going to have to use the non-local keyword here to pass it down one more level so we can modify these values inside of decide winner and then still access those values outside of decide winner when we need to. So I'm going to say non-local player wins and non-local Python_wins here as well. So again, a nested function inside of a nested function. Now, if we win, it says you win or the player wins, we'll say player_wins, and then we'll say plus equals 1. So we're incrementing by 1. Now I'm just going to copy this because clearly the same output is here as well, and it's also here. Now, we don't really need to count the tie games, so we won't put anything else there. But in our else, where Python wins, we can go ahead and paste one more time, but we'll just change this now to Python_wins. and now we're adding 1 if Python wins to this variable. So now that we've changed those, we just need to output the result also. So let's scroll down just a little bit, and here we find our output for game count, and then of course we're using the string constructor around game count because it's a number, so we can output it this way. I'm just going to Shift Alt and the down arrow to copy that down, and now we'll count the player wins right here. So I'll say player wins, and let's change this to our player wins value. So player underscore wins, and now Shift Alt and the down arrow one more time. We'll change player to Python there, and we'll change player to Python here also. And now you would think we are finished, but there's one important thing that we have not done yet, and that's create the return for our RPS, which needs to return our play RPS. So remember, our parent function here, RPS, needs to return the play RPS function. So now I'll scroll almost all the way to the bottom, and at the very end of our function here, this is where we'll need to go ahead and return the play RPS. And there we go. So return play underscore RPS. Remember, without the parentheses, we're not calling the function into action right there. We're just returning the function. So now let's define a new variable here called play, and we'll set this equal to our RPS function. And now play is going to hold the play RPS function. So now we'll call that into action, and now our game will start. So let's go ahead and play our game. I'll go to the drop menu and choose Run Python File. It's ready for rock, paper, or scissors. I'll choose rock, and it says a tie game. So Y to play again. I'll choose rock again. Another tie. So Y to play again, and another one. And let's 3 ties in a row. I cannot win right now, literally. Let's see. And hey, we finally won on the 4th game. Notice we have player wins 1, but the game counts 4. I also notice we have a slash here with Python wins, so I may have something in the code that I didn't want. Let's go back and check that out. And yes, we didn't get our in there, or I accidentally deleted it. That stands for new line. So let's put that back in. Now let's run the code again, and we're ready to quit or play again. So I'll say play again with the Y, and now we're ready for rock, paper, scissors. I think I ran the code again when I actually didn't quit before, and that's what happens. So let's quit because it's running the old version of the code. Notice the slash is still there. So we quit. Now let's go ahead and run that code again by pressing play up here, and I'm going to choose rock, and Python wins. Game count 1, player wins 0, Python wins 1. Let's play one more time, see if we can even it up, and we won. So game counts 2, player wins, Python wins. You can see everything is counting as it should, and we've implemented closure to keep track of these game counts and the wins without actually creating a global variable at all. And you also learned how to use closure at 2 different levels there, because we not only had one nested function, then we had a nested function inside of the other nested function. I've got VS Code open. You can see in the file tree I have a lesson 13 folder. Let's create a new file inside this folder called f_strings.py. Now, as we talk about f strings, we're going to learn what we have been doing with strings and what we could do to format strings that might be better. So what I want to do first is just paste in an example of something from the previous tutorial, and we'll look at how this is put together. So we have a variable that says person, then we've got a variable of coins, and you can see we concatenate everything in this string. We're using 4 plus symbols to create one string. It starts with the new line character as we see the /n, then we have the value of person, and each time we insert a value, we essentially have to wrap it in plus symbols to concatenate it to the rest of the values of the string, where we see has right here inside of quotes, and then at the end we have coins left inside of quotes. And now today we're going to learn a better way to do this. But before we get to f-strings, let's cover some ways that used to be used to format strings that could still be used, but f-strings are potentially better. However, it's good to know the older ways because you may see those in code examples that were created previously. So let's look at another example of this same string, but we're going to use the %s method of formatting this string. So I'll start out with, well, let's create a message first, and then we'll just print the message. So I'll say message equals, then I'll start with a quote, and we can put in our new line character, and then we're going to put in a %s, and we don't really need the space, but I want you to see the separation of these two as they're different characters. So let me remove that space, but the %s marks where we're going to put the person value. After that, we'll say has, and then %s again to mark where we're going to put the coins value, and then we'll say coins left. So that's a little easier to read so far, but then we need to put another % and then parentheses, and at the end, we'll put in person and coins. Now what this does is it inserts person where the first %s is and inserts coin where the second is. And you need to keep these in order. If we flip them around, it would insert coins first. So after this, let's just print the message and we'll save our file. And I'll go to the drop menu here and choose Run Python File. And you see we've got Dave has 3 coins left, and again, Dave has 3 coins left. So 2 different ways of creating the same string. We had been concatenating with the plus symbol, but this appears to be just a little bit easier than what we've been doing. But again, this is an older way of doing this, and there are newer ways. So we'll continue to move forward and cover those. First, I want to move this to the right once again, as you've seen me do before. So go to the View menu in VS Code, Appearance, and then Align Panel, and no panel position, there we go, and move that to the right. So we'll just see our output over here. I'm also going to press Control and the letter B to hide the file tree, so we can see more of our code here on the left, and then eventually Alt and the letter Z, so anytime our code is longer and running off the screen still, it will wrap down instead to this next line. So now let's look at another newer method than using the %s, and that is to use the format method. So I'm going to highlight our last example, press Control-C to copy, and then just underneath Control-V to paste this. And I'm going to change this string to use the format method approach. And so now we're still going to start with the /n for a new line, but then we'll no longer have a %s here. Instead, we're going to put in the curly brace, and I'll just delete that %s. So now you see the /n and then the opening and closing curly brace, or brackets. Some people call them curly braces, some call them curly brackets. Either way. And then I put a space here just so you can see the separation once again, because this is what we're talking about. But I really don't want a space at the beginning, so I'll remove it. I just want you to see the separation of the new line character versus the opening and closing brackets. Once again, we'll use the same thing here instead of the next %s. So we have these opening and closing curly brackets indicating where we're going to insert our values. And then at the end here, we won't use the % either. Instead, we'll use dot notation to chain on to the end of the string value. We'll chain dot format, which calls this method, and then we'll pass in person and coins to the format method. So let's save this and run our code once again. And now we see the same output again. So another way of achieving the same format of our string, but now we're using the format method. However, there are some other things we can do with this format method. So let me once again highlight both of these. This time, instead of Control-C, I'll tell you another way to do this, and that is to press Shift-Alt and the down arrow, and it will make a copy right underneath, and then I'll just press Enter one time to create that space. Now we're still going to use the format method, but we can put in index numbers to say which position of the value is going in. So I'm going to flip these around, and I'm going to put 1 here instead of 0, and I'll put 0 here. But that means I'll want to flip these values as well. So it will start with a 0, and then it will end with the 1. So we'll want to put person here where the 1 is because it has the index of 1. And we'll put coins where the 0 is because it has the index of 0. So if we save, run our code again, we get the same output, but now we can essentially not track the order of these. If we want to flip those around and then insert the values by which number they are as far as the index inside of the format method, we can do that. And remember, the index starts with 0, so we refer to coins as 0 and person as 1. But there's even more we can do with the format method, so I'll scroll up just a little bit. I'll highlight this example, and once again, Shift-Alt and the down arrow to copy it down. And now let's refer to these as the names that they have, but we're going to have to do something else inside of the format method as well. So here, I'm going to put person, and here I'm going to put coins, but now we actually assign these values inside the format method here. So I'm going to say coins equals coins, and likewise, person equals person. So now we're setting the values of these parameters essentially for the format method, and then it will pull them in here by name. So let's save once again, run our code, and we get the same output again. And I can see VS Code brought this down to the next line, and that's okay. You could even have your closing brace on the last line if you want to. And we have the opening one here. This will still run the same. Okay, before we move on from format, let's look at one more example. So I'm going to highlight all of this again, Shift-Alt and the down arrow, move it down, and I'll press Enter about 3 times now because I need just a little more space. I want to create a dictionary here. So I'm going to say player is going to hold our dictionary. There we start with curly braces for a dictionary. I'm going to define person inside of the dictionary, and I'll just assign person my name, Dave, and then coins, and then I'll give coins a value of 3 here. But this is all inside of a dictionary. Now, we can still refer to person and coins inside of our string, but what I'm going to do here is put in, and I can get rid of the extra returns here, so format's all on the same line again, but I can put in the dictionary, and I just start it with 2 asterisks, and then put in player, and it's going to pull these values in from the dictionary based on what we have assigned the keys here, as person is a key and coins is a key for the values of Dave and 3. So let's once again run our code, and we see the same output once again. So a dictionary could actually shorten that up, because then we just use 2 asterisks and the name of the dictionary, which is player in this one, to pass into the format method, and then it pulls those out based on the key names. So when we talk about these different ways of formatting strings, we have to look at why have we moved on to newer methods. Even format is an older method than the F string, which is what we're going to learn next, and that's what you want to use going forward. But when we look back at this % method, let's talk about what works for it, and it does work, but what doesn't work is this can get complicated quickly. So you see %s everywhere. You've got all these % signs, and imagine if you had more values to pass in. What if you had 10 values? This just gets longer and longer as you pass in the values. Now, as you might guess, the same with the format approach here. As we pass things in, except for the dictionary at least, but as we pass things in, it was also getting longer and longer if we had more values to pass in. But format gave us a little bit more control here with the index numbers or with the name references than we had with the % method. But we can shorten all of this up, and it won't be so verbose if we use F strings. So now that we're ready to move on to F strings, let me scroll up for some more room, and I'll put in a little break so you see it in the source code and know when we have moved on to F strings. And notice my Mandalorian reference. This is the way. So here we're going to have a message. So we'll define our message once again, and then equals, and we'll start with the letter F, and lowercase is what I usually use. And then let's go ahead and put in the new line character. And then let's refer to our person, which remember was defined above as well. Before we put it inside of a dictionary here, we had actually defined person and coins here at the very top of the file. So we're referring to that. And after our person, we can just say has, and then coins, and that's referring to the coins definition at the top as well, and coins left. Now, that's a lot shorter, isn't it? We're just inserting the values of those variables, but we're starting out with the letter F to indicate this is an F string. So let's print message and save, and now let's run our code once again, And we once again see the same output. Not nearly as verbose. We don't have to add anything at the end of the string or insert values into a method. We just use the letter F at the beginning, and then we insert the values we want inside of curly braces inside the string. Now I want to highlight the fact that we do not have to necessarily insert these predetermined variable values as well. So let's copy this down once again. And now, instead of coins, I'll leave person there, but we could pass in an equation like 2 times 5, and this will work. So if we run the code now, we should see the difference, and it says Dave has 10 coins down here at the bottom of our output. And I'll copy this once again to show we can actually use methods inside of this as well. So in this example, I'm going to say person and then dot lower. So if you remember our string methods we learned, this should make everything lowercase. So Dave should be lowercase now in this new output. And if I run this, yes, Dave is lowercase on the bottom line. So you can see we can do things inside of these curly braces besides just passing in a value. So let's look at one more example here. And remember our player dictionary above where we have player with person and coins as the keys. Let's come down here and we'll use that. So I'm going to copy this down with Shift Alt and the down arrow. And now inside of our curly braces, going to do this just a little differently. We'll refer to player, our dictionary, and then we'll use brackets, and then we need to put the key inside of quotes, so we'll use person. Now it's important to note that I'm using a double quote out here and then single quotes in here. If I had single quotes out here, this wouldn't work with single quotes. We would get an error. So if you wrap your string in double quotes, then you can use single quotes inside. So here we've got player, person, and we could refer to player coins as well, but I'll just leave the 2 times 5 right there. Let's go ahead and run the code. And once again, we have Dave has 10 coins left. So you see how we can insert different things inside of these curly braces, and it still doesn't make our string much longer, not much more verbose, if you will, which means adding more code. We're trying to minimize code. And F-strings do a great job of that compared to the previous methods of inserting values into strings. Now I also want to share that you can pass options into these F-strings. So I'll put another line here in our code with a comment just saying you can pass formatting options so you'll know what this is an example of. Let's start out with a variable that is equal to the number 10, and now we'll print an F-string. And so I'll start with F once again, and then I'm going to use a new line character. Then I'm going to say 2.25 times, and I'll insert the number value, so times 10 in this case, is, and now we'll have a bracket here for the result. And I'll say 2.25 times num, but I want to put some formatting on this so I get a fixed decimal. So I'm going to start with a colon, and all formatting will start with this to indicate. Then you're going to say how to format it. I'm going to say 0.2 to indicate I want 2 decimals, and this F stands for fixed. So now I'll go ahead and save this string, and we'll run the code once again, and we get 2.25 times 10 is 22.5. And remember, we wanted 2 decimals, so that's why we see the 0 at the end. Now this is just one of many examples of how to format, and I'm going to show you where to find more of those here in just a minute as well. But first I want to highlight that you can also put this in a loop. So now let's copy this line down at least. I'll just highlight that and Shift Alt and the down arrow, and then I'll press enter a couple of times, and I'm going to say for num in range. And I want to go 1 through 11, so I get 10 numbers, if you remember how we covered range. Now I need to indent this, or we'll have that error, because remember, the indentations in Python are important. So we're going to loop through this, so you should see this print several times. Let me go ahead and remove the new line character, because this will allow each line to at least have an output there, so it doesn't take up our full screen like this does. I can go ahead and put a new line character here at the end of this one, so at least we see the separation before our loop starts. So now let's go ahead and run this same code and see what we get. And you can see we've got 10 different lines of output here for the numbers 1 through 10. If you remember the range here, once we reach 11 is when it stops. It doesn't put 11 into this loop as well. So we've got 2.25 times 1 is 2.25, and it goes all the way through 10, giving us the result of each one. Now let's look at one more example of this. So I can copy this down, but then I'm going to change the values. So Shift Alt and the down arrow one more time. And now in this one, we're going to use the same range. I'm going to switch some things around. So I'm going to say num, then I'm going to say divided by, and then we'll have 2.25 is, and then we'll go ahead and put what we're calculating here. So I'm going to have num divided by, and you know what, let's change this number. I want to do something that always gives us some type of decimal output. So I'll just say like 4.52. So let's make it 4.52 here. 4.52, there we go. Now, not the letter M, there we go. So now we need our colon, and we'll have a period, and then I'm going to have the number 2, but instead of this fixed place, I want to have a percent. So it's going to put a percent output. It's still going to have 2 decimal points though. And that's what we're going to see for our output here. I'll go ahead and save this. And let's look at the output of this loop as well. So now we have 1 divided by 4.52 is 22.12%. Essentially, it is 1 would be 22.12% of 4.52. As you can see, as we get closer to 4, it gets closer to 100%. And as we go beyond 4, it's over 100%. Eventually, where 10 divided by 4.52 is over 200%. So we're getting the output expected, and that's kind of showing you how to loop through and format a string and get those results as you go. Okay, I'm on the W3 Schools website, and I'm on the Python string format method, which I said was one of the older methods, but you can still use the formatting options that I was talking about, even if you're using the older format method. So this is where they have this current information, and I'm going to, of course, include this link in the course resources and in the description of this video. So I'll scroll down here, and where I want you to see is down here when it says formatting types. And it starts to show all of these examples, and it shows what, or it says what they do, and it gives little try it buttons where it will launch a code playpen for you to try all of that out. And you can see there are so many different ones. Here we used the percent one, and before we used the fixed point number format in my examples, but there are many others that you can try out as well. So I'll put this link inside of the course resources. I'm back in VS Code, and you can see I've created a new file named RPS6, which is our rock, paper, scissors game, and I've pulled in the code from the previous lesson on closures, and that was our RPS5 version. So right now, I essentially have the ending code from the previous lesson that was in the rps5.py file. So now we can apply some F strings to modify our rock, paper, scissors game, and there's a few lines that actually need them. So let's go take a look, and we'll scroll down here to line 33. And you can see on line 33 and 34, we've got some longer strings, and VS Code's wrapping one kind of strangely as well. Let's first hide the file tree once again with Control B. We can see this a little bit better, and let's modify the first one. So we'll start with the letter F once again here, and now we don't have to use the plus symbol to concatenate this string. So let's highlight everything we have right here from the extra quote and the plus symbol, and instead put a curly brace. And now we just need to find where the end of this string we're creating is, and we're chaining the replace method and the title method, so the end is really right here after title. So let's put our curly brace there. Then let's delete the plus symbol and the extra quote as well. And now it looks like we have made a full string here that's a little tidier by using an F string. So now let's do the same thing, and maybe VS Code will like what we're doing better and will not wrap this down in a strange way. So we'll start with the letter F here, and we'll have Python chose, and then we'll highlight the quote and the plus symbol once again, and instead we'll put a curly brace. Now let's get rid of this weird space VS Code has added. And now we'll be going to the end here. So here's the replace and the title. So at the end of the title, we'll put another curly brace. That looks better already. Now let's delete the plus symbol and the quote as well. And now we have the period and then another new line character, and that's all fine. So let's save. And, well, VS Code wrapped it down, but I like where it wrapped things better because now after the parentheses for the print, we just have this long F string. So let's go ahead and move this closing parentheses down the next line as well and save. And that format's quite a bit better. And you can have that opening and closing parentheses on separate lines. And then our F string is all on one line as well. And now let's scroll down to line 63. And we have these different outputs here for the game count, player wins, and Python wins. And you can see we're still concatenating a value. So let's once again make these F strings. I'll just start all three of those with the letter F. Now we can highlight the quote and the plus symbol, delete those, and start with the curly brace. And really, if I highlight one and press Control D, it will highlight the next as well. I'll press backspace to change both at the same time, and then add the opening curly brace to both at the same time as well. So that's nice. Afterwards, we need to put a bracket here in between these two parentheses. So we could, of course, highlight both and then Control D and Control D. Now we've selected all three. I'll arrow to the right to go to the end and then arrow to the left once. And there I'm in the middle of all three. And so then I'm going to add that closing cursor as well. And after that, we need to put a closing quote. So now we have a full F string in each one of these print statements, and we can save the file. And now let's try our game out just to make sure everything is working as expected. We'll choose Run Python File here, and it's asking us to play. We'll make a choice. I chose rock, and everything looks like it works as expected, even though we lost the game. So let's play one more time. We don't like to quit when we're losing, and we still lost. Maybe again. We'll keep going with rock, and Python's beating us every time. But we finally won on the fourth game, and everything works as expected. So now you know how to use F strings, and we've applied those to our rock, paper, scissors game. I've got VS Code open, and you can see I have a new Lesson 14 folder over here in the file tree. Let's create a new file, and let's call this modules.py. Now, inside of our modules.py, we're going to actually import something first. And we've done this previously. So modules can be considered small code libraries that are based on related features. And one example of this is the math module, and it contains functions and constant values for use in mathematical equations. So we can import math, and that's a built-in module in Python. So Python comes with this module, but you have to import it to use it. And now let's go ahead and access something from math. And if we want to do that, we can just print and then say math, and then I'll use dot notation, and notice what happens. All of these different things that are available in the math module come up. And I'm going to scroll through here just so you can see a lot of them, but we're choosing a constant, and I'm going to choose pi. So we're just going to print pi inside of our output window. And I'm going to add a couple of extra lines just so that doesn't scroll up on me like that. And then I'm going to go over here to our dropdown and run the Python file. And notice we get the value of pi here in our output. Once again, I'm going to go to View and Appearance, and then to Panel Position and move that to the right, just so we can see our output over here today. But now you know what I'm doing. I'm either getting functions or constant values from the math module. And of course, we could bring in any type of data that could be in the module. There may be a dictionary in there or a tuple or something else that we can access. Now, earlier in our series, we also imported a couple of other modules that we're using in our rock, paper, scissors game. One of those was sys, and another was random. And now later in the code, we were using some functions. So one we used to exit the program, and that was sys.exit. And then we call that function. And then another one we used was random, or random.choice, actually. I should say random.choice. And we pull that up. And then it chose one of the characters of a string we provided, like 1, 2, 3. So just a couple of functions that are available from other modules that we've already used. Now here we're importing the entire module, and then we're using dot notation to pull a function or a value from that module. But instead of that, we can just pull out what we need. And you have seen that once already in this series too, because in our rock, paper, scissors game, we're using enum. And to do that, we say from enum, which is the module, then we say import enum, or we could do any of the other things that are available from that module. But now we're only importing enum from the enum module. And I know with the same name, that's a little confusing, but just for example, if we didn't want to say math.py, instead of import math, we could say from math. So we would say from math here, and then we would just say import pi, and then notice how VS Code already realizes we're now using the wrong syntax. Then we would just refer to pi as we want that output, and we can run our code again, and we still see the same value output here. Now, something else we can do is create an alias. So if we don't want to refer to a module by its name, say random, we could create an alias by just typing the word as after, and then I could say RDM, and then I could refer to RDM dot, and then still have all of these choices here. So like the choice function that I was using before. So how do we know what to use from a module? Well, there's a few ways to find out what's inside of a module. One of those ways, and I'll just create an extra line here, but is to use the dir function. So I'm going to print here just so we can see the output, and then I'll call the dir function, and then inside of that, which dir I believe would be an abbreviation for directory if I'm not mistaken, and then inside of that, we can just pass whatever module we want to. Now I've got an alias for random, so I'll just put that alias in here, and this will work. But notice the output when I go ahead and run the code after I save it. It's got a list of everything in the module, but boy, is that kind of hard to read. It's literally a list, so list type data, and then we've got everything in here, and it's all jumbled together. But we can make this more legible for us, actually, because what we'd like to do is just put one of these on each line and then see everything inside of the module. So let's just loop through it. So I'll say for item in dir, and then pass our random module, but I'm passing in the alias, of course, that we created. And now I'm not going to print the directory of random here. Instead, I'm just going to print each item as we go through the loop. So I'll save this and run the code again. Much easier to read now, and we can see everything that is inside that module. Now, of course, I already showed another way to do that, and that is with dot notation. So I just type the module name or the alias of that module, and then I use dot notation, so I type a period, and VS Code helps us out. So we can see all of these different things that are available inside of this module. But neither one of these ways actually tell you what any of these constants or different data types or functions are inside of the module. So for that, let's go to the docs quickly. I'm in the Python documentation now. As you can see here at the top, it says documentation for Python 3.11.3, and we're at the Python module index. Now, if you're watching this in the future and Python has gone to a newer version, that's okay. You should still be able to find this Python module index. And here is an alphabetical list of all the different modules that are available. And then if you go into the module, so let's find one we were using like enum here, I'll click this, and it takes you to a page that shows all of the details for that module, and it details everything and describes everything inside of the module. So this is a great reference, and of course I'll link this in the course resources for you to go with this lesson. Okay, now we're back in VS Code, and we're going to look at a custom module that I created. Notice it's named kansas.py, so like any other Python file, it ends in .py. And then inside of the file, we've got some values here. So I've set the capital, the bird, the flower, and the song for Kansas, and that's the state that I'm from. So you could create one of these files or modules, if you will, for where you're from if you want to, just as an example to go along with what I'm doing. But we've got a few values here, and then we've got a function that says random fun fact. And you can see inside of this random fun fact function, I have a list that has 4 fun facts about Kansas. And then notice I'm also importing something from another module, because you can do that inside of modules that you create as well, just like other Python files. So from random, I'm importing the choice function. So then down here, I'm creating the index value using the choice function and choosing between 0, because remember, our list would start with an index of 0, so 0 through 3. So it's going to choose one of those. And this is a string, so then when we use the index, we need to convert it to an integer here. And we're doing that with the constructor, and then we're just referencing which index it is inside of fun fact, and we print that. So this might surprise you, but there's really nothing special inside of a module. We've got data, and we can have functions as well, and you can use other modules inside of a module that you create. And so that's what we have here. Let's go back to our modules file. Now inside of this file, we can import our Kansas module, or if you created one for wherever you live, that's fine too. So we've imported Kansas. Now let's use what we get from the module. So I want to print the Kansas capital, and notice with dot notation, I see the other things available in the module as well. I'm going to choose capital. So I should print out that value. Now remember, our function already prints, so I don't need to call print here. So I'll just say Kansas and then random fun fact, and we'll just call that function, and it already prints. If we go back, you'll see at the bottom here, it returns a print, and we don't really need that return there even. I don't think I had that before, so let's just go ahead and remove the return. It should still be fine without it, and I think that's what I showed you before. So here, we'll go ahead and save, and now let's run our code and see what we get from bringing in the Kansas capital and the random fun fact. So here at the bottom, the Kansas capital is Topeka, and then we have our random fun fact. Wichita is the largest city in the state, but many would guess that that is Kansas City. That's also true. Much of Kansas City is actually in Missouri. Okay, so we're using our new custom module now. And now we need to talk about one special value that every module has, and that is the name value. And it is surrounded by two underscores, both before the word name and after. So let's look at that. And we can print the name of the module that we're running. So let's print, and then let's just say two underscores, name, and two more underscores. Now, do you think this will be modules? It possibly could be, but maybe it won't be. Let's go ahead and see what we get when we run our code again. And notice the name is main, and main also has two underscores both before and after the name main. That is because this is the module we're running. So if we print the name of the Kansas module, for example, we could say Kansas dot, and if we scroll through here, we should find name. There it is. So that's available to our custom module. I'll save. Let's run this. Notice the name of the Kansas module is Kansas, and that's because we're importing that module. So it gets the file name just like we have here, kansas.py, so the name is Kansas. But the file that we're running, modules.py, its current name is main, and that indicates that that's the file that is being ran. Now this can be very useful. So for example, I'm going to go back to the Kansas module, and at the very end of the file here, I'm going to put an if statement, and I'm going to say if two underscores name two underscores equals, and then I'm going to put in quotes main with the underscores. Then inside of that, we're going to go ahead and run our random fun fact function. So now this function is only going to run, it's only going to be called into action if this is the main file. Oh, and I only put one equals sign there. We actually need two as we compare. We're not assigning, we're comparing here. So that needs the two equals. So if name equals main, and you'll see this in many modules because this way they'll only run this code after this if statement if they are the main file. In other words, this file is being called into action. So let's go ahead and run our Kansas file now and see what we get. We have a fun fact from Kansas. Kansas is considered flat, but it does have a mountain. I believe we saw that one before. So this file will run this function if it is the main file. So that can be very useful when you create modules. Now, if we come back to our modules here and we go ahead and run this modules.py, we won't see anything different than what we had before. We don't see the fun fact function running twice. As a matter of fact, I could comment out the fun fact function, and now we shouldn't see it run at all if we do that. And we don't. We just have Topeka and then the two different name values here, Maine and Kansas, that we printed at the bottom. But it's important to do that if you want to have something called inside of your module, because if we don't do that, it will run every time. So if I comment out the if statement here, And then we'll have to, of course, change our indentation. Just bring this back to the front. Now, when we import the Kansas module, this will run. So we should see a fun fact executed twice because we're also doing it inside of our modules file. Let's go ahead and double check that. I'll run the code. And well, we're not seeing the result here because of this long list. But if we're to scroll up, there's actually another random fun fact at the very top of the list. And here we see it. Wichita is the largest city in the state. So we see that before we even print pi. Let me go ahead and comment these out again. I'll select all of those and do control with the slash, and it will comment those out. And now it won't be so far between when we see our output here. We'll run the code again, and notice we've got a considerable portion of Kansas City is in Missouri. And oh, I commented out the other Kansas information too. I meant to just do the loop. Let me try that again. I'll uncomment by doing the same thing. Select what you want and then control and the slash, and I uncommented both of those. Let's save and run the code again. Okay, now we actually have two fun facts running, even though we're only calling it once in this file. And that's because this first fun fact runs right now when Kansas is imported, the Kansas module. And that's because we don't have this if statement. Another important thing is if you leave this over here, it could actually be included in the import list. Let's see if it is. I'm not so sure if it is or not, but let's check. Say Kansas, and then we'll dot, and we have random fun fact here. Let's see if another one is included. It's not. By VS Code at least knows not to do that. However, maybe not all tools with Python do. So one thing to consider is you don't want this included in what's available to import as well if another Python tool were to allow that. So it's much better to put this if name equals main, and then of course we need to indent this back with tab. There we go. And now we'll only get the fun fact that we intend to run inside of our modules file, and this will not run unless Kansas is the main file. So let's go ahead and run our code one more time just to prove that. And yes, the first thing we get is the pi value, and that's up here, and then we get the capital, then we get the fun fact and the two names. Okay, now that we've covered the name value, let's close the terminal window. Let's create a new file over here, and we'll call this rps7.py. Now we're just going to start with the code that we finished with in the last lesson on closures, which was rps6 for our rock, paper, scissors game. So I'm just pasting this in, and this is the exact code you should have finished with in the previous lesson for rock, paper, scissors. Now we just want to make a couple of changes here to make our rps7.py a module. So let's go ahead and scroll to the very bottom. And once we get to the bottom here of our file, what we're going to do is I'm going to rename this play, and I'm going to name it rock_paper_scissors, and we're setting that equal to the RPS function, and that's because we're using a closure that we learned about in the last lesson. Now the nice thing when we make this a module is the rock, paper, scissors function that we want to call will be available to import. Now underneath this, let's go ahead and delete this. Let's put our if statement. So if _name equals with two equals, then main . Inside of this if statement, we'll go ahead and call our rock, paper, scissors function. So this will only execute if our rps7.py is the main file. So if we go ahead and run this code, rock, paper, scissors would execute. But when we import the file, it will not automatically run. It will allow us to call the rock, paper, scissors function where we want to. So now inside of our modules.py, let's go ahead and import this. And I'm going to say from rps7, and I'm going to import rock, paper, scissors. Now, of course, we could just import rps7, and then we would have to refer to this as rps7.rock, paper, scissors. But here is our rock, paper, scissors function, and it's ready to be used. So we will call it right here at the bottom of our modules file. And now, after we see these different values print out, the game should start. So let's go ahead and run our modules file. And yes, we're ready for a game of rock, paper, scissors. Let's go ahead and play, and Python won. So I'll go ahead and quit this time instead of playing till I win. But now you know more about modules. We've got built-in modules in Python, or you can create custom modules as well. I've got VS Code open. I have an open folder over here named Lesson 15, and we're going to create a new file, and let's call this file hello_person.py. To accept arguments from the command line, that is values that we will pass in to the programs that we call, we need to use a module, so we will import argparse, and that is part of the Python standard library. When we previously discussed Python modules, I gave a link to the Python module index, and we can see the argparse module right here. It says command line option and argument parsing library. I also want to call your attention to the Python standard library page, and this shows kind of the different modules. Instead of in the index that we had on the other page, it shows them kind of in feature areas here. So different things you can look at, a different way to find the same thing. So if I search the page with Control F for argparse, we can once again find it under generic operating system services. So just another way to find the modules that you would be looking for. Back in VS Code, let's go ahead and define a parser, and we'll set this equal to argparse and then dot, then we'll say argument parser, and from there we'll use parentheses, and we're only going to pass in some of the basic settings that we can for this argument parser. But if you look back at that module page for argparser, you will see many other settings as well. Here we'll just say description equals, and then we'll say provides a personal greeting. Whoa, I'm not spelling good today. There we go. Provides a personal greeting. So we have set the basic description for our argument parser. Now let's say parser.add argument, and there we'll go ahead and pass a few different values. First, we're going to put in a value that you could use at the command line as a flag. So just dash in. This will be short for name. So we'll also say you could also provide dash dash name, which is just a long version of the same thing. So you could use either one of these at the command line, and I'll show you how. Then there's another setting here we'll call metavar, and we set that equal to name as well. Now this is just the display name if you get a message that refers back to this argument. Now we're going to say this is required, so here we just set that equal to true, and then we can also provide a help message. And here let's just say the name of the person to greet. And that should be all we need to add this argument to our parser. Now let's say args equals parser dot parse underscore args, and that is a method on parser, so we just call that, and now we should get those different arguments. So when we want to print a message at this point, let me define the message, and I'll use an F string. So we'll have F and a quotation, and I'll say hello, and then inside of this, we'll say args.name. Now, where is name coming from? Let me put an exclamation mark behind this. But where is name coming from? Well, you see this value right here that says name. Now, that's pretty much what it's going to refer to. However, if you want to assign something different, we could say dest and set that equal to, let's say, first name. Then you would no longer use name here, you would use first name, for example. So either way, I usually use dest off, and we just refer back to name. So let me go ahead and remove that, and we'll see how that works as well. I'll quickly click yes here, but underneath our last one, we actually need to go ahead and print our message also. So there is a basic example of using the arg parser. Now, let's go ahead and use this in a terminal window. I'm going to press Control and the backtick to open our terminal window that I've already got over here on the right. Control B to hide the file tree so we can see a little bit more of our code, and then Alt Z to wrap any code down that was extending out of the window. So now it wraps down to a second line. Now we can't use the play button like we used to call this file because we need to pass an argument. So we're just going to type right here in the terminal, and I'll type pi because I'm on Windows. But if you're on Mac or Linux, you're probably going to need to type Python 3. I'll type pi, and then I want the file name, which is hello_person.py. But if I press enter right now, I'm going to get an error. Let's go ahead and do it to see what happens. And it says we have an error. It shows the usage here. And of course, the -h is for help. Then we have the -n, and it's referring to a name. And then it says the error, the following arguments are required. That's because we required this argument over here. So let's try this once again, or let's even see what the help does. So let's go ahead and pull this up again, and then just do -h for help, and let's see what we get. Now we get our provides a personal greeting, so that's the description we passed in up here, and it shows the options, and of course -h for help, and -n for name, the name of the person to greet. So let's once again pull that up, and now instead of -h, I'll say -n, and I'll pass in my name as a string, just Dave. And we get back hello Dave. Now that's what's expected. Let's once again close our terminal window for the time being, and now let's create a function just above everything we have, even the import, which I know is something you haven't seen me do before, but let's do it this time, and let's say def hello, and we're going to pass in not only a name, but also a language that I'll abbreviate as lang. Now inside this function, I'm going to define a dictionary called greetings. Inside the dictionary, I'm going to use English, and I'll match that to the value of hello. That needs to be a string also. After that, let me copy these lines down with Shift, Alt, and the down arrow twice, and I'm going to change these. So the second one is going to be Spanish, and that will be hola. And then the third will be German. And that will be close. Instead of hello, as we say in English, it's hallo with an A. Okay, after those three, let's go ahead and define our message. Once again, message equals an F string. And inside of this string, it's going to start with the value that we get from the dictionary. So greetings, and then we're going to refer to whatever we get in that lang param that is up here. And then after that, we want a space, and then we're going to use the name param value, the parameter. So as we pass these values in, remember they're called arguments, but when we define a function, these are parameters, or as I often say, params. Okay, now we're going to have a print, once again, for that message. So that's what our hello function is going to do. It's going to determine the language, we're going to have a name, and we're going to say hello in the requested language. Now, someone could import this function from this file if they wanted to. And if you remember what we learned about modules, we can go ahead and put our if name equals main here to then only run the code underneath if this file is actually the file being ran and it's not having the hello function imported from somewhere. So we'll say if 2 underscores name, 2 more underscores, and we'll say equals, and we need 2 equal signs as well. Then we'll have 2 underscores main and 2 more underscores, and then our colon. Now everything is going to need to be tabbed over. So I'll highlight everything and tab over once. And now remember we have a second argument. So let's add another argument to our parser underneath. So we'll say parser.addArgument. And now here we're going to call this one L instead of -n. So we'll have -L. We'll also have --lang. And then we'll have a metavar, and just to point out that they're not the same, here I'll put the full word language instead of lang, but we're still going to refer to lang when we get the value. After that, on the next line, I'm once again going to say required equals true, and then we can pass choices. So we can have specific choices here, and if these choices are not correct, then an error will occur once again. So here we'll make sure that the values we want are passed, either English or Spanish or German are the choices. And then after those choices, let's go ahead and put in a help value as well. And here we'll say the language of the greeting, and that's good enough, just the language of the greeting. Okay, now that we've defined that, we need to change what we're doing below. We still want to get the args from the parser with parse args, but then here, we're not just going to print this, we're going to call our hello function. So we'll say hello, and we'll pass in the args.name, and then we'll also pass in the args.lang. So quickly to review before we use this code, we just created our hello function above, And then if this is the file that's called into action, then we'll use the arg parse. So that's why the import is down here. It's not needed up here at all. And then we'll go ahead and use this, and we pass the 2 arguments to the parser, and then we call the hello function with those values. Let's once again press Control and the backtick to open a terminal. I can clear this out by typing clear as well, just so we start at the top. And now let's go ahead and say pi, or once again, if you're on Mac or Linux, Python 3, and we'll have hello_person.py. Now all of the same errors will apply. So if we don't pass a name, we would get an error. And likewise, if we don't pass a language, we would get an error. But even if we pass an incorrect language, like French, for example, we should get an error. Let's check that out. And yes, we do have an error. It says invalid choice, French. We should choose from English, Spanish, or German. So let's go ahead and choose one of those. I'll enter in German and press enter, and we have Hello Dave. And I can see I forgot to put an exclamation mark inside of that function greeting. So let's go ahead and put that back. Seems like we have to have an exclamation mark with a happy greeting, right? So after German, let's put in Spanish now to test this out, and we have Hola Dave with the exclamation mark. Let's once again close the terminal here in VS Code, and let's show the file tree again by clicking the Explorer icon over here. And now, as we have in previous lessons, let's create a new file. Let's call this file rps8.py, because we're going to pull in the code from our previous example of rock, paper, scissors, and that file was called rps7 in the previous lesson. So let's just paste in the code from rps7 that we had, and we did learn how to make a module with our rock, paper, scissors game. But now we're going to go ahead and pass in a command line argument to the game so we can personalize the game. But before we do that, and I do want to thank Ahmad and those that comment on the videos, but especially thanks to Ahmad for catching this one, because in a previous lesson, the one on F strings, we created 3 F strings inside of our rock, paper, scissors game. And as he noted, we no longer need to use the string constructor here in lines 63 through 65, because you can just pass game count into this F string and it will go ahead and show it without using that string constructor. So it will just make it a string as you create that F string. So we can go ahead and select all 3 instances of the str and that parentheses, and I did that with Control D after I selected the first one. Then I'll press backspace. Then of course we need to get rid of the closing parentheses on those. And this will still work without that string constructor. Now that said, and I'll save those changes, I do want to highlight that on lines 33 and 35, you still need the string constructor here. And that's because we're applying it to that enum value, and then we're calling a string method. So we really need a string there specifically, and it's not being converted before that happens. So you need to go ahead and leave that string constructor on these 2 lines. But on 63 through 65 here, when we have the game count, player wins, and Python wins, thank you, Ahmad, for pointing that out, because I did miss that. It didn't cause an error. There was no problem other than it's just not needed, so we might as well remove it. So now let's scroll to the bottom of the file where we're calling rock, paper, scissors here, and we're going to change this just a little bit. I'm going to start by pulling this rock, paper, scissors definition here where we set it equal to RPS to create our closure. I'm just going to Control X to cut that and go ahead and put it right above the call to the function here. And then let's go back to our hello person, because this code that we use with arg parse is kind of boilerplate, and that means we're not changing much of this right here. We want to get a name to go ahead and pass to our game and personalize that. So let's just copy all of this, the import arg parse, all the way down to where we set the args equal to parser.parseArgs, and Control C to copy. And then let's bring it over to our rock, paper, scissors game. And this is going to go before we define rock, paper, scissors there. So right after the if name equals main, I will paste this in. Now we're not using the language argument, so then I can go ahead and remove that piece of it. Now let's change our description just a little bit. So here we'll say provides a personalized, so there we'll just change that word to personalized game experience. And now here, instead of the name of the person to greet, we'll say the name of the person playing the game. Playing the game. And Alt-Z once again to wrap any code down that wants to extend off the screen. Now I'm going to remove an extra line here, and then all we need to do is pass our args.name to RPS. And now we're finished with this part, but now we're passing the name value to our rock, paper, scissors game, but our game is not handling that yet. Let's start by going to the top of the file where the function begins, and now we know it's going to receive a param, so I'll say name, and let's put a default value just in case this would be used somewhere that it doesn't receive that name, so we don't have an error if that happens. And we'll just make the default value player1. After that, we need to go ahead and put in another non-local here and pass name because it's coming from above from RPS as it goes into the play RPS function. Now let's scroll down and see where else we can use it, and one place would be here where we ask the player to enter any of the numbers for rock, paper, or scissors. Let's make this an F string, and then we'll go ahead and put name in front here, so I'll say name and a comma, and then we could just make that a lowercase e. And then underneath here, we could also make this an F string and use that value. So we could say, whoops, not that. Let's go ahead, quote, and then we need a curly brace and name. And then let's put a comma. And then there we'll just put a lowercase y for you must enter as well. And you know what? Let's be a little nicer here. Let's put please in both of these. So we'll say please enter. And instead of you must enter, we'll say once again, please, and I need to get rid of that T, there we go. So it would be like Dave, please enter 1, 2, or 3. Scrolling down just a little bit further, we have another line here where it says you, so let's change that. We already have an F string, so now I'll just go ahead and remove that capital Y, and we'll put in name once again. I'll put in a comma and a lowercase u, so Dave, you chose, and then it would give that value. Now we have our nested decide winner function. So once again, we need a non-local for that name value if we're going to use it inside of this function, and we definitely are. So instead of just you win, now we could have an F string. So this once again needs to be an F here, and then we can put in our name value. So name, comma, you win. And now let's just copy this because it's also used on a couple of other lines. So Control C there, and then we'll highlight this, Control D to select the next one that's identical, and then Control V to paste. And we have that same F string for all of the winning messages. Let's scroll just a little bit more, and here on 56, where we have Python wins, well, that works, but we could personalize that a little bit more. Once again, we need to make that an F string if we do, and I hope I haven't missed any of those. /n, and then let's say sorry, comma, and put in name once again. We could put in a couple of dots, so sorry, Dave. And then we could even put in an emoji, so let's find a sad emoji here, and I just typed the Windows key plus period on Windows to bring up this emoji menu. So I have a little sad face with the message that Python won instead of me. Okay, after that one, let's look a little bit further. And yes, we can provide another one here on line 67. I'm sorry, on line 66 where we say player. It doesn't need to say player. Now it could have a personalized name. So let's put in name, and after that we need an apostrophe S. Now we can use that apostrophe because on the outside we have double quotes, so that single quote doesn't cause an issue. And how about we do the same for the play again message? So we'll put an F here to make this an F string, and instead of play again question mark, we'll have play again, comma, and then we'll put in that personalized name. So it's going to ask play again Dave, for example. And let's see if there's any other instances as we scroll down. And yes, we've got thank you for playing, which is fine. We could personalize that, but let's personalize the bye message instead. So we can say bye and then just put name in one more time. So now we've personalized our entire game. Now I know I went over that a little bit quickly, but we covered concepts we had before, from the F strings to the non-local definitions where we pulled that value into the other functions that were nested. Okay, let's hide the file tree with Control B, and then I'll press Control and the backtick to open our terminal up again. I'll type clear just to clear everything out. And now let's go ahead and start our RPS-8 file. Once again, we can't use the play button like we used to at the top because we need to pass in these arguments. So I'm going to say pi, and you might need to say Python 3, just depending on your operating system. Then I'll go ahead and say rps8.py, and I'm going to pass my name with the dash n as Dave. And let's see what we get. It says, Dave, please enter. And so I'm going to choose rock. And we got a tie game, but we can see Dave's wins are 0, and then it says play again, Dave. So I did personalize that fairly well. Let's see if we get something else. Let me choose a number that is not 1, 2, or 3, like 5. Dave, please enter 1, 2, or 3. So it's also being polite and working as expected. Another tie game. Let's go ahead and play till someone wins. And we've got 3 tie games. Let's go ahead and play again. And now we won, and it says, Dave, you win. So that's exactly what we wanted for this game. So now you know how to pass command line arguments, and we've personalized our rock, paper, scissors game. I've got VS Code open, and you can see I have a folder for lesson 16, and I already have all 3 files in it for lesson 16, and that's because today is a student challenge. Today's lesson is different. We're focusing on applying what we've learned instead of learning something new, and we will attempt to complete a 2-part student challenge. So I've got the terminal hiding my code, so you don't see the code that's in these 3 files for now. Part 1 will be creating a new game called Guess My Number, and this will require you to take what you've learned from building the rock, paper, scissors game in previous lessons and apply it to a new problem. So let's look at how this game works first. So I'm going to launch Guess Number, the file that you see over here on the left side, from the terminal, and I'm in Windows, so I type pi. If you're in Mac or Linux, you should be typing probably Python 3. And then I'm going to type the file name, guess_number.py. Now it's going to accept a name as we learn to pass in a command line argument and receive that with the argparse module. So I have -n for name, and I'll just pass in my name, Dave. When I press enter, it should launch the game, and it says, Dave, guess which number I'm thinking of, 1, 2, or 3. I'm going to guess 1, and we can see the result. It says, Dave, you chose 1. I was thinking about the number 1. So Dave, you win. Game count 1. Dave's wins 1, and my winning percentage is 100%. Then it asks if I want to play again or not, so I'll say yes. I'll choose 2. And it looks like I didn't get the number right. Once again, the game was thinking about the number 1, but I chose 2, so it says, sorry, Dave, better luck next time. Now it updates the game count. My win number is still the same because I didn't win, and it updated my winning percentage. Now it's only 50% compared to 100% before. Now, of course, we can quit this game as well, so let's go ahead and play one more time, though, just to see what happens if I choose a number that's not 1, 2, or 3. It just says, Dave, please enter 1, 2, or 3. So then it starts over. And that's what we would expect to do. So let's go ahead and pick another number. And I didn't win again. So now my winning percentage is 33.33%. I'll go ahead and choose Q to quit. And then we get the thank you for playing and goodbye, Dave. So a lot like our rock, paper, scissors game, but not quite. So you can take what you learned from that and now create this new game, Guess My Number. Now, after completing the first part of the challenge, which is creating the Guess My Number game, then we're going to move to the second part of the challenge, which is to build an arcade that will allow you to choose between rock, paper, scissors and Guess My Number. And this is going to require you to take what you've learned about modules in previous lessons and apply it to a new problem. So let's look at how the arcade works. So we launch it much the same way. I'll say pi and then arcade.py, and from there I'm going to pass in a name at the command line as well. And once we launch the arcade, it says, Dave, welcome to the arcade. Please choose a game, and I can choose 1 for rock, paper, scissors, or 2 for Guess My Number, or press X to exit the arcade. So I'm going to choose 1 for rock, paper, scissors, and you can see the game launches now. So I'll choose 1 for rock and Python 1, but I'll go ahead and quit. And when I quit the game, it says, Dave, welcome back to the arcade menu. Please choose a game. So we're not going to exit the game entirely or the arcade from our rock, paper, scissors game or from the Guess My Number game. We're going to exit it when we're back at the arcade menu. So now I'll choose Guess My Number and we'll see if it works the same way. So I'll guess a number and I did not win, but I'll go ahead and quit. Now it says, Dave, welcome back to the arcade menu. Now, if I don't choose 1, 2, or X here, I'll press 5 again. It's going to just start over and say, Dave, please enter 1, 2, or 3. And I guess I need to change that to 1, 2, or X, actually. So I need to update my code just a little bit. Go ahead and do that in yours as well, because the options here are 1, 2, or the letter X. So now I'll just press X to leave the arcade, and it says, see you next time, bye, Dave. So you've got the idea here for the arcade and how it should work. You should be able to launch either game from it or exit the arcade. And when you launch those other games, when you quit those games, you should go back to the arcade. So that's a different challenge, and you're, of course, applying modules and other things you've learned along the way to conquer this challenge as well. So now you should be ready to pause the video and attempt to build the Guess My Number game, part 1 of the challenge. So when you finish building the Guess My Number game, come back to this video and I'll show you my code for the game. So I'll see you then. Okay, we're back and ready to review the code for the Guess My Number game. So I'm in the guess_number.py file that I created. I'm importing a couple of modules just like we did in the rock, paper, scissors game. I've imported sys and random. Notice I don't need an enum now like we did in rock, paper, scissors. Now I create this parent function because we're still going to need a closure to keep track of the game count and player wins. So I have this parent function called guess number, and then inside, after I set the game count and player wins to 0, I initialize those values essentially. Then we have our next function, which is play guess number. Here, of course, we need those values. We're going to get the name from a param, by the way, which also has a default of player 1, if nothing else. And we're pulling in the non-local name and then local player wins right now. Not game count yet, but we will later. And then, much like rock, paper, scissors, we have an input with the player choice. And much like rock, paper, scissors, if they don't choose the correct thing, we go ahead and use recursion to launch this play guess number once again. So we call it and it starts over from the top. Then we have the computer choice decision here, and it's just a random choice between 1 and 3. We did that in rock, paper, scissors as well. Now we go ahead and print saying, personalizing the message as well, and the saying you chose, and give the player choice. Now the player choice up here was a string, and that's fine to put in here. We didn't need a number at this point. And then, of course, we say, I was thinking about, and put the computer choice here. It is also a string. And if it wasn't, we're still using these F strings, so it would make the conversion without us using those class initializers as we previously did when we were concatenating strings. But down below, we go ahead and do make those numbers. They were both previously strings in player choice and computer choice. Now they're numbers in player and computer. And we're going to use those as well. So here we're looking at decide winner, this function, and we have player and computer. We need to once again bring in the name and player wins. And now we're going to compare player and computer. And if they are equal, because that means we've guessed the number correctly, we go ahead and we increment player wins with our plus equals, and then we return the phrase here saying you win. If not, we say sorry, better luck next time. So that's returned, and then we hold the value that's returned from this function in game result as we pass in player and computer, the two params that it receives. Now these are argument values being passed in, and we print the game result. Now here is where we need the game count, and this is just like we did in rock, paper, scissors as well. So we increment the game count. Then we're going to output the game count. We're going to output the number of player wins. Now this is new. We have an F string here saying your winning percentage. Now inside of the F string, we can calculate that winning percentage by dividing player wins by the game count. And now we're formatting the output of that calculation as well. And we went over some of that formatting when we learned about F strings. So we have a colon here, then a .2, which means we want 2 decimals, and the percent sign. So we're going to display that as a percent. And then we ask if they want to play again, just like rock, paper, scissors, and we handle that the same way, whether they want to play again or maybe they don't want to play again. And of course, they have to enter in the correct number or it just loops back through. Then if play again, we're going to use recursion once again and launch the play guess number function once again. But if not, then we're going to go ahead and print the thank you for playing. Now here's something that's just a little different because we want the guess number file to be able to run on its own. And if that's the case, then that means name will equal main. So if that's the case, we're going to use the system exit and exit out of the game when they choose to quit. But if not, say it's launched from that arcade file, then we just want an empty return here, which will go ahead and exit out of this function, and that would take it back to the parent function that it will be in the arcade file. So we do need to have a conditional here based on whether the file is launched by itself, where name equals main, or if this file is actually a child, which would be running from the arcade. So then we just have an empty return. And then, of course, at the end of this function, we're returning play guess number so we can create the closure that we learned about. So that is what is happening there. Now we're here saying if name is equal to main, we're going to go ahead and parse those arguments passed at the command line, which should be a name. And then when we get down here, we go ahead and finish creating that closure because we set guess my number equal to the guess number function that receives the name from the arguments. And then we call the guess my number function. And that once again goes back to our lesson on closures. So a little simpler than rock, paper, scissors. Much of it is the same. And we were able to remove a few things as well. I hope you did good on this challenge. Now with the Guess My Number game complete, you are ready to take on part 2 of the Student Challenge, where you build an arcade menu that allows you to choose between rock, paper, scissors, or Guess My Number. So pause the video and come back when you're ready to see my solution. We are back and ready to review the code for the arcade menu. So at the top of this file, we're once again going to import the sys module. Then from the RPS file, which we have rock, paper, scissors in, we're going to go ahead and import RPS. And from the guess number file, we're going to go ahead and import the guess number function. Now quickly, I want to just go to the RPS file because the same thing that we did in the guess number file, the only thing I changed in rock, paper, scissors from previous lessons is when we exit the file. So once again, if name equals main, then we use the sys.exit, and that's because we called the rock, paper, scissors function directly from this file. If not, if it's called from the arcade file, for example, we're going to say else here and just return and have an empty return. So we go back to working with the code in the arcade file. So just highlighting that in the RPS file, the same as guess number. And that's the only change to rock, paper, scissors from any previous lesson. Okay, in the arcade file now, after the imports, it's structured much the same as we have defined other functions essentially. So we're starting here with play game. And then we have name equals player 1 as well, just as a default, just in case. Now, the first thing I do, we don't have a closure here, but we are defining this welcome back variable as false. It's a Boolean value. And that's because I want to give a welcome back to the arcade menu when we come back from either one of the games. Say we played rock, paper, scissors, we quit, and we come back. So here we only do that if welcome back is equal to true. Now notice we started a while loop right here. So I say while true. So it will be a loop that just continues if it is always equal to true, if we don't exit the loop in some other way. So if we come back to the arcade, we're still going to be in this loop, and we'll get that welcome back message if welcome back equals true. Now notice I'm not setting welcome back equal to true until after we check the player choice, because if they make the wrong choice, say the number 5 instead of 1, 2, or X, as we have for choices here, then it's going to relaunch this function. Now we wouldn't want to give a welcome back to the arcade menu message every time that they chose a wrong number. So I wait to set that welcome back equal to true here. Now this is much like we had in both games, where we have the input and we check that input and we give a message if the input is not what we directed the user to input. After that, we have a conditional if else if, and then an else here. So if player choice is 1, they have chosen rock, paper, scissors. Now we have the name value being passed in here as a parameter. So down here, we use that and we create that closure. Remember, we imported RPS. So now we set rock, paper, scissors equal to RPS with the name being passed in. And then we call rock, paper, scissors. And that is that closure that we created there. So it can keep track of the game count and the wins for Python and the user. But if player choice is 2, then we do the same thing for guess my number. It also uses a closure. So we set guess my number equal to guess number, where we're passing in the name value, and then we call the guess my number function. And now the else. So essentially here we're checking to make sure it's 1, 2, or X. But down here, we don't need to at this point. So we know if it's not 1, 2, it's going to be X. So now we just say, see you next time, and we use the system to exit the arcade. That's the full arcade function. It's not that big. Now, we do have the if name equals main. So if we launch the arcade from the arcade file, this is where we use the arg parse to get the name. And then down here, we have our welcome to the arcade message that's only going to happen the one time, right after it's launched. And then we just launch play game and pass in the args.name, which launches our play game function from up here. So I hope you did well on both of these challenges. If not, hey, it's no big deal. We're learning. So you might have picked up a thing or two that you hadn't encountered before. Although we did go over this information, sometimes it takes some time to learn how to apply it all. And I think learning how to apply what you have learned is very important. And you're only going to do that by trying to create some of your own things as well. So now that you have this code for an arcade and you can call any game you want, think of a couple other games you would like to create. What are some other simple games you might create that you could add to this arcade? So keep learning, and I'll see you next time. I've got VS Code open, a new folder for lesson 17, and let's create a new file, and let's name it lambda.py. Okay, we have 2 topics today, and we're going to start with lambda functions. A lambda function is a single expression that returns a value. So let's look at a simple example, and we start with the keyword lambda. So LAM, and then you see BDA, and I'll just press tab, and there it is, and Visual Studio Code highlights it because it's a keyword. And now we're going to pass a param, so I'll say num, then I'll put a colon, and I'm going to say num times num. So this function would square a number. So if we pass 2, it would be 2 times 2. And this is a single expression that will return that value. But notice we're not using the return keyword, but it will return the value. Now we can't call this function into action by name because it's anonymous. And sometimes lambda functions are referred to as anonymous functions, but we can assign a lambda to a variable. So now I'll just take a variable name over here and I'll say squared equals, and now it's going to store that function in the variable name squared. So let's go ahead and use the function as an example, and I'm going to need to print the output. So I'll say print and then say squared, and I'll pass in 2 like the example I gave. Now let's go ahead and choose this drop down here, and I'm going to run the Python file, and we'll see over here on the right, we get the number 4 as the output. Now, just to understand the concept, let's make another one, but I'm going to press Control B to hide the file tree so we can see all of our code here, and we can still have our terminal over here on the right. We could even type clear to get some extra space and clear that out. So now our second lambda, so let's go, oh, and notice this added the def keyword here as I type squared there, and it added the return key. So Visual Studio Code formatted that lambda for me, and I didn't catch that until now. But let's go ahead and do the Control Z to undo these changes. Now, before I saved it, this is what I had. So squared equals lambda with a num, and that's the keyword lambda, and then we're returning num times num. So that is an expression. But then once I saved it into squared, it went ahead and changed it. So once again, when I save, it changes it to this def squared, and it made it a one-line function essentially. So VS Code's going to do some of that auto formatting, and that's okay, but it's actually the same thing. So now let's go ahead and create another one, and I'll call this add2, and it's going to be equal to a lambda, once again, that has a num, and then we'll say num plus, or plus, I need the plus symbol instead of the multiplication, num plus 2. And then we will print what it puts out, and we'll say add 2, and let's pass in something like 12. Now when I save, it's probably going to reformat this in Visual Studio Code again, so I'll save, and yes, we can see it was reformatted. But let's run the code, and we get 14 over here, which would be 12 plus 2. Now, even though Visual Studio Code is changing this formatting when I save, it's important to know how to write a lambda as I'm writing it with that keyword lambda. So we're going to look at some more examples, and in the future, you'll see why that's important when we get to the second topic, which is higher order functions. But first, let's create one more, because I want to show that a lambda can accept more than one parameter. So I might have a function, and I won't set it equal to a variable here. I'll just write the function. So I'll say lambda, and then I'll say a and b, so 2 params here, and then this would be a sum function, so we just say a plus b. So you can see what this would do. This is an expression, a function expression, which is a lambda function that accepts params a and b, and then it returns the sum of those two. Now if we set this equal to sum, of course, then we'll get that reformatting from Visual Studio Code again, but I'm going to go ahead and use sum here, so I'll say print, and I'll say sum, and we'll pass in 2 and 2. Of course, when we save, it reformats it, and you can see it written in a more traditional function way here. And let's go ahead and run the code, and we get 4 once again. And with that being the same as our first function that was squared, I want to show that's different, so let's go ahead and just pass in 2 other numbers like 10 and 8, save, rerun the code, and now you can see we get 18 because it's 10 plus 8. And before moving on, just so I can have this in the source code for you, I want to put the lambda functions in comments, even though Visual Studio Code reformatted when we save. So let's put a comment here and how we would write this with a lambda. So I'll say lambda, and then we had a num param, and then we would say num times num without that keyword of return there, and without the keyword def as well. So just our function expression, which is a lambda. So that was our squared function. Now let's move on to the add to function, and we'll write another comment here, which was lambda, and then we'll say num, and then it has num plus 2. And then I'll go ahead and just copy this down and paste under sum as well, so we can write a lambda there. And that has a and b, so we had a and b, and then it was a plus b here. Just so you know what the lambdas look like, and you can refer to that in the course resources. Now let's scroll up for some room, and I think you have a good idea of what lambdas are about and how to create them. I'm going to add a line of comments here just so we know we're moving on to our next section. So the next logical question after you've learned about lambdas is, when would I use one? Well, they're most often used inside of another function, really when you just need a quick function that you don't want to save for later. So let's look at how this works. And it also makes lambdas very powerful when you do this. So I'm going to define a standard function here, and I'm going to call it func builder, which stands for function builder, and it's going to receive one param, which is x. Now inside this function, I'm going to return a lambda function. So I'll say lambda, and then this is going to be num once again, and then we'll say num plus x. Now let's look at how we can use this function to build other functions. So I'll say add 10 equals func builder, and I'm going to pass in 10. And then below that, I'll say add 20, spell 20, there we go, equals func builder, and I'll pass in 20. Now what we have here is the x that we're passing in currently. So we're passing in 10 as x, and then this lambda with add 10 is going to add 10, and then the same for add 20, because x would be equal to 20. But notice the rest isn't defined yet, and we're returning a function. Now you've seen this before. When we used closures, we returned a function, and then we called it later. So we haven't called add 10 or add 20 into action yet. So let's go ahead and do that now, and we'll need to do it in a print to see the output. So I'll say add 10, and I'll pass in the number 7. Now I'll copy this down with Shift Alt and the down arrow, and I'll change that 10 to a 20, and we can add 7 to that as well too, so we'll know the difference. Let's go ahead and save and see if we get any formatting that's different, but no, Visual Studio Code left our Lambda the way it was inside of a function. So that's good. Let's go ahead and run the code. And now we can see we get 17 and 27. So we're using a Lambda as a function builder essentially here in this first function. So the Lambda is being returned, and then the Lambda is actually called when we call add 10 and add 20. So in our example here, the Lambda receives 7 as the num parameter, and it received 10 the first time as the x param in the func builder function. So now we're ready to move on to higher order functions. So I'll put another dividing line in here with our comments. And then let's go ahead and discuss this. What is a higher order function? Well, it's a function that takes one or more functions as arguments, or a function that returns a function as its result. So yes, by that definition, up here we just created a higher order function as well because it returned a function as its result. That's our func builder here. And now we're going to look at some higher order functions that actually accept functions as parameters when we pass those in. So I guess, once again, when we define the function, we define it to accept a function as a param, and then when we actually pass in the function, that function is an argument. And I should also highlight the fact that yes, when we learned about closures, we were returning a function just like func builder, so we also used a higher order function there. But this is where I really like to start to talk about them, and that's when we start passing functions into functions. And that really brings up the discussion of higher order functions for me. Now, these are predefined functions that are built into Python. So we'll just use this function. We won't have to define it. And of course, then we'll be passing in a function as an argument. So let's start by looking at our squared lambda again. So I'm just going to type this out once again. It's lambda, and then we have a num, and then that num is going to be multiplied by itself. So that lambda squares a number when it receives it. So now let's define a numbers list because we need a collection of data. Now we've learned about different data collections. It wouldn't just have to be a list. We could have tuples and so on, but I'm going to use a list for most examples today. I'll pass in some numbers here, 3, 7, 12, 18, 20, 21. That's good. They wouldn't have to be in order. You could use any numbers you really want to. And then I'm going to say squared numbers, or squared nums. Let's just say squared nums equals, and then we'll call map. Now map is a function that is built into Python, and it receives a function as the first argument. So what I'm going to do is take this lambda right here, use Control X, and just paste it in here with Control V. So that is the first argument. Now the next argument is your data collection. So now we'll pass in numbers. And then it's going to iterate over every item in this list, each number, and it's going to apply that function to it. And then it will create a new list. Well, it won't actually be a list at first. We're going to need to apply the list constructor to it. So I'm going to say print, then I'm going to have list as our list constructor, and then I'll say squared nums right here. So let's go ahead and save this, and we'll run our code and see what we get. So we have a new list here. And notice each number has been squared. So 3 times 3 is 9, 7 times 7 is 49, etc., all the way through the list. So really, that's something we could achieve with a loop, but knowing how to use map is so much more efficient, and your code is so much cleaner. This is just one line of code that we achieve all of that in by passing in a lambda function and passing in our data collection to the function map. Now we're going to look at another built-in function that works much like map, and it is called filter. So we're going to use that same numbers collection up here, and then we're going to filter some results with that. So let's create another lambda. So I'll type lambda, and now this will receive a number as well. We'll take that number, and then we'll use the modulus. And if you remember the modulus operator, it actually returns the remainder of division. So anytime we divide by 2, there's going to be a remainder if the number is odd. So what we want to say is we're checking to make sure it's not odd, or actually we should say we're checking to make sure that it is odd. That's what I want to do, is return the odd numbers. If it was equal to 0, it would be even, and if it's not equal to 0, as I typed here, it will be odd. So let's think about this lambda. What will it actually return? Well, it's going to return true or false because we're doing a comparison. So it's either equal to 0 or it's not. So it's either true or false. If true, this is an odd number. So now let's define our odd underscore nums, and we'll set this equal to filter. Now we're going to pass in the lambda. So once again, I'll highlight this and Control X to cut, Control V to paste. And then we had our numbers list that I'll pass in here as the second param to filter. We've got one line of code with filter, just like we did map, and I still need to print and then use the list constructor and say odd underscore nums and save. Let's go ahead and find out what is odd and what is not. We actually had our lambda return true or false, and filter, the filter function, then only returned the numbers that got the true result. And so we can see we previously had these numbers, and 12, 18, and 20 were even, so we only have 3, 7, and 21 in our new odd nums list. So now both of these results could be achieved by creating a loop and looping through the numbers and doing the appropriate actions through each iteration of the loop. However, once again, much simpler to have one line of code where you pass in a lambda function and apply it to each item in your data collection that you also pass in to filter, just like we did with map. But map has a different approach than filter. Filter filtered out anything that did not get a true result from the function we passed in. And map returned the result of this function applied to each item in our data collection. We've got one more higher order function I'd like to cover today, so let's scroll up for some room, and then I'll come down here and I'm going to type an import line, but just know that when we save, VS Code is automatically going to take this import line to the top of the file. So we won't see it down here on line 52 anymore, it will be probably on line 1. But we're going to say from functools, import reduce. Now, reduce can be a more complex function, but at its most simple, it just adds everything together. So let's look at an example that is simple first. Let's start with our lambda, and the function that reduce accepts needs two parameters. And the first is an accumulator, or you could say a subtotal. The second is the current, which represents the current item. So here we're just going to say take the accumulated total and add it to the current number as reduce iterates through our collection of data. So now we need some numbers, and let's define those here. We'll say numbers equals, and we'll go 1, 2, 3, 4, 5, and back to 1. That should work. Okay, after we have our list of numbers, let's define total and set it equal to reduce. And then we're going to pass in our lambda. So I'll highlight it and say Control X, paste that in as the first param. And after the lambda, we need to pass in the numbers data collection. Now that wrapped down to the next line, but that's okay. It's still basically one line of code. You can see line 58 just got a little deeper here. Okay, so now we've done that, and we're just going to print total. I do not need to use a constructor here. These are all numbers, and they will just be added together. So we'll save this, and you saw the import is now gone. It's probably at the top of the file. Let's go ahead and hit the play button to run, and we get the total of 16, which is the total of all of these numbers. Now, adding all the numbers together is a good example to, a simple example to show how reduce works. However, you don't want to do that when there is a simpler solution, and reduce is kind of a complicated solution. So if I remember right, I named a function sum up here somewhere. Let's find it. There is our sum. Let's call this something else like sum total. So I'll just put a total at the end of this. We'll say sum underscore total would be more accurate for a Python name. So we'll call this sum underscore total just to have it named something different, because there's actually a built-in function named sum. So you don't really want to name them after a built-in function. So now we could just say print, use the built-in function sum, pass in our numbers, which this is very much simpler than using reduce. And if we run this code, we should get the same number. Yes, 16 twice. So while we're using reduce, we don't want to use it if there is a simpler solution. But reduce can provide some more complex solutions. One thing you can add here, for example, is a starting number. So a starting value, let's go ahead and put that in, and we'll say 10, and we'll save and run this code again. And now we have 26 and 16. So we told reduce to start with another value. However, we could also do that with sum, if I remember correctly. Let's try it out and put in 10 here as well. So we run this, and now we've got 26 twice. So once again, we're not doing anything with reduce that we can't do with sum right now. So sum would be the better solution. However, let's look at a more complex solution for something else we could do with reduce. So I'll scroll for a little bit of room here, and we'll give a second example of reduce. So I'll create a lambda, and this is going to be similar to what we had because it still gets the accumulator and the current params. And now inside of this, we'll take the accumulator, and to it we will add the length of the current item because the items are going to be strings. So now let's go ahead and create a list of names. And inside this list, I'll put my name, and then let's put Sarah Ito. And let's put, I don't know if you've heard this song, but there's a long name involved. It's John Jacob Jingleheimer Schmidt. So there's a lot of characters there now, and that's essentially what we were going for. If you haven't heard that song, look it up. Okay, now we've got character count being defined. And so what we're going to do is add up all of the characters in all of the items together and get a total. And we can use reduce for that. So we'll say reduce, and here we'll pass in our lambda. So I'll Control X and put it right in here as the first argument. And now as the second argument, I'm going to pass in names. And remember, we do have that optional starting value. And here it's not optional because we're using strings, but we want to tell reduce, hey, we're going to be using numbers. If not, it would view this as a string that was trying to add a number to, and we would get a type error back. So we put in the starting value of 0 as well, and then we'll have our character count value. So let's find out how many characters in total if we added all of the characters up from all three names that we have. So now we can run our reduce, and we get 47. So that is a little more complicated example there to show a good use of reduce, even though it's still kind of a simple example here learning. You'll learn more about reduce as you continue to learn more about programming. But now today we have covered lambda functions, function expressions, and higher order functions. Remember, it's a higher order function if it receives a function as an argument or if it returns a function. I've got VS Code open and a new folder for lesson 18. Let's create a new file, and let's name this file classes.py. Now, classes are kind of like blueprints when we want to create something, and we're going to create objects with classes. So you could say they are blueprints for objects. Let's look at a simple class. I'm going to create a vehicle class. Notice we capitalize the class we defined. So I used a capital V on vehicle. Now inside this class, we can have properties, things we define, like a vehicle might have a certain amount of doors or a make and a model, which is what I'm going to use today. But then there's also actions a vehicle can take, such as going and stopping, or let's call it moving or moves today. So let's define a few things here. And I'm just going to start with a basic method, which would be an action. We want to take properties and look at those as details about our class or details about the object we're going to create from the class, actually. And we'll look at methods as the actions the object could take. And we need to define those methods inside the class. So I'm going to define a method called moves, and we pass self in to our methods. Now all the self is it's just referring to itself. So we're going to need that, and you'll see why inside of these classes and of course the objects as they're created. But we'll just start by knowing we need to pass that in. Now that we have self passed in, I'm going to print, and here I'm just going to say moves along. Notice I'm not really using self right now. Let's just put a couple of dots. But there we go, a very simple method. and it's inside the vehicle class. So now if I want to create an object from this class, let's call this my car. So I'll say my underscore car equals, and I'll call the vehicle class. So now I've created my car, which is different than possibly your car that we could also create from the vehicle class. So I've got my car, and now I could call the moves method on my car. So I say my underscore car, use dot notation, and notice we have moves available here at the top. So I'll press tab and then just add the parentheses after to actually call that method. And we'll save this file. Let's go ahead and run our Python code by choosing Run Python File from the drop menu. And now inside of our terminal here, we see moves along. So we called the moves method on my car. So to clarify this once again, and I'll hide the file tree with Control B, but to clarify this, my car is an object that I created from the class vehicle. Now I also mentioned that a class could have properties. Say we wanted to set the make and model for the vehicle. We do that with an initializer function called init at the top. So we'll say def. We have two underscores, which you've seen before when we use something special like main, and we use those inside of functions, where we had two underscores main and then two underscores, and that's a common theme in Python. So here we have our initializer, or our init function, and it receives self, and then we're also going to pass in anything else that we need to pass into the class to create our objects. And here I want a make and a model. So these are the parameters. And now here we'll say self.make. Let's set this equal to make. We'll do the same thing here. Self.model is equal to model. So we're referring the object to itself once it's created. So self just represents the object that is created. And we're saying the make equals make, the model equals model. And of course, this is the blueprint. We actually create the objects when we set our variable here, like my car, equal to vehicle, and we call vehicle. So now I can't just call vehicle like this. I need to pass in a make and a model for my car. So let's say I have a Tesla, and then we'll say Model 3, for example. Now it's going to have these values as well. So above the call to the moves method, I could also print and say my underscore car. Then I could say dot make and get that value. Now I'll do Shift Alt and the down arrow to just copy that down. And I'll also say for model, so I can retrieve those values from the object that I have created here. So let's save this file. Let's run our code again with the play button. You can see we have Tesla, which was the mycar.make, and then we have Model 3, and finally we have moves along when the moves method is called. Now you can put more methods or properties if you want to on your class. So let's put one more method in here that will use the properties that we have, and retrieving those through what is called a getter is sometimes more often. So are used more often. So we would use that more often than we would say mycar.make, for example. So let's just create a function here that will return these values, and I'll say def, and I'll call this get underscore make underscore model, as I want it to retrieve both. I'll pass in self once again. Now here we're going to use self in this method. I'm going to print, and I'm going to use an F string. Now inside the string, and let's use double quotes here so I can use a single quote here inside the string where I say I'm a, and I'll say self.make, which refers to that value that it will receive, and self.model, if I spell it correctly. And then let's put a period just to have proper punctuation. And so when we call get make model, it should return this statement and fill in self make and self model with the values it receives. So now instead of print mycar.make and mycar.model, I'll comment those out with Control/, and instead I'm going to call my underscore car.get make model, and you can see that was available in VS Code as well. When I used dot notation and just put the dot after it, showed the options. So let's save this and run the code once again. Now you can see we get the statement, I'm a Tesla Model 3, and then once again it calls the moves method and it moves along. So as I said, you can create more cars from this same class. So let's do that now, and let's create your car. Let's say your underscore car, and of course you can set this to whatever you want to. I'm going to have a vehicle and say it's a Cadillac, and then let's say it's an Escalade. And then after that, we'll go ahead and say your underscore car dot get make and model, and your underscore car dot moves. Save our code. So now we've created two different car objects from the same vehicle class. We can run this code, and first we get I'm a Tesla Model 3 and it moves along. Then we get I'm a Cadillac Escalade and it moves along. So now you can see how we can create different objects from the same vehicle class. I think you now have the idea about the relationship between creating a class and then creating objects from that class. So now let's move on to inheritance. And notice we have a very kind of generic class here. We're creating a vehicle. It doesn't say what type of vehicle. We might want to start to get more specific as we create classes that depend on this vehicle class. And we can do that with inheritance. So let me do that. I'll scroll down here. I'll create a couple of new classes. The first one I'll call airplane, because an airplane is also a vehicle, and it's going to receive the vehicle class. Now inside of airplane, we might give it another moves method. Now notice if we put the same method in here, this will overwrite whatever it would inherit from that vehicle class. So I'll say def moves once again, and it's going to receive self. And now inside of this, I'll just say print, and let's say flies along. And now let's create another one. I'll call this class, and this will be a truck, also a vehicle, but it's a more specific type of vehicle. And now we'll give it the same method also, and we'll say self. Inside of here, we're going to print rumbles along. And then finally, let's create one more. And I want to do this just because of how simple this can be. You can't have an empty class, so I'm going to say something like a smaller vehicle here, like a golf cart, and it will also receive the vehicle. And now inside of this class, since it can't be empty, we're just going to say pass. And this means it's going to inherit everything as is. We're not overriding the moves method as we did with airplane and truck. Now, because all three of these new classes depend on vehicle, it will inherit what we already set up in the vehicle class. So we need to pass in a make and a model as well. So let's go ahead and create these new objects now, and we'll pass in those values as needed. So I'm going to say Cessna, and that will be our plane. So I'll say airplane, and now I want to pass in that is a Cessna brand or make, and then we'll say it's a Skyhawk, which is the model. We need to move on to our next one. So let me just shift alt and the down arrow twice, and we'll start renaming everything here. So this is going to be Mac, as in a Mac truck. I'll name this truck. Once again, the brand here or the make will be Mac. And let's call this a Pinnacle truck, Pinnacle model. Finally, our golf cart here. So we'll just say golf wagon. That should work. And then for this, we'll say it is a golf cart. And now inside of here, we'll make this a Yamaha golf cart. And I have no idea what the model number would be. I'll just say GC100. And now we should have those same methods available to us. Not only the moves method, but also the get make model method that we had above. So let's go ahead and do that for all of these. We'll say Cessna dot, and once we put dot, we can see what is available. We have moves and get make model. So I'm going to just call both, and we'll put moves here as well. And now I'm going to highlight both of these. Let me scroll for some more room. And I'll do Shift Alt and the down arrow, and it will copy both lines at the same time. I'll do it one more time. And now I'll select the third Cessna, Control D to also select the fourth, and change those to Mac. I'll select the fifth Cessna, Control D to select the next one, and I'll change these to Golf Wagon. That's going to make me laugh every time. Okay, now let's go ahead and run the code and we'll see what we get here. So we had our code from above and that stops after the Cadillac Escalade moves along. So here we are. I'm a Cessna Skyhawk. It flies along. I'm a Mack Pinnacle and it rumbles along. And I'm a Yamaha GC100, which is the golf cart, and it moves along because we didn't set any new moves method on the golf cart. We just put pass. So it inherited the original moves method directly from the vehicle class. And so now you have a basic idea of how inheritance works, and our airplane class, our truck class, and our golf cart class all inherited from the vehicle class. But what if, for example, you wanted to pass in some more information besides the make and the model? Let's say the airplane also needs the FAA identification number. But you have to have that identification number for every airplane. So let's go ahead and put in our init function once again. I'm going to grab that from the top because if nothing else, it's going to need to match. And once you put that in, that means it's overriding the entire init function in the vehicle. Put it in here. And now we have an identical init function, but let's say we want to add one more reference here. So let's put in our FAA underscore ID, and we would need to put in our self.FAA underscore ID equals FAA underscore ID. But there's something easier than just copying self, make, and model. So let's get rid of those, and instead we can use super, and then after we use this special function here, super, we can say dot 2 underscores init 2 underscores and then make and model. Now this means we're going to inherit these from the parent. So we don't need to set those individually like we would have in that parent vehicle class. So instead of having self.make and self.model equals here, we put in our super function and then we just pass the init, make, and model there. Now we could write another method that would use this FAA underscore ID, but I think you know how that works. So this is just important if you were going to create an airplane that had more information than its parent would receive or would have received. So when that happens, you need to redefine the initializer and, of course, to use the make and the model. If you don't want to define each line once again, you need to call super, so you can also bring those in essentially from that parent class. Now, when we define airplane here, when I define Cessna, it looks the same, except now we need to pass in, and I'll just put some random number here, but our FAA ID like that. So that would be the appropriate way to now go ahead and build an airplane object from the airplane class, because it will receive that one extra argument that is represented as the parameter here inside of the initializer function, that FAA underscore ID. Now I think you should have a good understanding of how inheritance works, how these classes, our three classes here, inherited from the vehicle class, and then we created our more specific objects of airplane, truck, and golf cart here below. Now there's one other thing I want to cover today, and that's polymorphism. So let's go ahead and get an extra line here in our code. I'm just going to print, have a simple string, and put a couple of new lines so we can actually tell when we log anything else over here in the terminal, it will be a little separate. Let's get some more room as well. And now I'm going to create a loop. So I'm going to say for V, oftentimes you see X or Y or whatever, but I'm just going to say V for vehicle in. And now I'm going to put in the different objects we've created today. So I've got my car, also got your car. We also created a Cessna, we created a Mack, and we created a golf wagon. Now, inside of this loop, we're going to say v.getMakeModel. We're also going to say v.moves, because all of these objects have both of these methods. And I notice this line's just a little bit long here. I'm going to go ahead and do Alt-Z if it needs to wrap down. Yeah, just wrap down the one character, but that's the colon. This is all still on the same line for our for loop here. Now, polymorphism is a big word, and that's what we're talking about. Polymorphism is the ability to behave differently in response to the same input messages. So what does that mean in our case? Well, it means we're going to get different responses when we call get, make, model, and moves, even though we're giving these objects the same input messages. We're saying, go ahead and provide the response to get, make, model, and provide the response to the moves method. And we're saying that to each of these objects. So that is polymorphism. Essentially, they all have the same methods, but that doesn't mean they provide the same response. So let's go ahead and save this, and we'll run our code, and we get those extra line breaks in here like I wanted. And now we see all of this information. So we're getting different responses depending on what type of method they've either inherited or that they have in their own parent class that they were created from, essentially. But what polymorphism is, once again, is we are giving the same input. We can loop through all of these objects and say get, make, model, and moves, but they all behave differently based on how they were built. So that's polymorphism. So today we've covered classes, which are our blueprints for creating objects, and then we covered objects themselves and what you do with those and how you create them from classes. And then we covered inheritance, where we have other classes that can inherit from a parent class, such as airplane inheriting from the vehicle class. And then we also covered, besides inheriting these, we can overwrite what we inherit, as we had new moves methods for these two different classes. And then we can also even pass more information in to one of these other classes if we want to. So that led us to learning more about this super function here that's called in the initializer of a class that is inheriting, so it pulls in from the parent class as well. And then finally, we learned about polymorphism, which we were actually using before we even looped in here, because we were calling moves on more than one object and we were getting different responses. And that's essentially what polymorphism is. Next time, we're going to work on a small project with object-oriented programming. And that's what you've learned the foundations of today. When we create objects, we will be using object-oriented programming. I've got VS Code open, a folder for lesson 19 over here on the left. We haven't created a file yet, and I want to start with a quick apology, because at the end of the last lesson, I said we were going to move on to an object-oriented practice project. That would be OOP for object-oriented programming. And I said that was next, but during the week I realized that we should probably cover exception handling first. So we're going to do this quickly today. Next time I hope to move on to that OOP practice project. Okay, so you've probably seen a Python exception before. Let's go ahead and create one, and we can do that by creating a file over here in our file tree, and I'm going to just call this exceptions.py. Now inside of this file, I'm just going to say print x. Notice we haven't defined x. Visual Studio Code notes that and puts a little warning squiggly under here that says, hey, this isn't going to work, but we're going to go ahead and put this into action so we can see the exception. I'm going to choose Run Python File here. And we see over here, and I'll drag this over a little bit more, and then I'm also going to do Control B to hide the file tree now that we've created our file. We can see it says this is a name error. So this is a specific type of exception, and it's telling us name X is not defined. So that's what an exception is. And now we're over here in the browser, and I'm at W3 Schools, and they have a list of built-in exceptions that are built into Python. And I like the way they present this. It's just a simple table here. So the exception name is on the left, and the description is on the right. Notice they each say raised. That's because in Python we raise exceptions. If you're familiar with JavaScript, we can throw errors there, but here in Python we raise exceptions. So on the left we've got all of the exception names, and on the right it says when they're raised. And all of these are built in, but we're also going to learn how to create our own custom exceptions today. Okay, we're back in VS Code, and we still have our name error over here on the right. And in our code, we are going to throw an error if we run this. So let's go ahead and handle this. And we do this in Python with a try block first. So I'm going to say try and put a colon. Then I'll tab over our print x, which will still throw an error right now. And then we can have an except block, and this will catch the error. Notice now we don't have the squigglies we had earlier. This still says it's going to throw an error because VS Code is helping us out. But we can just say except right here, and this will catch all errors. Now this is a bit generic. You want to be more specific, and I'll show you how to do that. But at first, I just wanted to show how you can catch pretty much anything right here. So we can catch this error, and then we can print something when we catch it, or do whatever we want, like say print there is an error. Now we won't get that specific information like we did here. Instead, we will get this, there is an error statement. Let's go ahead, save that, run the code just so you can see how it works. And now we have, there is an error right here in our terminal. Now what I would rather do than catch all errors, because this would catch everything and really we wouldn't get any useful information. It would just say there is an error. I would rather catch the specific error that might occur, like name error. So now this will only catch the name error. Then I could say something here specific, like, let's see, I'll say name error means something is probably undefined. I'm going to save that, but I'm also going to press Alt-Z to wrap the code down just in case I type a long line and we don't see it all underneath our terminal. So now that we have that and I run this code again, it's going to specifically catch that name error, and now we can see we have that statement. Name error means something is probably undefined, but another error it wouldn't catch. So let's try something else here. Let's say up above our try except, I can say x is equal to 2. And now I'm going to divide x by 0. And that's usually a problem also with mathematics when you try to divide by 0. So let's see what error we get when we run this code. And yes, we have a 0 division error. So that's another error, and it was not caught here in our except block. It only catches the name error. So now we can provide another except block to catch that specific error too. So 0 division error, and we could print something here like, please do not divide by 0. And that would catch that specific error. So if we run that, we now see that message. And so we've caught 2 specific errors, and that's still leaving everything else to be caught possibly by an except at the end of this. But there's other things we can do as well, and it's not always bad to throw an error. I said throw, there I'm thinking in JavaScript, to raise an error or let Python raise the error, like when we had one when we didn't catch our 0 division here in our own except when it just was raised by Python. That's not bad either, because you really don't want to just put a blanket over everything and then not know what that error might be. However, after the excepts, we can also have an else. So let's say there is no error. Now we would get here. So inside of this else, I could say print no errors. Now, if we throw, I say throw again, there I'm going to say that probably too many times. Anyway, if we raise an error like the 0 division error, it's never going to reach this else. So let's go ahead and run this code again that should raise the 0 division error. Here we go. And yes, we've got that please do not divide by 0. It never reaches the else. But if we go ahead and divide by 1 instead, so we should not have an error, and then we run our code, then we get our response here, which 2.0, and then we have no errors. So we made it to the else block. Now, one additional thing we can add here is a finally. Now, in the finally block, this is going to happen no matter what. If we have an error, this will still reach the finally block. And if we don't have an error, it will also reach the finally block. So I'm going to say print, and inside of our print, I'm just going to say, I'm going to print with or without an error. So either way, we run our code now and we get I'm going to print with or without an error. And if we switch this back to 0, save the file, run once again, we get our please do not divide by 0 message from our 0 division error, and we still get the print statement from our finally block as well. Now, I mentioned a catch-all could be bad if we didn't get the information about the error, but there is a way to handle this. So let's go ahead and add that after we're catching the specific errors. Here we can say except, and then we're going to say exception with a capital E as error. Now, inside of this block, we will print the error. So let's test that out now by coming back up to our try block here, and I'm just going to comment out the division by 0, but I'll leave it there for you in case you want to get the source code from the link to the course resources. And now I'm going to say if not type, and let's see, x, and then we'll go is string because it's currently an integer, so it's not going to be type string. This should make it to this if statement then, or what's inside the block, and we'll say raise, and now we can raise a type error. This is a built-in error, so you can raise one of the built-in Python errors on your own, and with this type error we're going to say only strings are allowed. And we'll save this, and now let's see how we catch this. It should catch down in our accept exception as error and print the error. Let's see what happens. Yes, we get our only strings are allowed message from the type error. And now notice we didn't have to pass this in. I'll just temporarily say Control X here to cut that out. I want to paste it back in after I give you this example. Let's run this code one more time without that message in there. And now we don't get anything at all. So really what we want to do is put a message in there so we can know. And we could even say type error only strings are allowed if we wanted to state that. But it's just going to be good to give some type of information when you raise an error on your own. So now I'm going to comment out these two lines, and let's look briefly at creating a custom exception. And we can get more specific, but I want to give a generic way first, and this is to just say raise exception, and then we can pass in a message, and I'm just going to say I'm a custom exception. And we'll save that. Now this should automatically raise this exception, so when we run the code, that's what we get. I'm a custom exception right here inside of the terminal. But you don't often see a generic exception like this. Often the exceptions are named to specify what we expect that exception to be. So if you're creating a custom one, you can still give it a custom name, and it should be descriptive. So we could say something like not a string error or something like that. I'm going to say, and by the way, they start out with class, I'm going to say just not cool error. And now, of course, this doesn't really describe much, but it's just an example. So I'll have just not cool error, which is a class, and then you must pass in exception right here as well. After this, I'm just going to say pass. We won't have any specific code to this error, but now, or this exception, but now I can raise this. So I'm going to copy this, and instead of raise exception, which I will comment out here, so that is commented out. Now let's raise our just not cool error, and now we can pass in a message and say this just isn't cool, man. And now we're ready to run the code once again, and we'll see what we get over here, and we get this just isn't cool, man. So we've created our own custom exception with our just not cool error. And with that, that's really all you need to know to catch exceptions or to create your own when you need them. And I wanted to show you this before the OOP practice project because we will be creating one of our own. Now that said, remember to wrap at least a try block around what you're trying to do, and then at a minimum you'll need one except, even if you're just catching each exception as error. But if you expect specific ones that are possibilities, it is good to, of course, create those as well. Remember, else is only going to happen if there are no exceptions, and finally is going to happen whether there are exceptions or not. These aren't required, but you can add else and finally to your try except blocks. I've got VS Code open. I have a folder for lesson 20 over here on the left. And 2 lessons ago, we covered Python classes and objects. And in the last lesson, we learned about Python exception handling. So today, we'll take what we learned from both of those lessons and complete a Python practice project. Try saying that 3 times fast. Python practice project using object-oriented programming, or OOP, if you will. So let's start by creating a bank accounts file. So I'll have a new file. I'll name this bank_accounts.py. Now this file is going to hold the classes for several different types of bank accounts, but let's start by just creating our first class, which will be bank account. So I'll type class and then bank account. And now inside of this bank account class, we'll start with our init function. And remember, that's 2 underscores and then init and 2 more underscores, and it will receive self, and then it needs to receive an initial amount that we're opening our bank account with. So I'll type initial amount here. And then also let's give this an account name that it receives. And then inside this initializer function, we'll say self.balance equals the initial amount. And then we'll also say self.name equals the account name that it receives. And then we're going to print some output here just to get some output when we open our bank account. So we'll say print, let's make this an F string. And inside the string, we'll start with a line break. So we start on a new line, and I'll say account. And then inside of this, we're going to wrap this in single quotes. We'll say self.name, and then another single quote. And then we'll say created, put a period, another new line, and now let's say balance equals, and a dollar sign, because this will be in US dollars, and we'll say self.balance, and I'm going to press Alt-Z to wrap this down to the next line as it starts to get longer. And then we'll format this, so we put a colon, and we'll put a .2f. So that means we'll have 2 decimal points in our self.balance, and that would represent the cents if there were any cents to go along with our dollars. And that's all we need to open an account. So let's save this file. And now in our file tree, let's create another file, and let's call this OOP_project.py. And in this file, we're going to import everything from our bank accounts file. So we'll do that with from bank_accounts, import, and then we'll put an asterisk, which stands for all. And then I'm going to create an instance of a bank account. So I'll say Dave equals bank account, and we'll start our bank account with $1,000, and we'll name the bank account Dave. And let's go ahead and create a second bank account. So I'll do Shift, Alt, and the down arrow to copy that down. I'll double click Dave, which selects the first one here on line 4, and then Control D. Now I've selected both, and I'll just type Sarah, and it will change Sarah with an A at the end, and it will just change the name on both. Now let's go ahead and change Sarah's deposit amount here that she starts her account with, and she'll get $2,000 to start her account. So now let's save this file, and let's go ahead and from the drop-down menu choose Run Python File. And you can see we've got a message here that says account Dave created, balance equals 1,000, and then account Sarah created, balance equals 2,000. Now I want to change this view so this appears on the right. So we should be able to go to View, Appearance, and as I have done in previous tutorials, choose, it's panel position, and then choose right. And now this is over here on the right, our code in the middle, and we see our file tree on the left. Now we're not going to add any more files, so we can go ahead and press Control B to hide that file tree and have a little more room for our code, and we can switch between the files at the tabs here at the top. So now let's go back to bank accounts, and let's add a method to our class, and let's call this method getBalance. And it's going to receive self, and that's all it needs to have because it's just going to output the balance of the account. So we'll say print, make this another F string, and inside of this we'll once again start with a new line, and then we'll say account, and we'll say self.name, so it names the account, and of course another single quote. We need a single quote to start with. I said another and we didn't put the first one. There we go. So we're just wrapping that in single quotes in the output as we see over here where it says account Dave and account Sarah. So after account and the name, then we'll just say balance equals, we'll have a dollar sign, and now we'll essentially have the same thing that we had up here. So we can just copy this where we had self.balance and we format it to have 2 decimals. So I did copy C and now or Control C and then Control V to paste. And so that is our method, getBalance. Now let's go ahead and call that over in our OOP project file. So just underneath where we opened our accounts, I'm going to type Dave.getBalance and call that. I'll copy that down with Shift Alt and the down arrow, and we'll also get the balance for Sarah's account. Now let's save the file, and let's once again run this file. And now I need this just a little bit wider so it doesn't wrap down. There we go. So now we create both accounts, and then we get the balance for each account with our getBalance method. Now let's go back to the bank accounts class once again, and let's add a deposit method. So we'll say def deposit. It's going to receive self, and it's also going to receive an amount. So whatever the amount of the deposit is. Here we'll say self.balance, and we'll set that equal to self.balance plus the amount that we've received. And now I'm going to copy our print statement from above where we get the balance, and I'll paste it below. Once again, Control C and then Control V. But I want to add just a little bit. So before we have the account balance, I'm also going to say deposit complete, and then go ahead and save. Now, essentially, we're getting the balance once again. So if you wanted to just have a print statement that said deposit complete, and then we call getBalance, we could do that also. So how about we do that? Since it looks like the same thing from above, let's go ahead and delete what we were going to print. We can get this all on one line, and it doesn't really even need to be an F string here because we're not inserting anything. And it looks like I need a quote right here at the end of our print statement. But after that, we could go ahead and call getBalance as well. And here we're going to do this with self.getBalance. Let's go ahead and save this method. And now let's run the file with our OOP project. But we first, of course, need to call the method. So I'm going to say Sarah, and now let's deposit. And now we need to pass in a value we're going to deposit. So let's deposit an extra $500 into Sarah's account. We'll save that. Let's go ahead and run the Python file. And now we have deposit complete, and it went ahead and called the getBalance method once again, so we can see Sarah now has $2,500 in her account. And now we need to go back to the bank accounts file, and we need to add a withdraw method. However, this gets a little more complex because anytime you withdraw money, you need to do a balance check to see if you have enough money or enough funds to complete the transaction. So for this, we're going to need to add a separate method called viable transaction, which will make sure the transaction can be completed before we go ahead and complete it. And because of this, we're also going to want to create a custom error that I'm going to name balance exception. So let's scroll to the top of our file, and just above our class bank account, let's create another class that I'll call balance exception, and it's going to receive an exception. And then inside this class, I'm just going to say pass because we won't put anything extra here. But this is a very descriptive exception because we're going to have a problem with the balance if we don't have enough funds to complete the transaction. So now let's scroll back down underneath the deposit method, and let's add our viable transaction method that we're going to need to use inside of our withdraw method. So I'm going to call this viable transaction, and then it's going to receive self and the amount. And then because of this, we'll say if self.balance is greater than or equal to the amount, then we can go ahead and complete the transaction. So we'll just return. But otherwise, we'll just have an else. We're going to raise the exception. So this will be the balance exception. And inside of this, I'm going to put an F string. Let me go ahead and close the terminal now so we have a little more room to read this F string. Say F, and then inside of this /n for a new line, and sorry, account, and now we can put self name, but I want that in single quotes again. Self.name, another single quote, and after that only as a balance of, and now let's put in our self.balance and our format here of 2 decimals. And it looks like we're pretty much complete. We just need our closing parentheses there. No, we actually have the closing parentheses down below. Sorry, I just put that on separate lines. So that is our balance exception and the message that goes along with it, which remember, we created the class above, and now we're just passing in a message with the exception here as we raise it inside of the viable transaction method. And we're going to use this method in our withdraw method. So now let's create the withdraw method. So just underneath this, we'll say def and have our withdraw, and it's going to receive self and an amount as well. I'm going to scroll for just a little more room here. And now inside this method, we're going to start with a try because we also want to catch an error if we actually raise that exception. So we'll have self.viable transaction, and we'll pass in the amount. Now here's where an exception could be raised, and we'll want to catch that below if we have that occur. So we will handle that in just a moment. But now let's go ahead and say self.balance is going to equal self.balance minus the amount. So we're beginning the withdrawal here because if we make it past this self.viable transaction and an error is not raised or an exception is not raised, then we will make it onto this line because then it will be okay to go ahead and complete the withdrawal. So now we'll say print, and we'll have a new line here, and we'll say withdraw complete. Now on the next line, we can go ahead and say self.getBalance once again to show the balance after the withdraw is complete. But now after our try, we can have our except. This will be a balance exception as error. Now inside this except block, we'll just print, and this can be an F string. And here we'll just say withdraw interrupted. There we go, spelled that correctly. And we can go ahead and pass in the error message right here as well, which of course already starts on a new line. So I didn't put a new line there to go with it. So this will print out withdraw interrupted, and then of course fill in this information right here that goes along with the balance exception. Now let's head back to our OOP project file, and underneath the deposit for Sarah, let's go ahead and say Dave withdraw, and let's withdraw an amount we don't have, like $10,000 here. We'll go ahead and run this file once again, and we can see, let's bring this over just a little bit, but sorry, the withdraw is interrupted. There it says, sorry, account Dave only has a balance of $1,000. Maybe I could bring this in a little bit so it reads better. It's not wrapping too well. There we go. So sorry, account Dave only has a balance of $1,000. So we raised our error and it did work as expected. Now let's go ahead and add a withdraw that will work. So Dave withdraw, and let's just withdraw $10 now. And let's run this file once again. And now it says withdraw complete, and account Dave has a balance of $990 because if you remember up above, we opened the account with $1,000. Now let's finish our first class here, our bank account class. Let's finish this with a transfer method where we could transfer money from one account to another. And this method is going to also check for a viable transaction because we'll need to withdraw money from one account and then deposit it into another. So it's also going to call those methods. So I'm going to once again scroll up for a little more room here, and we'll start our transfer method. So we'll say def transfer. It's going to receive self. It's going to receive the amount, and it's going to receive the account that we want to transfer money to. We'll once again start with a try block. And I'm going to print, and I'm going to start a new line, and I'm going to make it rather obvious that we're starting a transfer here. So 4, 5, 6, 7, 8, 9, 10. I'll put 10 asterisks, and then I'll put 2 new lines, and I'm going to say beginning transfer, couple of dots, and then I'm on Windows. You can pull up an emoji however you want to on your operating system, but on Windows I can press the Windows key and the period, and my emoji selector comes up. I'm going to type rocket, and I'll just put a rocket here for our beginning message. Now, after the transfer begins, then I'm going to say self viable transaction and pass in the amount so we make sure that it is a viable transaction that can proceed. Then we'll say self.withdraw and we'll pass in the amount once again. And then we're going to say account. This is the account we passed in that we're transferring money to. And we'll call the deposit method on that account and we'll pass in the same amount there that has been withdrawn from the other account. Then we're going to print, and here we'll say /in with a new line once again, and then transfer complete, and I'll put an exclamation mark. Once again, bringing up my emojis, I want to use a check mark here as well. So now we have our full transfer complete message. Let's go ahead and put some more asterisks at the end of this too. So I'll do a couple of new lines, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, once again, just to match that beginning message. So there's our full try, and then we have our accept as well, and this will be accept balance exception as error, and inside the accept block we will print. We'll have an F string here, and then we'll say transfer interrupted, and I'll once again pull up my emojis, and I want an X. I'm just going to use a red X there so it's obvious, catches our attention. Then I'll close my emoji selector, space over, and we're going to pass the error into the string as well so we get the message from the error. Now let's go back to our OOP project, and then let's transfer some money. So I'm going to say Dave.transfer, and first I'm going to try to transfer $10,000 once again, which should trigger our transfer error now, not the withdraw interrupted, but we should see transfer interrupted. Let's try that out. So we'll run the file, and clearly I forgot to pass in what else was needed, which is the second account. I need to actually transfer this to Sarah. So I'm transferring $10,000 to Sarah's account. So we had an error when we didn't pass in the other param that was needed here. So now let's go ahead and save this file once again, run this, and yes, we had beginning transfer, but then the transfer was interrupted, and it says, sorry, account Dave only has a balance of $990, so no way we could transfer $10,000. Let me do Shift-Alt and the down arrow and change that transfer to $100 that we're going to send to Sarah. So we'll see the beginning transfer and the transfer interrupted again, but then after that we're going to look for a successful transfer. Let's run the file again, and yes, so above the transfer was interrupted, but now here is a full transfer. So we have beginning transfer, then the withdrawal is complete because we call the withdrawal method, and now it shows Dave has a balance of $890. And then it says deposit complete, and it shows Sarah has a balance of $2,600. And finally, it says transfer complete. And we have completed our main bank account class. But now let's go back to the bank accounts file and let's start a new class. So underneath this, we're going to create another class, and this one is going to use inheritance from the bank account class. And this is going to be an interest rewards account. And I'll abbreviate account like that. And then we're going to pass in bank account, which is the parent that we're going to inherit from. Now there will be no new properties, so we don't need to create a new initializer at the top, our init function, but we are going to overwrite the deposit method because any deposit in this account gets an added 5% to the amount that's going in as the deposit. That's the rewards. So here let's say def deposit once again. And we can see Visual Studio Code wanted to fill everything out for us, so it's already returning and calling super as the deposit amount. That's very nice, but that's not exactly what we want. So I'm going to delete this second line that VS Code added for me automatically. Instead, I'm going to say self.balance is going to equal self.balance, and then I'm going to say plus the amount that we're passing in. But if we want to add 5% to the amount, we don't want to just add the amount. So let's go ahead and put a parentheses here just to indicate our order of operations, and we'll say amount times 1.05, which would actually add that 5%. I'll close the terminal window over here again so this can stay on one line. So we're not just adding the amount to the balance, but we're adding an additional 5% to that amount. After we do that, we can say print, and then we don't need an F string, we'll just have a line here that says deposit complete. And then on the next line, we should be able to go ahead and say self.getBalance once again. And this is really all we need for our new class, because it should inherit everything else from the parent class bank account. So we were just overriding the deposit, so now it has the interest rewards added. Let's go back to the OOP project file and let's try this out. So first, let's start by creating a new interest rewards account for Jim. So I need to say interest rewards account. Now we're going to open this with $1,000 for Jim also, and we'll name the account Jim. I'll scroll up for some more room. Underneath opening the new account, let's go ahead and call Jim get balance, so we can check that method out. Then let's also say Jim.deposit, which remember is also going to use get balance in there, but we'll just pass in an extra $100 to Jim. So he should have $1,100, but also another 5% of $100. So at this point, when we check the result, we should be looking for $1,105 in Jim's account after that deposit, because he would get a reward. Then let's go ahead and say Jim.transfer, and Jim will transfer $100 to Dave. Now the transfer method, if you remember, not only uses the deposit method, but it also uses the withdraw method. So that should also indicate that those methods are working. So let's save this and run our file once again. Okay, let's scroll up so we can see where everything starts here. And we have account Jim created with $1,000. And now we got the balance, which was $1,000. And then Jim deposits another $100, and with his rewards account, he gets an extra $5, which is an extra 5% of that $100. So now Jim has $1,105. Then Jim transfers $100 to Dave. So we begin the transfer. It says the withdrawal is complete. And then account Jim has $1,005 instead of $1,105. And now the deposit is complete for Dave. Dave doesn't have a rewards account, so he just gets the $100 on that transfer deposit, and it's back up to $990, and then the transfer is complete. So everything with our interest rewards account worked as expected, and you can see it has all of the methods that it inherited from the bank account class. Now let's go back to the bank accounts page one more time, and we have our interest rewards account class here, and underneath this we're going to create one last class. So let's call this class, and here I'm going to say savings account. Now savings account is going to inherit from an interest rewards account. I'm going to scroll up for a little more room here. Now, our savings account is going to add another property to the class called fee. And so in order to do this, we are going to need to define that init method for the class again, and then we'll use super to bring in everything from the parent class. And the parent class, as we mentioned, is an interest rewards account. So let's start here just underneath, and we'll say def, and then we'll put in our init method, which will receive self. It will receive an initial amount, as our parent class bank account did, which is actually a grandparent going up 2 levels there. And then underneath here, we'll go ahead and call that super function, and then we'll have init after it, and now we put in initial amount once again, and after initial amount, we'll also put in account name. Now, no colon after that. I accidentally typed that for a second, but no colon there. And then we'll add our new property, which is self.fee. And there's going to be a $5 fee for any withdraw from this account. Now, this is inheriting from the interest rewards account, and it's a savings account. So also any deposit will get that additional 5%, just like Jim's account did when he had an interest rewards account. However, it's a savings account, so anything withdrawn from this account is going to have a $5 fee on every withdrawal. So to do that, we need to go ahead and override the withdraw method by adding a new withdraw method here. So this is going to receive self and amount. And now inside the withdraw method, we're going to have a try. We'll start with checking to see if we once again have a viable transaction. So we're going to have the amount plus self.fee, because that would be the total amount withdrawn. Let me go ahead and close our terminal once again. So we're not just checking the amount. So this is a little bit different than the initial withdraw method that we had above in that bank account class. After this, we're going to set the self.balance equal to self.balance minus the amount plus the fee that is added on. So that total needs to be withdrawn from the balance. Then we can print, and we'll start with a new line once again, and we'll say withdraw complete. And then after that, we should once again call the balance with self.getBalance, and we'll find out what the new balance is after that withdrawal is complete. But if it's not a viable transaction, we once again need to catch the error or the exception that is raised. So we'll say accept balance exception as error. Now we will print, and here we will have an F string. We'll have /n for a new line, and then we'll say withdraw interrupted. And then after that, let's not put a period, let's put a colon, and we'll print out the error message as well. Now we can save this file and check it out. I'm going to go back to the OOP project file, and underneath Jim, let's create a new account for Blaze. And Blaze is going to have a savings account, and let's go ahead and pass in $1,000 when Blaze opens his account. Let me make sure I abbreviated savings account right. If I look at the class, yes, savings account. So that needs to match up. We did call the right class there. So we're creating an instance of a savings account. So it starts with $1,000 for Blaze, and then we'll say Blaze, and we'll once again check the get balance method there, which is also called when we make a deposit. And let's go ahead and make a deposit for $100, just like we did for Jim. And finally, we'll say Blaze and transfer, and we'll try to transfer $10,000 to Sarah. And let's go ahead and save the file, and we'll run the file and see what we get for output. So let's drag this over just a little bit more. There we go. Let's scroll up here where we go ahead and create the account for Blaze. Here it is. Account Blaze created, and then the balance is $1,000. Then we called the get balance method, and you can see he has $1,000. And then we deposited $100, and since he also has a savings account that inherited from the interest rewards account, just like Jim, he gets that extra 5%. So now he has $1,105. And then we begin the transfer, but it is interrupted because Blaze had $1,105 and he could not transfer $10,000 to Sarah. So we get the message that Blaze only has a balance of $1,105. So instead of transferring $10,000, let's go ahead and bump that back to $1,000. And now we can save and run this again. We'll once again have a transfer interrupted, but then we should have a successful transfer. So let's check that out. Here it was interrupted, but now here's the successful transfer. We get the beginning transfer, the withdrawal is complete, and now Blaze only has a balance of $100 because he had $1,105, but he has a savings account, so also that $5 fee applied, and it took away the $5 with the fee, and then he transferred $1,000, leaving Blaze with $100. Then the deposit is complete, and Sarah now has a nice bank account with $3,600, and we get the transfer complete message. Okay, I think you're getting the idea overall. Now we've created 3 classes here, and we've used inheritance as we've created them, and then we've also added a new property to one class, and we have used a couple of methods more than once, essentially overriding one to add some new functionality as these classes needed that new functionality. Now, these could be used in a larger banking or part of a personal finance program, for example, but this is where we're going to go ahead and stop this OOP practice project. But I hope it has helped you review everything we've learned about Python objects and classes as we move forward. I've got VS Code open and a new folder to the left for Lesson 21. We're learning about 2 related things today, Python virtual environments and also pip. PIP is an acronym for Preferred Installer Program, or some have said PIP installs packages. So let's start with PIP. So PIP lets us install packages in our programs that are not already included in Python, like the math module and other modules that we've used in previous lessons. So let's look at how to do that. Now, PIP is already included with Python, so you should have it after we've installed. Now I have a terminal window open. I pressed Control and the back tick to open that up. And from here, we could type, normally I guess you would type pip install and then the package name. One package that's popular that we can work with today is called requests. So you could do that, but if you get an error, and I would get an error if I entered this right now, or at least my antivirus doesn't like it, I need to go ahead and type my Python command, which for me on Windows is Py. It might be Python 3 for you on Mac or Linux, for example, and then -m, which just means module, and I'm launching the module pip to install requests. Now I've already got this installed, so you may see a different message than I do when I press enter, but let's go ahead and press enter. This should install this onto our computer. Now you might get a longer message if you didn't have that installed, because mine says requirement already satisfied. So just remember, if the pip, let me find it here again, pip install requests, I'll just type it out. If that doesn't work for you, remember to just go ahead and use the Python command first with the -m flag for module like I did there. So you've got py-m pip install requests. Okay, now that we have that installed, where did it install? Well, it's a global install, so it's available to all of our Python projects, and you'll want to remember that for the future, because we're going to come back to it when we discuss virtual environments. Now you can list all of the packages you've installed with pip list. So once again, I need to start with py-m, and then I'll say pip list. And this will list everything that I've got installed here, which is quite a few on my computer that are installed globally. But we'll once again come back to that with a virtual environment. But remember the command pip list when you want to see everything that you've installed with pip. Now you can also install a specific version. Notice all of the different packages have versions over here. So if I scroll up and find requests, here it is. Let's see, requests. It's at version 2.31.0. Well, maybe I want 2.30. I could go ahead and install that with pip install requests, and then I'll set that equal to 2.30.0. Press enter, and yep, my computer doesn't like it without the py-m. Let me go ahead and try that again, and I'll press the arrow up to just bring that back up, and at the beginning I'm going to add py-m and then pip install requests 2.30.0. Go ahead and do this, and it says the requirement is already filled for most of it, but then here at the end it went ahead and uninstalled 2.31, and now it says it successfully installed 2.30. So let's once again look at pip list, and we'll see what version we have now listed here in our list of all of our packages, and you can see requests is now at 2.30. So now I have an old version of the package, and maybe I need to update it, or I decide I want to update it. So I'm going to once again say pip install, and then I'm going to use the -U flag, put request back, and it's going to update my request package to whatever the current release is. So when I enter this, it should now go back to 2.31. And now, as you might expect, you can also uninstall. So let me go ahead and issue an uninstall command here with pip uninstall, and I'll say request. Now I don't really want to uninstall this, but I'm just going to show you how it works. So I'll press enter, and it says, do I want to proceed, yes or no? So at least it gives you a confirmation before it goes ahead and uninstalls. I'm just going to press N for no and press enter. Now you could do the Y to see what it's like and then reinstall if you want to as well. Okay, now you've got a good idea of what pip is all about. It helps us install packages that are not already installed by default with Python. And now that you know this, let's talk about why virtual environments exist. So it's not unusual to have more than one Python application already running on your computer. And it's also not unusual to have a situation where one Python app needs a specific version of a module, and then another Python app needs a different version of that same module. So how can you provide two versions of the same module? Well, remember we said pip installs updates globally, so that can impact every Python program. So how do we get around that? Well, we do with virtual environments. They're a solution to this issue. And you use them in development, but you don't include them in your Git repositories or send them to GitHub. So just note that you won't see any virtual environment files from this tutorial in the code repository for this lesson, because I'm not going to send those to GitHub. So we use virtual environments with a project. Let's go ahead and create a small project that will allow us to demonstrate everything we're learning today. I've already got the lesson 21 folder, so now let's bring the terminal back up with Control and backtick, and we can go ahead and create a virtual environment. I'll start with my Python command, then -m, and then venv, which is the virtual environment program that's going to help us create our virtual environment. We're going to name it .venv. Now you'll see this will create a folder inside of our project. I'll just go ahead and press enter. And notice we now have a folder over here on the left that's .venv. That's our virtual environment. But we still need to activate our virtual environment. So to do that, we'll type source, and then I need to type .venv for the folder. And then inside of this folder, let me go ahead and expand. It's got a scripts folder. And inside of there, it's got activate.bat and another activate file and so on. But we're just going to call activate. And what we need to do then is specify scripts and then activate, if I spell activate correctly. Now this will go ahead and start our virtual environment. Notice now after I press enter, we see in parentheses down here .venv. We're inside of an active virtual environment. Now I'll press enter again, and you'll notice it once again ends with that .venv inside of parentheses. That's how you know it is activated. Now, it's important to remember how to activate it, because you're going to need to do that every time you come back to work on your project. Let's say you've closed this folder out and opened another project, then you come back, you're going to want to activate your virtual environment every time you're working on the project, so you're not in the global environment. Now, it's important to know you can also deactivate it, and all you have to do for that is type deactivate. So I'll do that and press enter, and notice you don't have the parentheses and the .venv anymore. And if I press enter, it still won't be there. So now we're back in the global environment. So I can use my arrow keys and just arrow back up to the previous commands if I want to activate or deactivate right now. But right now, remember I have that big long list of packages that are in my global environment with pip. We can look at that again with pi-m then pip list. So here is a long list of the global packages I have. Now let's go ahead and activate our virtual environment. It's now activated, and now I'm not going to get an error on my computer if I just use pip instead of typing pi-m now. So now in the virtual environment, you'll see me just do pip list, and I don't have much because we just started our environment. So we just have the basics right now inside of our virtual environment. And notice it also says a new release of pip is available. 22.3.1 should go up to 23.1.2. And it tells us how we could execute this as well. So let's go ahead and do that. Now I can just use my py command here instead of python.exe. Then I'll say -m, and then I'm going to say pip install. We could use the 2 dashes and the word upgrade, or you could use the 1 dash and the capital U like I showed you, which means the same thing. And then we'll just say pip, and it should go ahead and update that for us. And now it says we're at 23.1.2, and we should be able to say pip list. Now let's go ahead and install some packages that we can use with our small project that we're going to create. So let's install requests once again, and we're going to need this in our virtual environment. We already have it in the global, but that's not going to be for this project now. We're going to just use a virtual environment for this project. So let's install that with, I'll say pi-m and then pip install requests. And now it should install that, and we can check that to see if it's on our virtual environment with pip list. And now notice it installed several other things. It didn't just install requests. So this package requests has some of its own dependencies, and we can see the details about any package if we use the show command. So I'll say pip show requests. And now we get some details here. So it says this also requires, and it lists these other packages that it requires. And notice those were installed, and we should also be able to see those listed up here in the lib and then site packages folder, and we see several things that were installed here as well. Now there's one more package I want to use today, so I'm going to say pi-m and then pip install, and it's going to be python-.env. Go ahead and install this package as well, and you could check to make sure it's installed with pip list if you want to. I'm confident that it's already there. It says it is successfully installed. I've temporarily opened up a web browser here, and we're at pi, which is pypi.org, and this is the website that has the Python package index. And this is where you can search for these packages to use inside of your application. So if you're wondering where I could find requests or learn about python-.env that we just installed, or many other packages, go ahead and search for projects here on the Python package index. Back in VS Code, now that we've installed these other packages we need, let's once again look at our pip list. So I'll say pip list, and we'll see everything that's installed here in our virtual environment. Now these are the dependencies for our project, and while I said we will not want to include our virtual environment files inside of any GitHub repository, we can go ahead and include a list of requirements, and we should create that. So let's type, I'll start once again with pi-m and then pip. Now freeze, that's a new command. So pip freeze, then do a greater than sign, and then put requirements.txt. So we're going to create a text file with the requirements in it. Let's go ahead and press enter, and we should see this show up over here in our file tree. And if I close the terminal, we can see it lists all of the dependencies here for our project. Or if you want to use another word instead of dependencies, it lists all the requirements for our project. Now, as I've said, I don't want .venv, the folder or anything inside of it, inside of our GitHub repository or my GitHub repository for the course files as well. So I'm going to create another file here called dot with a period first, git ignore. Now this works with Git and GitHub, and I'm going to list the .venv folder inside of it and save this file. So that way, when I create a repository, or when you would initialize a repository for your project using Git, if you know Git, if not, I do have tutorials about that on my YouTube channel as well. But this way, it will make sure this folder or .venv is not included in that Git repository with the rest of the source code. But we've left a requirements.txt that will tell everybody what should be installed to run the project. And speaking of our project, we haven't even created a Python file yet. So let's go ahead and do that, and we'll name it weather.py. Now we're going to create a simple program that goes on the internet and requests the weather from a service, and of course returns the current weather to us. And we're going to be able to request the weather from any city that we want to. So let's learn how to do that. In the browser, I'm at openweathermap.org. And here you need to go ahead and just sign up for a free account. I've already done so, so I have my name up here in the top right. Once you have signed up for that free account, and I believe you'll have to confirm your email probably, and there may be a slight waiting period as well, so no rush, but once you have all of that complete, come back to the video. And now I'm going to assume that is complete, and you're back to the video, and you've signed up for your own openweathermap.org free account. From here, you want to click your name in the top right and choose My API Keys. Now don't worry about seeing my API keys because I'm going to delete them after this tutorial and I can create new ones. Notice the generate button over here. So I'm just going to use one that I have. You're going to probably want to generate one, or if you have a default one you can copy. Either way, just double click one of the API keys that you either generate or that you already have and Control C to copy that. Now back in VS Code, let's create one more new file. And it's going to be named .env, which dot means once again that it starts with a period. Now inside of this file, I'm going to use all caps and say API_key equals, I'm going to say Control V or use Control V to paste in that API key. Notice there's no quotes and they're not needed inside of this file. This is our environment variable file and we use this in development. This is another file that we never want to send to GitHub because it contains our secrets and we don't want to share those in a code repository on GitHub. If you ever deploy an application on the web, your host will allow you to insert the environment variables in spaces they have provided on the host for the website, for example. So you would take this value and take it to your host. So you never include that in GitHub, but you do use it during development in a .env file, and that's what we're doing today. So let's go to our gitignore file, and besides the .venv that's listed, we also want to list .env, lowercase, make sure it matches, and save. So you will not see the .env file inside of my code repository for this lesson either. Back in the browser at openweathermap.org, let's go ahead and click on API in the very top nav bar. And once you're at API, we need to scroll down and we're going to go to the current weather data API doc. So click on API doc by current weather data. Now that we're here, we see a URL that they're providing us where we can request weather data from. And we're going to modify this just a little because we can provide a city name instead of the latitude and longitude. One other thing we're going to do is use a unit of measure. So let's go ahead and highlight this much and we'll just modify it. So Control C to copy this specific URL. Now I said we're going to use a unit of measure. So over on the right-hand side, click units of measure. Now you'll probably want to apply whatever unit of measure you're used to for the weather. I'm used to the imperial because I'm used to seeing my temperature in Fahrenheit. For temperature in Celsius, it says use metric and they use Kelvin by default. So I'm going to set the units equal to imperial. You possibly want units equal to metric depending on where you live. And now we're back in VS Code. I'm going to type a variable quickly named request_URL, set this equal to a simple string right now, and paste in that URL that we got from the openweathermap.org website. I'm also going to press Alt-Z so it wraps down and we can see everything. And now, of course, we're going to modify this. But I'm just going to start from the top. I just wanted to get that pasted in first. Oh, and let's go ahead and add that last thing, the unit as well. So we'll say and, which is an ampersand symbol there. And now we'll say units, and then we'll put it equal to imperial. And of course, I'm having some trouble typing. Make sure you do not have a typo or it may not work. So I added this final parameter on the URL, and mine is going to be units equals imperial. We will come back and fix the rest of the URL, but let's start at the top with our imports. So we're going to import requests, and after requests, let's say from .env import load_.env. That's going to help us get our environment variable value. We're also going to need to import OS, which is, of course, built right into Python. And now we need to call load.env, and that's going to load in those environment variables so we can retrieve them. And we only have the one, which is the API key, but it's still important to call this first, and that way it will be available for us. And now I'm going to create a function. So we'll say def, and then we'll call this get_current_weather. And then inside the function, we'll go ahead and start with a line that is just a print, and we'll do a new line. Let's do 3 asterisks, for example, and then say get current weather conditions, and 3 more asterisks, and another new line. That is just our welcome message when the function is called. After that, we're going to need a city value, so we can get the weather for whatever city we want, and we'll create an input there. We'll once again have a new line, and then we'll just say, please enter a city name. And after that, we could put another line break. Yeah, let's go ahead and do that. So one more line break there. We can just space things out nicely. And after we get that city name is where we're going to need this request URL. And of course, we're going to have to insert the city name into it. So now let's go ahead and fix our request URL. Everything we see before the line break is fine. So everything we have here to weather is good. And then you start the params with the question mark in a URL. And we are not going to provide latitude or longitude. However, we are going to provide some city information. So let me delete this ampersand as well, because the API key could be the first thing we apply here, and we have to pass it as the app ID. But this won't work, just saying API key in there. And likewise, this also needs to be an F string. So let's go ahead and put the F here, which will allow us to insert those values. So now I'm going to say os.get_env. Oh, and I'm sorry, there is no underscore. It's get_env without the underscore. And now we can specify that variable name, which was API key, that we have inside of our .env over here. So there is the variable name, and we have now specified it, and we use os.getEnv to get that, and we loaded those values from that file with the load_.env. But notice we haven't entered our city yet. So before units, let's go ahead and add another ampersand here. And here we just put a Q, which is an abbreviation in their API system for query, I believe. And what we want to pass in here is the city. And we'll just wrap that in curly brackets. And then we have the final ampersand. And for mine, units equal imperial. So that's the full request URL. Now let's go ahead and print the request_URL. And we'll just make sure that it's putting out what we expect it to. So this will make sure you're not missing any values if we go ahead and test it that way. So underneath this, we can call our function with getCurrentWeather, and that should go ahead and launch when we run the file. So now let's go ahead and choose Run Python File. And we have getCurrentWeatherConditions. Please enter a city name. So I'm going to say Kansas City. Press Enter. And here is what was output. So here's the full URL, and then we go ahead and get the app ID param, and it's equal to that API key. Then we have another ampersand, which means there's going to be another param, and this is the query, which is Q, equals Kansas City. And then finally we have another ampersand, units equals imperial. So this looks like what I want, although I'm a little concerned the Kansas space city, this space might create an issue. We'll see if it goes ahead and works or not when we enter a city name with a space, like New York or Kansas City or New Orleans or Los Angeles and so on. Okay, I'm going to close the terminal and let's finish out this program. We no longer need to print that request URL, so I'll comment that out. So just leave it in there for you in the source code for this lesson if you want it. Now let's set our weather_data equal to requests. Now we're using that request package that we installed, .get. We're passing in the request_URL, and then we want a JSON format of data. So JSON is a string that is sent in an object kind of format. If you're not familiar with JSON, I don't want to explain it all right now, but it's the way data is sent back and forth on the web for many, many applications. And that's how we want to receive this. So we'll see what that looks like when we go ahead and print the weather_data now when we call that function. So let's save the file once again with Control S, and now I'll run the file and let's try this out, and let's enter another city name that has a space just to see if it's going to work with that. So yes, it did work, and this is what JSON looks like, and it doesn't read too easily in the terminal like this, so maybe we want to add something else that will help us read it as well. So now let's close this. I'm going to scroll back to the top. We're going to have one more import, and that's going to be, from ppprint. So what it stands for pretty print, but it's just not saying the word pretty. So we have pprint actually, and then import pprint. And now we'll come down here and we'll use that on the weather data. So instead of just print, it's going to be pprint for pretty print. Let's save and let's run that once again. Happy to see the space inside of the name New York did not create a problem. So let's run this for Kansas City again and press enter. And now, yes, this is much easier to read than it was before. The pretty print definitely helped out. So we can see here is all of the information, and the JSON starts right here as an object, and here's all of the data. So we've got our feels like, and there is my temperature in Fahrenheit for Kansas City. Here's the current temperature, which is almost the same. Has a lot of other details as well. Here in weather, description is clear sky. So we can get all of this from this object, from the JSON, if we know how to access these values. Now let's once again close the terminal, and let's go ahead and make this a legitimate module. If we say if underscore name underscore twice once again equals 2 underscores main 2 underscores, then we will call the function. If not, we could possibly import this as a module into another file if we wanted to as well. I'm going to go ahead and comment this out, but once again, leave it in here with the pretty print, just so you know how you can easily read that JSON data if you want to. And I will, of course, leave this import here at the top, even though we're not using it with it being commented out. Let's go ahead and print out some more readable information for anyone that would use this module. So I'll say print, and now let's just give a string for each value here. So they need to be F strings, and this is going to be weather, or I should say current weather, right? Current weather for, and this is where we would insert our value. So it's always going to reference the weather data variable that we get. And now we just need to reference what's inside that JSON. Well, one of the properties was, and let me get it right here, we need a bracket first and then the name of the property. One of the properties was name. So this would say current weather for Kansas City, for example. Now I need to go ahead and put in line breaks once again. So I'm going to do a /n to start out with, so that's not right up against anything. And now we put one here at the end as well, or we could just wait to the next line. Let's wait to the next line. So now let me copy this down with Shift Alt and the down arrow. And instead of current weather, we'll just say the temp is, and temp stands for temperature. Now we need to reference the main object that was in there. And if you go back and look, and you can do that if you open the terminal back up, we're going to reference main and then the temp right here inside of main. So main has its own object that, of course, main is a property in the larger object, and then we're referencing temp inside of the next object. So after we say main here, we need another bracket, quotes, and list our temp. Now I'll copy this down, and now we want the feels like. So the temp is, and we'll say what the temp is, but then we'll say feels like, and now we're going to list feels underscore like value. And let's go ahead and extend this sentence right here. So I'll say and now let's enter in another value. So it's once again going to be weather data. And now we'll have brackets, and this is inside of an array. So we can look back at this. But first, it's actually weather, and then weather is an array. So we'll look back and determine this value. So I want the very first element in the array. So I'll save that much. Let's open the terminal once again and look back. So it's weather. Now this isn't an object like main was. This is an array, and we want the first and only element in this array, and it is an object. And then we're going to reference the description here. So we're saying weather, first element in the weather array. Then we want to reference the description property of the object. And finally, we want to capitalize that string. So I'm going to call capitalize on that at the very end. But you know, maybe I don't need capitalize because it's not starting the sentence, it's at the end. Originally, I'd thought about putting that at the beginning of the sentence. So this is just our statement. Let's put a period at the end to make it a sentence. Let's go ahead and run this and see if we get some output that is more readable for most humans. Now we'll go ahead and run this, and we've got get current weather conditions. I'm going to enter in San Diego. Press enter. And yes, current weather for San Diego. The temp is 76.32, feels like 76.98, and few clouds. And maybe I should capitalize that and put the few clouds at the beginning because it doesn't feel like it reads quite right, but it's close. It's not too bad, and maybe we want a line break at the end. So just a couple of tweaks, but overall, this is our program. I'll add those changes, and it will be in the code repository. You can add those as well. And I hope you know much more about virtual environments and pip for Python. I've got VS Code open, and I have a new folder for lesson 22 over here on the left. Notice 3 files. I've got names, more names, and context. And inside of these files, I've really just got the same thing, 4 names, 1 on each line. And you'll see why we are using those. We just need some text files to work with as we learn about working with files in Python. So let's create a new file in our file tree, and we'll call this files.py. I'd like to introduce an acronym, and it's called RAWX, R-A-W-X. And this stands for read, append, write, and create. You may have heard of the acronym CRUD before, and this is very similar, which CRUD is create, read, update, delete. But here we have read, append, which means the same thing as update, write, and create. We will also learn how to delete files as we go, but first we'll cover these 4 operations. So the first one, R, is read, and we'll start with that. Now, if a file doesn't exist and we attempt to open it, we will get an error. So I'll put error if it doesn't exist, just as a note here inside of our code for you. Now let's go ahead and open one of these files we have in our file tree, and we'll just abbreviate the file with the letter F. You see this fairly common. You could write the word file if you want to. Either way, it's going to hold the file and we can work with it. So we'll say open, and then inside of parentheses, I'll just say names, an S if I spell it correctly, .text, and this will open the file. But this has some defaults that we are not seeing, and these are essentially what these are, what we want to do with the file. So if I put a comma here and then put an R for read, that's the same thing. It's still going to read the text file. And if you really get into working with files, you can even specify if it is, for example, a text file with a T or a binary file with a B. We'll just be working with text files, and that's probably what you'll do the most often. So that's what I'll focus on today. And we don't really have to specify that. It's going to just have a default value for the files as T for text. It also defaults to read if we don't specify that. So really, we don't have to put the comma and the R there, and then it knows we just want to open this file in order to read it. So now that we've opened the file, let's go ahead and print the contents. So I'm going to say print, and I'll just say f.read and call that method on the file. And now let's go ahead and run our code. So I will choose run Python file, and we get the contents of the file. It just says Dave, Jane, Eddie, and Jimmy. And of course, all the files have that same content. I'd like to move this over to the right as we have in the past. So let's go to View and then Appearance. Then we come down to Panel Position and choose the right side. And now we'll see our code run over here. I'll still keep this open when I can, or maybe toggle it with Control B. You can close it and reopen that file tree if we want to see what files we have over here. Now we should note we don't have to read the entire file, so I'm going to copy this down so you can see both examples. And now let's say I just want to read the first 4 characters of the file. So I'm going to pass in the number 4 to the read method. I'll run this once again, and we should see just the first 4 characters, but we see everything, and that's because we already read the file. So now we're at the end of the file, so you understand kind of how that works. So let me comment this out. Now let's once again do the F, which is file.read, and just get the first 4 characters, which should just be my name, Dave. I'll run the file once again, and now we only have Dave as the output. Okay, I'm going to comment out that line as well, and let's look at another example where we maybe want to read the entire line. We don't know that there's only 4 letters on the first line or 6 letters on the third line, and we just want to read the first line of the file. So I'm going to once again use print so you can see what it does. But instead of read, I'm going to use read line, and this is going to read the first line of the file. So save and run the code, and we once again get Dave. But if I stack this now with Shift Alt and the down arrow, I recreated that line. Do you think we'll get Dave twice? Will it read the first line twice, or maybe it will go to the second line? Let's save the file with Control S, run the code, and find out. It went to the second line, and notice there's a space between now, which is different than when we were reading the entire file. So that is also worth noting, that you can read one line, then move to the next. So notice when you're reading a file, just like I showed before where I had to comment this out up here, when you're reading a file, it moves through the file. You'll eventually get to the end of the file. So now I'll comment both of these out as well, so I can highlight these and do Control and the slash, and that will comment them both out. Now what I want to do is loop through each line of the file and print those lines. So that looks a little different. Let's say 4x, and this would just be we could say 4 lines. So let's just say that 4 line in F, which is our file. Then we're going to go ahead and print the line. Now, this should loop through and print each line. Let's find out when we Control S to save and run our code once again. And yes, it did. It was just like doing f.readLine, and of course we printed each one here. So very similar, but this is a little more concise and fairly easy to use. Now, after we opened a file like this, where we have F as an open file, we should always close it when we're finished. And to do that, we just say f.close. And now we won't see a difference here, but it is important to close those files because it could be that you change something in the file, but that change is not going to show up really until you close the file, and then you wanted to reopen it, then you could see that change. So let's go ahead and run this code again, and you'll see the same output, but now we've closed the file, and that's important. Every time we've opened a file, then we do something with it, then we should close that file. Now notice the file names we have over here on the left. We have names, more names, and context. So I'm going to try to open a file that we do not have. So I'll press Control B now so we can have just a little more room here. But I want to show what you should do to avoid an error. And we've already learned this. We should use a try block. And then inside this block, we could say F equals and open. Now this could be the name of any file that doesn't exist. So I'll just say name list.txt. And then after that, I'm going to say print f.read. So I want to print the contents, but I am making a mistake because this file doesn't exist. So it might cause an error, or it will cause an error actually because it doesn't exist. So let's also print and say the file you want to read doesn't exist. Nice little bit of a long message, but a nice message to explain what's going on. And then we can use our finally block, and this comes in handy because this allows us to go ahead and close the file, because remember we opened it before, or we tried to open it before we had an error. So if we don't open it at all, we'll of course have the error. But say the file did exist, this would allow us to open it, do something with it, and in the finally block, we could call close. So it's a nice structure for that operation. Let's go ahead and save. Now let's run the code. And we get the file you want to read doesn't exist. So what if it did exist? If we had our names.txt. Now let's save and run this again. And now we printed the contents of that file, rather than getting our error message, the file you want to read doesn't exist. We are now ready to move on to appending to files. That means adding to files. So I'll just paste this in. It says append. It creates the file if it doesn't exist. So that's important to know also. Say we try to open a file that doesn't exist, but we're opening it to append to it. Well, it's going to create the file anyway. So here I'm just going to say F equals now open, and I'm going to open my names.txt file once again. Now I'm going to say this is to append. So we need to pass in what we're doing with this file. By default, remember, it's read. So we didn't need to put in the comma and then the R in quotes, but here we need the A for append. Now I'm going to say f.write, and I'm going to write something new to the file. I'll add a fifth name, and that name is Neil, and f.write f.close. So now I've added to the file, but we are not really seeing what's in that file yet. So let's go ahead and now read the file as well. So I'm going to copy all of this down. I'll highlight everything, do Shift Alt and the down arrow. I'll create one line here in between. Now I'm going to open this to read so I can get rid of the A. And now instead of the f.write, I want f.read, and I'm not going to try to pass anything into the read. I'm going to want to print what we're reading, so I see the new contents. Then we're going to close the file. So we're appending to the file here by adding a fifth name. Then we're going to go ahead and open the file and read it, and then once again close it. So now let's run the code. I'll scroll so we're way down here at the bottom to our prompt. Run the code. And so we had our 4 names, then we appended to the file. When we opened it back up and read it again, we had our 5 names. And now we can even go to our names file and we can see Neil has been added on the 5th line of our file. Okay, now you've already seen the write method here as I used it to write the name Neil to the end of the file on that 5th line. However, you haven't seen how we open a file for writing. So let's do that now with write. And really, I'm going to put in parentheses here overwrite, because we will overwrite whatever is in the file that we open. So I'm going to say f equals open. Now I'm going to open my context.txt file, and I'm going to pass in the W that stands for write. Now when we do this, we'll go ahead and write something else to the file, but just to confirm, let's look at that context.txt file. You can see that it has the 4 names in here that we started each file with. So this is in our context.txt. Now let me go back to files. Now let's write something else to that file as well. So after this, I'm going to say f.write, which is not the same as opening a file for writing, because remember, we were able to open a file to append to it, and we still used the write method. So now we're going to use the write method as we opened a file to write to it, and this will overwrite everything in the file. I'm going to write, I deleted all of the context. And yeah, let's just leave it at that. That's a fairly simple statement. So that's what will now be in the file instead of those 4 names. So now I'll say f.close, and we've closed the file. Now once again, we're going to want to read this file to confirm that what we actually put in it is there. So I'll copy what we had above, and now I'll paste this in, and we're going to change this to read the context.txt file and then print what it finds inside the file. So now let's run our code again, and we have I should have said deleted. I deleted all of the context. So that's what was in the file. Let me change that to deleted, or that's going to bother me. Let's look at the context file itself, and yes, it says I delete all of the context. So I'll have to run that again. Notice what also happened when we ran the code again. We added Neil one more time to our names.txt file. So now it has Dave, Jane, Eddie, Jimmy, Neil. So every time we run this code right now, we're going to add another Neil to our names.txt. And it might also be important to note that it didn't put that on another new line because we didn't put in a line break. So if we wanted Neil to go to a new line, we would also want to put in a new line character with our /n as we added that name to the end of the file. And now let's look at a couple of ways we can create a new file. So I'll put a comment here and say 2 ways to create a new file. And each way has its own plus or minus, depending on how you look at it. It kind of just depends what you need. So here, I'm going to say this opens a file for writing. So you know we're going to use the W, that permission. And then we're going to say this also creates the file if it does not exist. And I'm going to press Alt-Z so that wraps down to the next line, just so we can see that. And now I'll say f equals open, and I'm going to name a file that doesn't exist. I'm going to say name_list.txt, and we're going to pass in the write permission. So this is going to open a file for writing, but if we specify a file that doesn't exist, it's going to go ahead and create the file. So after we do that, I'll just put f.close. We're not really going to add anything to the file, but let's see what happens when we run the code. We updated our statement here, but let's check the file tree to see if we have this new file. And if we look over here, we now have a name_list.txt file. We didn't write anything to the file, but we opened it for writing, and we specified the file even when it didn't exist, so it was created. Now, the second way to create a new file could also cause an error. So I'm going to hide the file tree so we have a little more room. And let me put a note with this. I'll say creates the specified file, but returns an error if the file exists. So if we're trying to create a file that already exists, this will return an error. So we kind of need to check before we try to create the file. So to do that, we need to import OS, and we're going to use that when we delete a file as well. So let's import OS here at the top of our file. Now let's scroll back down where we were, and on line 54, I'm going to say if not os.path.exists. Now I can check to see if a file exists or not. So I'm going to say if a file named dave.txt does not exist, and that's what it means when we say if not, and then we're checking this. So if the file dave.txt does not exist, then I'm going to say f equals open, and we'll pass in dave.txt, and then we'll open it with x, which remember means create. Then I'm just going to say f close. Now this should create a file named dave.txt. So let's look at the file tree as well, so we'll be able to see it show up over here. And we've saved the code. Let's go ahead and run that code. And now we have a file named dave.txt. We didn't put anything in the file, but we did create it. Now we could change this out as well. So if you wanted to put in a file name like context.txt, then it would say if it doesn't exist, create it. You shouldn't get an error because it already exists, so it shouldn't try to create it. Now I'm going to hide the file tree, and let's use some similar logic here as we delete this file, or we delete a couple of files that we don't need. So I'm going to put delete a file here. Now here I'm going to say we can avoid an error if it doesn't exist. And to do so, this looks very similar. We'll just say if os.path.exists. So notice now we're not saying if not, we're saying if it does exist. Now, what did we already create over here? We've got a file with my name, dave.txt, and we've also got a names or name_list.txt. If I remember right, yes, that didn't have anything in it either. So we could delete one or both of those if we want to here, for example. So I'm going to say if dave.txt exists, then we're going to do something. So now we'll just go ahead and say os.remove, and then we'll pass in the name of the file, dave.txt, and we'll remove that file. But we should put an else. So we can put else, and then we can say print, and then here we'll say the file you wish to delete does not exist. So that would say, okay, if the dave.txt file does not exist, then we're going to get this message. So let's go ahead and run this code, and we'll see what happens. And we've got I deleted all of the content here at the end, so it must have deleted the dave.txt file. We can verify that by looking at our file tree, and that file is indeed gone. Now you could do the same thing and put in the name_list.txt and delete that as well if you want to, because we're not really using that file either. Okay, we have covered the operations I wanted to show you, but there is one more thing. Let's scroll back up to the top quickly and just recap here. We've looked at reading files, appending files, writing to files, creating files, and of course, we also applied some checks like our try except finally. But I want to show you a way that people work with files, and they don't use the try except finally. Instead, they have some implicit exception handling, and it makes this a little more concise yet. So let's look at the with keyword, and I'll do this here at the bottom. So I'm just going to say with open, and now let's open our more_names.txt file. and we'll say as F. So once again, F represents the file, but this is just phrased differently. It says with open as F. Now that we've done that, we can just say the content here equals f.read. And that's not new. Before we were just printing f.read, and now we're just storing it inside of our content variable. Now after that, let's go ahead and say with open, and we can have another file. Let's look at what's inside of our files first. So names has all of these names. Notice we've written Neil a couple of times now on new lines because we had the new line character. Before we put in that new line character, we had 3 Neils on one line. But when this started out, it looked like our more names file with just these 4 names. So maybe we want to put our names file back to that. We can read the content out of more names and then write it to names so we get it to look just like more names, essentially copying the file. So to do that, let's go ahead and now say with, I'll hide the file tree again so we have some room here. I'll say with open names.txt, and this is also going to be as F. And now inside of this with, we'll say f.write, and we're going to write that content that we stored. So let's go ahead and do this, and then we'll look at those files again. So I'll run the code, and I got an error because I wasn't thinking. I was too quick, and what happened was this defaults to open because it's a read. We didn't specify. Here, we need to go ahead and say we're going to open this for writing. So we're going to overwrite what's in the file. So we needed to pass in that W out of our rocks acronym. So that W stands for opening the file as writing. So now we should be able to avoid this error. I'll save and run this again. And yes, I think we've succeeded, but we're first going to have to check because we did all these other things to the file first. But now let's see if the file has all of this in it or if it just looks like our more names file. So if we come back, more names just has these 4. Then we read this, took that content, and we wrote to names, which now only has the 4 names once again, instead of all the extra Neils that we had previously added to this file. So I hope today's lesson has really helped you learn many different ways to work with files that will be useful for you in the future. And remember, the RAWX acronym, RAWX, for read, append, write, and create. I've got VS Code open. You can see I have a new folder for Lesson 23, the final lesson of this Python series and course. So it's the final project, and there's so much you can do with Python, and there's always something new to learn. But I feel like this course has provided you with all of the fundamentals you'll need to keep moving forward in your programming journey. So with today's project, we're going to build this Python web app with a popular Python web framework called Flask. A couple of lessons back, we learned about virtual environments, and in that lesson, we retrieved current weather conditions for cities, but we needed to use the terminal window. Today, our web app will do the same. It will retrieve weather conditions for cities, but we'll deploy it to the web so you can share your project with everyone. Let's go back to VS Code and get started. In VS Code, let's open a terminal window with Control and the backtick, and we want to create our virtual environment as we've learned about before. We want to do this right away. So I'll type Py. If you're in a Mac or a Linux environment, you might have to type Python 3, I believe. But then we'll have -m for module, then venv, and then .venv, and I'll press enter. It should create a folder over here in your folder for lesson 23 or whatever you called it, and now we have a virtual environment. So let's go ahead and activate that environment as well. So I'm going to type source, then .venv, and then scripts with a capital S. Now that's because I'm on Windows, and I'd mentioned this during the lesson on creating a virtual environment, but I don't think I mentioned that if you're on Linux and possibly Mac, I think instead of scripts, this might need to say bin, as in bin. So here we'll say activate and press enter. This should activate the virtual environment. Now I can press enter one more time and I should see, yes, it says .venv in parentheses underneath underneath after I pressed enter, so I do know it is active. And we've also learned about pip, and we need to install a few packages we're going to use today. So I'm going to type pip install, and then after that I'm going to type requests, and then python-.env, because I'm going to need that as well, and then also Flask with a capital F. Okay, that quickly updated. It's also giving us a message about pip, so if we want to run that, we can. So I'll type py-m, then pip install dash capital U is the same as 2 dashes and upgrade, and then pip once again. Press enter, and it should go ahead and update that installation as well. And now we're going to deploy our project today. So in order to do that, we also need to create a requirements.txt file. So to do that, I'm going to type pip freeze, and then the greater than sign, then requirements.txt, and it should quickly create a requirements file that we see over here in the tree, and this should list the packages. So when we deploy this, of course, remember, we won't send our virtual environment folder to GitHub, but we will send our other code, including this requirements. So when this is deployed and it gets to our host, then the host will see what needs to be installed as we deploy our Python project. And so now I mentioned we will not send .venv to GitHub, so I'm going to create a git ignore file, which starts with a dot as well, then git ignore, and then inside of this file, I'm going to list the .venv, so that is not added to a repository when we create one. And if you're not familiar with Git and GitHub, I do have a tutorial on my channel for that as well that you can check out. Now, one other file we're going to create is a .env file, and that's where we hold environment variables. And you never want to share those. Those are your secrets that are linked to your account, and we're going to have an account at the Open Weather Map API. So I want to type .env in here as well, and this will be a file we create that will hold our Open Weather Map API key. Now, we never want to share that with anyone. So here, I'm just going to create this file and say .env. And now it's listed over here. Now, I don't know if you have Git installed or not. Git was not a prerequisite to take this course. So if you're not familiar with Git and GitHub, you may not want to deploy this project today. You may want to go back and learn about Git and GitHub and then come back and deploy this later. Now, I already have Git installed, so I'm going to go ahead and initialize a Git repository, and then you'll see these files that we've included in the git ignore turn gray because they will not be sent to GitHub in the future like our other files will. So I'm going to once again open the terminal and then just type git init, and that will initialize my Git repository here inside of this folder for our project. And you can see these are green, meaning that they are new files in our repository. Now, this tutorial is not about Git specifically, so I don't want to get any deeper into that right now. We want to go ahead and create this project. But right now, we need to go ahead and get an Open Weather Map API key if you don't already have one from the previous tutorials. I'm in Chrome at openweathermap.org. Now, if you completed this just a couple of tutorials back when we got our API key, you can skip this part. But if you haven't, you're going to need an API key. Notice I'm already signed in up here and I've got my name, Dave. Now, you can get a free account and then sign in here if you don't have one. But there's a drop menu. Now it says My API Keys. I'm going to delete any API key that I show you because you never want to share those. But I'm going to click My API Keys. And you see I have one here called My New Weather Key, and here's the key. So once you generate one of your own, if you don't already have one in your account, go ahead and copy it right here. I'm just double clicking and then doing Control-C to copy. We're going to put this in our .env file back in Visual Studio Code. Back in VS Code, I'm in my .env file. I'm going to type API_key with all caps and then equals, and then Control-V to just paste in that API key. Notice no quotes around this, but it will be considered a string. Now we'll refer to this later, and I can go ahead and close all of these files out. Now we need to create a couple of specially named folders over here in our file tree. So let's click the new folder icon. Let's name this first folder static. Oh, and I need lowercase now. So there we go, static. The next folder we need to create should be called templates. And so I've got templates, I'll press enter, and we have the two folders. Now first, static, this holds any static file. That means non-changing. So it can be CSS, JavaScript, images, any type of file like that. So to organize those files inside of static, I usually create more folders. So I'll create one inside of this called CSS because I'm going to create a CSS file inside of the static folder. So I've got static CSS, and then we'll eventually create a file in there as well. But now templates is where we're going to store our HTML files. And with that, we're going to insert some values from Python into those HTML files and use those as templates for our web page. So let's start by creating our CSS file. So I'll click on the CSS folder. Now I want a new file. I'm going to name this style.css. Now this is not a CSS course. I do have a CSS course on my channel, and it's also been published on freeCodeCamp, so you can check that out. I'm going to just paste in some very simple CSS styles. You can see I have a very simple CSS reset here if you're familiar with CSS. If you're not, of course, you can copy this CSS code from my repository for this lesson if you want to. I've got several styles applied to the body of the HTML page, and then I've got a few styles applied specifically to the input and the button as well. Now if you see a white dot, that means you need to save the file, so I'm going to Control S just to save that file. Now let's click on the templates folder. I'm going to create a new file inside named index.html. So this will be the home page that everyone sees when they load our web app. Now, if you're using VS Code to create an HTML page, you can use a shortcut here that's called emit, and emit has several commands. I'm just going to type a exclamation mark, which is an emit abbreviation. And with this abbreviation, or shortcut if you will, I can press tab, and I quickly get the outline, or the skeleton, if you want to say that, for a web page. So here's Alt-Z to just wrap that down so we can see the full line without going off of the screen. Now I'm just going to fill in some information here. So for the title, I'm going to say Get Weather Conditions. And now besides that, we're going to put a link to our style sheet. And this is a little different even if you have written some HTML and CSS before. So this is specific to how we're going to work with Flask today and how it inserts some values. So here I'm going to say link, now I'm going to have my href, and now inside of these quotes, I'm going to use two curly braces, and I'm going to say URL underscore for, not form, but for, and then parentheses, then single quotes, the word static, and after that, I'm going to have file name equals, and then I'm going to have another set of single quotes, styles slash style.css. So it is pulling in our CSS, but this is just a little bit different than you may have written before. Now, after these two curly braces here, we need another space, and we're going to type rel, which is an attribute of the link element, and then we'll put equals, and here we just have another set of double quotes, and well, we didn't finish the other double quote. I guess I needed to end that double quote here. Sorry about that. So let's delete that extra one it added. So we've got a quote here with href, and the href ends after the two curly braces, so you want to quote there. Now we'll have our second set of double quotes, and inside of this rel, we're going to say style sheet because that's what we're linking to. And finally, at the end, we can have a slash and close out our link tag here. So that is the full link. Now, this is a little unusual compared to just linking to our styles slash style.css, but this is what Flask is going to use to insert a value here because this is a template. We will be inserting values into this file when it is called. Okay, now inside of the body of our HTML, we want to have an H1, and I'm going to say the same thing, get weather conditions. So you can just copy this from the title, Control C, click here, Control V to paste it in. Underneath that, we're going to have a simple form. So we'll have our form, and then it's going to have an action attribute right away. So inside of this, we're going to go to the /weather page when we post our data from our form. So inside of the form now, we need an input, and this input is going to be type text. That's correct. We can also give it a name equal to city, And then after that, let's give it an ID equal to city. And I need that to go inside the quotes. There we go. Then let's give it a placeholder like we saw in the example that says enter a city. And then of course we need to close out our input tag with the slash there. After that, we need a button. So we'll have our button and it is the submit type. So VS Code wants to help. And now we have button type submit. And let's just put the word submit on the button as well. Control S to save, and we're finished with our index.html template for our app. Now we will come back and create one more HTML template very soon. But right now, we need to create a Python weather module that will retrieve the weather for any city using that Open Weather Map API. And this part's going to be very similar to what we did when we retrieved that weather and we just looked at it in the terminal window. So now over in our file tree, let's create a new file and let's call it weather.py. Let's import everything we're going to use at the top. So I'm going to say from.env, and then I'm going to import load_.env. Also going to use pretty print, so from eprint, I'm going to import eprint, and then I need to import the requests dependency that we added, and I also need to import OS. So the very first thing we want to do is load that API key value from our .env file, and that's what load.env does. So I'll just say load_.env, put the parentheses on there to call that function. Now let's go ahead and define our get current weather function. So we start with the def keyword, and I'll say get_current_weather, and now it's going to receive a parameter, and I'm going to say city, but I want to give this a default value too. Say it's just pressed enter and the form is empty. So by default, I'm going to give it my area, which is the Kansas City area. You could provide your city or your nearest large city is what I would recommend if you want to put a default value here that's different than mine. Just to avoid a typo, as I've been having lately, I'm going to paste in this URL, but let's go over the URL so you can get it accurately as well. So here we've got request_URL. Notice it's an F string. Then it goes to http://api.openweathermap.org/data/2.5/weather. And then we have a question mark, and this is where the params in the URL begin. You need to put app ID equals, then we use the OS module that we imported, and we'll say os.getEnv, and then parentheses API key. So we're getting that environment variable right here using os.getEnv. And then we have an ampersand and then a Q, which is short for query. And then that equals the city value that was passed in, or Kansas City in my case if a value is not passed in. One more ampersand, and I set the units to imperial. Now you can look at the docs for the Open Weather Map API, because if you don't want imperial, if you want something else instead of degrees essentially for the weather, you can change this to metric, I believe. Okay, now let's go ahead and get that weather data. So we'll say weather_data equals requests.get, and we pass in our request_URL. And at the very end, we need to add .json and put parentheses to call that because we want JSON data. And then we're going to return the weather_data. So this gets the data from the Open Weather Map API. And now I said we're making a module. So to do that, let's complete this by saying if _name, and then two equal signs equals main with also the two underscores, which we've covered in this course. So if this file is called directly weather.py instead of calling the file that might call the entire application for the web, then we're going to go ahead and run this file as if it's at the terminal once again. So I'm going to print, and then inside of the print statement, I'm going to start with a new line, and then I'll just say, let's do 3 asterisks here and get current weather conditions, 3 more asterisks, 1 more new line. So that's just kind of a welcome to the app at the terminal window. Then we'll say city equals input, And here we'll have a new line, and please enter a city name and a colon. And after that, let's go ahead and come down and get our weather data. So weather data is going to equal get current weather data, and we're going to pass in whatever city was provided. And again, if they don't pass in a city, it should go back to our default value here of Kansas City. After that, at the very end, I just want to print, say, one new line, and then we'll go ahead and pretty print. Oops, don't want to do that. Having a hard time typing today. At the end, let's go ahead and pretty print our weather underscore data. So this is if this file is called directly, which is kind of the right thing to do for a module. This would go ahead and provide the weather data at the terminal, just like we learned how to do a couple of lessons back. But today we're going to use this get current weather function in our web app so we can get that weather data and present it on the web with a template. And now that we have our weather function, we're finally ready to start working with Flask directly. And so let's go ahead and create another new file over here, which will be the main file for the application. Sometimes people name that main.py. I'm going to name this server.py because it will be a Flask instance that is running our server essentially. So that is also common. You could name it either one you want, but just remember what you do name it. So I'm going to refer to it as server.py like I used. Now inside of this, we're going to create a route with hello world just to test it out first. So I'm going to start with from Flask import Flask with a capital F. Then I'm also going to import render underscore template and request. Now that is different than requests that we've imported in the other file. I also need from weather import get current weather, and we'll use that in just a moment. Now let's go ahead and define our app. So we say app equals Flask, and then inside of the parentheses we do 2 underscores name 2 underscores, and that makes our app a Flask app. Now we define routes in Flask, and those are routes that we would access on the web. So I'm going to say at app.route, and now I just want slash. This would be the home page. But then also commonly you should be able to access the home page if you go to /index or /index.html, for example. So I also want to add app.route, and then inside of this I want /index. So both of these will apply. Now following these routes, we define a function that will return something for the route. So I'll say def index parentheses, and now we'll go ahead and return something at this route. So I'm going to return. Here I'm just going to say hello world to start out with. Just a simple example, but of course we're not ready to run our file yet until we add our if name equals main, 2 more underscores. And now in this if name equals main, I'm going to start with app.run, and here I'm going to say the host is equal to, now inside of quotes I'm just going to put 0.0.0.0, 4 zeros with dots in between. That's going to make it run on our local host. And then I'm going to say port is, I'll give it 8000. So we're going to go to localhost port 8000 to see the app after we start it. So we have a basic route here for our index or our home page, if you will, and we'll return hello world, and it's going to go ahead and start the server with this simple command. So let's run this file now. And here we see running on all addresses. So it should be running as expected. Now notice we get a warning here as well. This is a development server. Don't use it in a production deployment. So we'll want to fix that in the future as well. Let's go ahead and look at our web app right now that should say hello world, and we'll need to do that in the browser. I'm in Chrome and I have a new tab open. I'm going to type localhost, and then I'm going to want 8000 after it. So localhost colon 8000. I'll press enter, and right now we have our hello world as expected. Back in VS Code, I'm going to press Control C to quit the server for now. And then I'll close out the terminal window. And let's go ahead and adjust that. Remember that warning we saw that said, hey, this is a development server. We don't want that. We need to go ahead and replace that because we are going to deploy this app, essentially put it in production. So to fix this, let's open the terminal once again. And here I'm going to type pip install Waitress. And now Waitress is a package that is going to help serve our web app in production. So now that I've installed that, I've got a new dependency, and that means I need to recreate the requirements file. So once again, pip freeze greater than symbol requirements.txt, press enter. It should now have added Waitress to our requirements file. Let's check, and yes, there it is on line 14. And now that we have Waitress added, let's go ahead and add it to our Flask app as well. So I'll say from Waitress, and I'm going to import serve, and serve is what we need to serve our application. So let's replace this app.run here with serve, not server, just serve. And inside of this, we need to start with app, comma, and then we can still say host with the 4 zeros. We can still say port 8000. All of that is fine. We're now ready to add that second HTML page I talked about. So click on index.html, click somewhere in the file, press Control-A, which should select everything, Control-C to copy everything, then you can click away if you want to. Now let's create a new file here. With this new file, type weather.html, and inside of our weather.html, we'll get a jump start just by pressing Control-V and pasting in everything we had inside of the index at first, and then I'm going to press Alt-Z to wrap any of those lines down as well. Much of this will stay the same, but we're going to make a few changes. So we need the same CSS link, that's no problem. We do want to change the title of the page. So let's go ahead and select that, and then I'm going to press Control-D, and I'm selecting the second instance here of get weather conditions because we're going to change both of these to say the same thing. I'll press backspace, and it deletes both of those, and I'll press 2 curly braces, then the word title, 2 more curly braces, and then the word weather. So whatever city is entered into that previous form, when we fill this page out, it could say Kansas City weather or Paris weather or wherever, but it's going to fill that in as we use this template. Now we still want the same form underneath because we want users to go ahead and be able to request more data or more cities weather if they choose to after they request the first one. But let's create some space here between the H1 and the form so we can put in some more information. Now I want a paragraph, and in this paragraph I'm going to use 2 curly braces once again, type the word status, 2 more curly braces, then and 2 more curly braces, type the word temp, 2 more curly braces. Now I'm using degrees again, so I'm going to use the abbreviation in HTML entity for degrees. If you wanted this changed to a different system, a different symbol, you can look that up on your own, but I'm going to use ampersand DEG semicolon, which will give the degree symbol. Now I'm going to just click on this line, press Shift Alt and the down arrow, and it copies all of that down. So now I'm going to say feels like, and after that I can delete status and, but I'll leave temp. I'm going to replace the word temp with feels underscore like. So these are the values that we are filling in when we get that weather information. But currently we're not handling the weather route, and when we make a request for weather, be it on the index.html page, we look for the weather route, or even on the weather page itself, we submit this form to the weather route, and then that data comes in and fills it out. So let's go to our server.py and handle a route for weather. So we need to go ahead and create that function and route underneath where we have the route for index. So I'm going to say app.route, and here I'm going to pass in /weather. Now, beyond that, let's go ahead and define our function. I'm going to call this get weather. Remember, our other function was get current weather, so I'll just call this get weather. Underneath this, we're going to get the city value first. Now, that city value is going to come in from that form data. So here we can say request .args.get, and then we want to get the city value. So now we should have retrieved that, and we'll have weather underscore data going to equal get current weather, and we'll pass in the city value. So now that we have the weather, we want to send that data to that template. So here we're going to say return, and then we'll say render underscore template. And now inside of these parentheses, the first value we want is the template itself, which is weather.html. Now we need to pass all of the other values that we're going to use. Let me scroll up just a little so we have some room, and I'll say title equals weather underscore data. Then we want to use brackets and say name. After that, this would be the city name, of course, as well. After that, we want status equals, once again, we're going to have weather underscore data, brackets, and now we need to get some specific information that's in that JSON. And if you remember back to the lesson a couple of times before, we had a fairly large JSON object to navigate to get this data. So here we start looking at weather, and then we get the first element in weather, and so we use a 0 to get that. And then after that, we still need to get the description. And then after the description, I want to capitalize. So I'm going to pass capitalize here and call that as well. So that's going to be the status, such as cloudy or whatever the status is. I believe cloudy or few clouds was what we just had for Kansas City. Now let's go to temp. We'll set that equal to, and now this is an F string. So we start with F and quotes. Now curly braces, and we'll say weather underscore data once again, brackets. Now we already have double quotes on the outside, so we need to use single quotes, and we'll have main, and then we have temp. Once again, you need to refer to the JSON object to know how to get this data out of the object. And I'm not breaking all of that down here for you because I did it 2 lessons ago. We've got main temp, and I want to format this to that .1 afterwards, whatever it was, .7, 0.8. So I had like 97.3 degrees, for example. So I just want the 1 digit. So here I had colon, then a period, then 1, and F. So that's how I'm formatting that F string instead of a 2, which you've seen that format here before when we used the bank accounts, I believe. Okay, after that, another comma, and then finally we need the feels like value. So feels underscore like, set this equal to another F string. So we have our double quotes, our curly brace inside of here, weather data, and then we'll once again have the single quotes around main. And then we'll have another bracket, single quotes around feels underscore like. And finally, we're going to format this the same. So colon dot 1F. There's all of our information passed in. So you get how we're getting that out of that JSON object that is returned from our get current weather function. And after we do that, we're passing all of these in that we're using in the template. So the words we're defining here to the left are what's used inside of our weather template. So when we go back and look at weather, we just have to say title, status, temp, and feels like, and we can use those inside of our template. Okay, back in the server.py, one thing we didn't do is ever change our hello world, and we want to do this, but this will be fairly simple. All we need to do here is say render underscore template as well, and just pass in the index.html. Because it's not receiving any of these like the weather page is. Now, if any of this went too fast, feel free to go back to the previous lessons. Also, of course, my code is available at the link in the description. And let's go ahead and run this code and make sure everything's working now as we expect it to. And I'm going to choose Run Python File. And now we're going to have to go back to the browser and look at the app. I'm back in the browser. I need to refresh our local host at port 8000. And now we have our get weather conditions. But what I notice is the CSS is not being applied. I may have a typo. Let's go ahead and check out the functionality first, though. So here I'm going to type in New York and press enter. And yes, we've got the New York weather, haze and 88.1 degrees. It feels like 93.2 degrees. This is all good. What's not good is we're missing the CSS being applied to the pages. Okay, back in VS Code, I've made a very simple mistake, easy to make. I am looking in the file name, or in the folder name, styles/style.css inside of both the HTML files. But when I look at the file tree, I actually named my subfolder here inside of static CSS because I had CSS on my mind and not the word styles. So let's go ahead and change the name of this folder. Should be able to right click and choose rename, which also it looks like F2 would have done that. And I'm going to switch this folder to styles. So I'm looking at static styles and then the file style.css. That will match what we put inside of both of our HTML files. So we save that. We should come back and go ahead. I stopped my server. If you haven't stopped it, you might not need to. I'm going to go ahead and restart this. And let's go ahead and reload the home page. So now the CSS applies like we expect it to. Let's go ahead and type in a city name. I'll put in Omaha and press enter. And yes, the weather app is working like we expect it to as well. However, this is the core usage. What if we entered something that would be unexpected? Say we just pressed the submit button without entering a city, or maybe we entered some spaces into the input and we submit. I think we'll probably get an error. Well, that's a surprise. Several spaces brought back a name from the API that I did not expect. Let's go ahead and hit submit without entering any spaces and see what we get. Now we have the internal server error that I expected. So let's go make a few changes to handle these edge cases in our code. We're back in VS Code and we need to go to the weather module to start out. And let's work with the module when it is called at the terminal line first, because this will be easier to debug and check as we go. What we need to do is get the input from the user and make sure that it is not an empty string, meaning a string that actually has no characters, but still the two quotes, or a string that is full of spaces only. So it would still be empty because then we could strip away those spaces and we would once again have an empty string. So to do that, we can put in a line of code here, and I'm going to put a note and just say check for empty strings or string with only spaces. So we know exactly what this line of code is doing. So I'll say if not, and then I'll use bool. And if you remember Boolean, that's true or false. Well, we're going to say we want content here, so it won't be empty. So we're looking at city. But before we look at the city, let's also strip away spaces. So I'm using the strip method here. So this strips away all those empty spaces because it would normally take away white space at the beginning and the end of a string. But what if there wasn't anything in between? So it's just going to strip away all of those spaces. And then we're going to make sure we have something left. So we can say if not bool, but first we're stripping away the spaces. And then we'll go ahead and put our colon for the if statement. Then we'll just say city equals, and let's give it a default value like Kansas City. And if you remember, we put in a default value for our function, and I put in Kansas City. However, that doesn't mean an empty string couldn't be passed to our function. And in that case, the default value wouldn't kick in. So this line of code is going to check for that. So now let's just run this module and see if it works when we do not enter anything or when I enter several spaces. So now we'll run the code. This is the error that we got in the web app. This is not the code that we're running. So I need to press Control-C a couple of times, and now it's running at the terminal. So it says, get current weather conditions. Please enter a name. I'm going to drag this up just a little bit. I'm not going to enter a name at all. I'm just going to press Enter. And now it returned the weather for Kansas City because that's the default value I gave in the code if we stripped away everything and the city name didn't exist. So as we look back here, city equals Kansas City. Let's do this one more time, and now let's do it with several spaces. So I will go ahead and run this code once again. I just pressed the up arrow to pull that line up and then press enter, and that's what ran the code here. Now please enter a city name. I'm going to enter in several spaces. Let's see what we get back. Do we get something from the API that is not Kansas City? No, we get Kansas City. So once again, we stripped away all of those spaces, and then there was nothing left. And so then it defaulted to Kansas City. Feel free to put in your own city name here. But now that we have debugged this or worked around some edge cases inside of our weather module, we also need to apply something like this to our getWeather function inside of our Flask server. So let's go to the server.py file. Here's our getWeather function, and we're getting the value city from the arguments, essentially the parameters sent in the URL. And so after we get city, this is where we would need to check. And I really want to put in the exact same code here that we used in the weather module to check for that. So I'm just going to copy this that I put in on lines 23 through 25 with Control C, go back to the server.py, and I'm going to put this code right here. So that is once again going to check for an empty string. After that, we're going to get the weather data from the API. But what if the API does not find the city that we pass in? What if we pass in some strange name? That could also be a problem. Let's go back once again to our weather module, and let's run this one more time, and I'll just put in a random string that I know is not a city name. So when it says enter city name, I'm just going to put in something strange like that. Let's see what we get back. Notice we get a different object instead of that JSON weather object. Now we get an object that has a code of 404, which means not found, and a message that says city not found. Likewise, if we would run our app here one more time, just this weather module, and I type in a name, or I'll just press enter so we get Kansas City information, we notice inside of our larger weather JSON object here that there is still a code right here. The code is 200. That means successful. So we could look for a successful code of 200 to know that our request has succeeded. Now there's nothing to fix in our weather module. It presented the object that was returned just fine. But inside of our server.py file, we actually need to handle that in case we don't get the object that we expect, because then we would get an error here as we attempted to get the name and the different weather values from the weather object if we did not have a weather object. So to handle this case, I'll put one more note underneath here, and I'll say city is not found by API. And in that case, we'll say if not weather data, and then we'll look at that code value. And notice it doesn't have an E at the end, but it's abbreviating for code. Then it looks like COD actually, which is kind of funny, but nope, it is for code. If it's equal, or this is if it's not equal to 200. Notice 200 is not a string because that object didn't provide a string, it provided the number. So if our weather data code is not 200, then our request has not been successful and we will not have the weather data we expect. So in this case, I want to return a message simply saying city not found. Now we could do this just like we did with hello world and say city not found. And I'll save this for now, but instead let's create one more template to handle that. So in our templates folder, I'll just click on index.html and then the new file icon, and I'll call this city-not-found.html. And now I'm going to go to the index.html file and press Control A to select all and Control C to copy. From there, I'll go back to the city not found file and press Control V to paste everything in. Also Alt Z so it wraps down. Now there's not much to change here, but I'm going to change the title. And once again, after selecting Get Weather Conditions, press Control D so it selects the second version of that, which is down below in the body of the page. Here I'm going to type City Not Found. After that, I'm going to put an H2 underneath City Not Found in the body and just put try again with a question mark. And then we'll once again leave this same form so the user isn't stranded on this page. They could once again enter in a city name. Maybe they just had a typo. So this will be our city not found page. So after creating this template, Let's go back to the server.py, and now we can render that template here instead of the city not found string. So I'll have render underscore template once again, and now we're just going to pass in the city-not-found.html file. Now with this new code in place, we should be able to handle those possibilities, those edge cases as we would call them, inside of our web app as well. So if our files are saved, let's open the terminal once again, and we want to run the server.py file. So I'm just going to press play here and run this file, and we can see it's running here. Let's go back to the browser and check it out. So we had an internal server error before, so I'm going to remove everything that came after the localhost 8000. Now press enter, and it should once again reload the app. I'm ready to put in a town or a city name, so I'll put in Austin, press enter, and yes, it's working like expected. So now if I just press submit without entering anything, we get the Kansas City weather because that's what I put in for default. And if I put in some random characters that don't make any sense and press enter, we get our city not found template, and it says try again. So I could try again. I'll enter in many spaces, which actually has no content whatsoever. Press enter. And once again, we get the Kansas City weather. So that's really what we wanted to do. It handles those. And notice up here, the city equals value, when I put in all the spaces, is represented as plus symbols inside of the URL, which is a little interesting. Let's go ahead and enter something else. It's just blank. And then notice it's just city equals and nothing comes after it, but we still get the Kansas City weather. And now with our code feeling like it's complete, it's ready to deploy to the web. I'm back in VS Code, and now we're going to work with Git and GitHub. And if you're not familiar with Git and GitHub, you may want to stop the tutorial now, learn about those before you try to proceed and deploy your web app, because I'm not going to go into all of the details of how they work. I'm just going to show you what I do, because this is not a Git or GitHub tutorial, although I do have those on my channel. Okay, so here we've already initialized our Git repository earlier in this tutorial. Now with it initialized, I see some files over here, meaning they're new, they're green in my file tree, and I'm getting ready to add those. But I'm also looking at my file tree going, hey, this PyCache folder has been created. That happens when we use modules, we import modules, then it just caches some things to work more efficiently. But we really don't want to send that to GitHub either. So let's once again go to the git ignore file, and inside of there, I'm just going to list the 2 underscores, PyCache, and 2 more underscores, and save. And now that is also not going to be sent to GitHub with our Git repository. So once again, it's already initialized. So now I just need to add the files to the repository. So I'll say git add and type a period. That means all. So I'm going to add all of those files. Now I'm going to commit the files to the repository. So I say git commit -m for message, and I'm going to say first commit. Press enter. Now all of those green files turn white in my file tree, and they have been committed to my repository. Now they haven't been sent to GitHub yet, so we need to go to GitHub and create a repository to send them to. Okay, I'm on GitHub and I have an account here already. If you don't, you'll need to create one. And then I want to click New for a new repository. Now I have a paid account because of my job. I need to be able to do several things that only a paid account can do. However, if you have a free account, you can only have public repositories, I believe. However, I'm going to set mine to private because I'm just going to use it for this tutorial. So here I'm putting in the repository name, and I'm going to put in Python-weather. And so you could name yours whatever you want to. After that, I'm just going to scroll down and create the repository. After it does that, it's going to give us this page of instructions. And I'm really only interested in this part that says, or push an existing repository from the command line. And that's what we have back in VS Code. We have an existing Git repository. So I'm going to copy, just by clicking this icon here, all 3 of these commands, and then we'll go run those commands inside of our terminal in VS Code. Okay, I'm back in VS Code. I'm going to type clear first here in the terminal just to clear everything else out. Now when I right click, it's going to run the first 2 of those 3 commands, and it's going to wait for me to press enter on the last one. So I right click, runs the first one, it runs the second one, and now it's waiting for me to push, this is a git push, the repository here on my computer in VS Code to GitHub. So when I press enter, that's exactly what's going to happen, and it quickly sent those files to that GitHub repository. Now I'm back in the browser at the repository. I'll click the repository title here near the top left, and we can see these files are now in the repository at GitHub. So now we want to go to render.com, where we're going to deploy this web app, and it will pull these files from our GitHub repository into Render on its own. We can set that up. So let's go do it. And now I'm at render.com. If you don't have an account here, you can sign up for one for free. I'm already logged in, so it is just showing me the dashboard button. I'm going to click that dashboard button, and now I am logged in, and I can go ahead and create a new web service, which is what we want. So by creating the new web service, it's going to give us a list of our connected repositories. Now I have connected my GitHub to my account, and you could do the same. If you don't see it, like it's offering to connect GitLab, which is another service like GitHub, to my account as well. So you might see it over on the right if you're not connected. So I'm connected, and now I immediately see my Python-weather repository because I just created it 2 minutes ago. I'll click the connect button, and it will start to pull the code in from GitHub, and now I can set up my web service or my web app here inside of render.com. I'm going to name this the same thing, Python-weather. I don't need to change the region. I'm on the main branch in my repository, so that's fine. This root directory is optional. I don't need to change that. We will be using Python 3, and we have been using Python 3, so that's fine. Where we have the build command, pip install -r requirements.txt. That's good because we do have a requirements file, but we might also want to update pip, as we have had some notifications about pip before needing updated. So let's go ahead and put in pip install, and we only need 2 L's there. Then I need -u, capital U, for that upgrade, and then pip, and then 2 ampersands, and then it can do the next command, which would be our requirements.txt. So I just want both of those in there. Now as we come down to the start command, here our start command is going to be Python 3, and then we're going to run our server.py file. But we're not quite finished yet. Let's scroll down just a little bit further. We're using this free instance, which is fine. But as we scroll down, we need the advanced because we're going to add our environment variable. Remember, we have an API_key in our .env file in development. We need to take the value of that and put it right here. Back in VS Code, I'll close the terminal and click on my .env file. Here's my current API key value. Control-C to copy that. Let's go back to that dashboard, and we can put it in right here. But we also need one other environment variable. And no, we did not have it in development, but Render needs it. Render needs to know what version of Python we have been using. So we'll say Python version. And now, if you remember how to check your Python version, you could do that and put it in here. If not, let's quickly do that for you. So back in VS Code, let's control in the backtick to open this up. I'm going to just type Py, lowercase once again. If you're on Mac or Linux, type Python 3, I believe. But after that, you need --version. And then when I press enter, you can see I've got Python 3.11.2. You want to enter in whatever version you have been using. So here I'm going to put in 3.11.2. And remember, I am going to change my API key value. So don't try to use mine. Make sure you go to openweathermaps.org and get your own. Okay, now that we've entered everything, I believe we're ready to scroll down here and create web service. So let's click that. It will start to deploy, and it will give us quite a few messages here in this window. I'll come back when it's finished. I'm back, and Render says your service is live. So that's what we wanted to hear. Let's scroll up, and we can see our URL for our Python web app right here. It's at python-weather.onrender.com. So whatever you named your repository or your project here in Render is probably what's here before .onrender.com. Let's go ahead and click the URL, And now we see our web app is actually on the web and you can share it with your friends. Let's go ahead and enter in another city name here. I'm going to enter in Santa Fe, press enter, and there's the weather tonight. It's getting a little chilly in Santa Fe, maybe a warmer destination like Houston, and press enter. And yes, the Houston weather is much warmer. It feels like 95 right now. So everything is once again working. We can even check out not entering a city, and I get Kansas City, depends what city you put in for yours. I'll enter in something that doesn't make any sense, and of course that shouldn't be found, and we get our city not found template. So I'm happy with the results here. I hope you are too. And moreover, congratulations on completing the Python for Beginners course and on completing this project.